making surveys and engaging local communities, stakeholders, and local and international universities. Also, economic diversification by contributing to ecotourism, and promote cutting-edge research and innovation by involving local and international universities and research centers. The center objectives in preserving wildlife ecosystem, first by implementing a baseline information assessment to fill the gap knowledge regarding the marine and terrestrial ecosystem and help us to collect more data to see the areas in urgent need for rehabilitation, develop and enhance research and infrastructure using the best global practices and the best technologies and monitoring systems, breeding of and some seabird species. In the Saudi waters, we have 10 different species of whales. Not all of them are endemic to the Red Sea or the Arabian Gulf, but they come over a seasonal cycle to settle there. Although our knowledge is still limited about these organisms, but we still cite them a lot during our surveys. In this list, I'm presenting rehabilitation of turtle nesting area in the marine protected areas and in the Arabian Gulf, a review of shark and ray fisheries in Saudi Arabia and their interaction with natural fisheries, also assessing the trends in non-native species in Saudi waters and preparation of biosecurity plan, inspection of Saudi waters for compliance to environment initiative. It's a scientific initiative aiming for increasing our knowledge about marine habitats in the Red Sea and their biodiversity. The expedition was launched and led by the National Center for Wildlife together with 8 participating institutions. And during the expedition, we covered more than 70,000 square kilometers of the Red Sea during 126 days of sailing on board of 2 vessels, Ocean X and Al Azizi. And during the expedition, we surveyed more than 3,000 square kilometers. We conducted aerial surveys and more than 44 submarine and submersible trips, more than 133 ROV trips, and the expedition involved 135 research and scientists. During the expedition, we also collected more than 800 samples for biodiversity, more than 150 samples for live corals, and more than 235 samples of core sediments collected from the bottom of the sea, and more than 2,000 samples for eDNA or environmental DNA. And right now we are at the analysis stage. I mentioned our project, which is assessing the health status of marine habitat and biodiversity. And during this project, we covered different habitats, such as coral reef in the Arabian Gulf and marine protected areas, seagrass, mangrove, and megafauna in the Saudi waters. And the aim of this project is to fill our knowledge gap and to have a baseline assessment. It will give us information about areas in urgent need for conservation, and it will help us in managing and conserving our habitats in Saudi Arabia. Another project is the rehabilitation of marine species and turtle nesting areas in the marine protected areas and in the Arabian Gulf. And the aim of this project is to remove solid wastes from islands and coastal areas. We visited more than 30 sites during 45 days, and we removed 13 kilograms of solid waste, such as plastic, glass, wood, rock metals, and fishing tools. The first table represents the waste collected from Farasan Bank, and the table at the bottom represents the waste collected from Farasan Islands. Another project is the review of sharks and ray fisheries in Saudi Arabia and their interaction with fishing activity. And we visited fishing markets during fishing activities, and we collected data on the bycatch of fishes and rays. This will help us in collecting more data, and during the survey, we developed relationship between our team and fishermen, and that will help us in raising awareness and teaching them the best practices for fishing and what species are endangered and need to be preserved. Another project is assessing trends in non-native species in Saudi waters and preparation of a biosecurity plan. Well, I will not talk about this. I just want you to stay tuned because Professor Susanna Carvalho from KAUST is going to go in depth through this project later today. I see the red flag, so I just go quickly. We also have another project, inspection of Saudi waters for compliance and environmental and wildlife regulation. We inspect the boats for illegal fishing or any illegal activities in giga projects, and also we collect data that will help us in support the research and development in marine environments. And this map shows the distribution of our inspections boat and the area that they cover. For the marine protected area, the aim is to develop and expand marine protected areas and terrestrial protected areas in alignment with the vision of the kingdom in 2030. So our goal by 2030 is to achieve 30% terrestrial protected areas and 30% marine protected areas. As part of our environmental awareness and community partnership program, it's include education for school, cooperation with universities, and conducting campaigns for community awareness in public places, engaging the local community in the rehabilitation, the relationship with the local community and fishermen to educate them about the best fishing practices. Thank you.
Thank you, Dr. Iman. She was explaining about the NCW's efforts towards the management of marine resources. I think we have time for 2 questions. Please, here.
Good morning, everyone. Thank you for the nice presentation. My name is Khalid Naboud. I am going on my question on technical. I don't know if you can answer me. You have mentioned you did an aerial survey and you have used drone. We saw some. So which sensor did you use?
Well, I think this question is going to be answered by engineer Omar Abuniyan. He has a talk later today.
Okay.
He can address this question.
Okay, great.
Sorry.
Okay, thank you.
Thank you for your informative presentation. My question is regarding the marine commercial fish stocks. You know, some of the fish stocks, for example, hamur, orange spotted grouper, Epinephrys coides. KFUPM in our study also, in general, IUCN, it is enlisted as overexploited species in Saudi Arabia. So it is going to be overexploited, and it is one of the most commercially important fishes for Saudi Arabia, you know, that hamur. So do you have any program to enhance their stock in the wild? Because there is no further scope, you know, natural enhancement, because already degradation or exploitation is there. So in this case, do you have any program to release? Because hatchery technology are already available for this fish, okay? Do you have any program like stock enhancements through sea ranging like this?
Yeah,
Thank
we
you.
do have some project for rebreeding of this species, but we are still at the developing stage. It's so important, actually. This is one of the most important projects that we have in the National Center for Wildlife.
Doctor, very good presentation. Actually, you have one question. On one of your slide, you mentioned the entire Red Sea coast. You just monitored the occurrence of seagrass ecosystem. So that much area, it is a huge area actually. So which method you used? The ROV or some other with the aid of divers? Or
So we used drones and we used ground truthing. And we visited so many areas in it was more than 130 sites along the coast of Saudi Arabia. And we have another ongoing project in the Arabian Gulf. And the main technology we used, as I told you, is drones and ground truthing.
Okay, thank you, Doctor. Thank you very much.
Let me ask one question about what are the efforts of NCW for making any repository or depository for organisms in the marine environment?
Well, this is also one of our ongoing projects. Right now, we are collecting a baseline because our knowledge is still limited. And if you went to literatures or studies, you can see the list or organisms or the biodiversity and marine habitat are site-specific and limited to certain areas. So our first step is to conduct a baseline assessment to know what we have, to make the list, and to know the areas that in need for rehabilitation, the endangered species that need restoration or breeding.
Thank you so much. We'll discuss further about that. Once again, that was a wonderful presentation, Dr. Iman. And we move on. Next presentation is by Dr. Thamban Meloth. Dr. Thamban Meloth, I know him personally. Dr. Thamban Meloth is the director of the National Center for Polar and Ocean Research in India. That is one of its kind in India. And Dr. Thamban Meloth led and participated several programs in the Arctic and Antarctic ocean research representing India and other countries also. Dr. Meloth has been awarded many recognitions like the prestigious National Geoscience Award by the Government of India, as well as several national and international awards. He also represents India at the International Arctic Science Committee Council, Scientific Committee on Antarctic Research, and Council of Managers of National Antarctic Programs. With this short introduction, let me invite Dr. Thamban to deliver his presentation. Dr. Thamban, please.
Thank you, Dr. Joydas, for that introduction. And thank you, the organizers, for inviting me all the way. And some of you must be actually wondering what a polar researcher or an Antarctic and Arctic person is doing in on a conference which is essentially related to sustainable development in the Kingdom of Saudi Arabia. In the coming few minutes, I will just try to impress upon you the importance of these regions for other parts of the world. And it's also obviously very clear in 2024, the Kingdom of Saudi Arabia also become a party to the Antarctic Treaty. And in 2025, the United States Arab Emirates also joined the Antarctic Treaty system. So that shows the kind of the awareness as well as the importance of these regions hold to our future. So if you look at the region, you know, typically when you look at the Mercator projection, you don't see Antarctic or even Arctic for that matter. We see it's all actually as a place which is navigable place from the places where people live. But there are places which are, for example, you look at this large continent like Antarctica, which is the size of the United States and India put together. Such a huge continent, of which 98% is covered by ice, with an innumerable diversity than what you imagine, especially at the microbial level and other species which are not seen in other places. And a place which holds importance as well as critical for going to be the future of the whole planet. So I am basically representing this National Center for Polar and Ocean Research, which works under the Ministry of Earth Sciences in India, where we started the research into Antarctic and Arctic several decades back. And if you look at these two regions, we call them as cryosphere, where all water is frozen form. There's the continent sitting in the south, in the southern hemisphere, which is surrounded by the ocean. And then you have an ocean surrounded by the land on the north, we call as Arctic. Mostly it's the sea ice, that is frozen sea water. But also there are some islands like Greenland and Svalbard and so on. And these regions are completely different in every aspect, because the way they connected to the land, because Arctic have people living, the indigenous population living there, Antarctica does not have any population. Antarctica is governed by a treaty system, which means it does not belong to anyone. And it is managed by the consensus by the treaty parties. There are about 57 treaty partners to Antarctica. of which 29 are the consultative parties. Whereas Arctic is mostly sovereign, part of the sovereign nations around that region, and is also kind of a management system which we call as the Arctic Council. Why we need to talk that today is about, as the globe is warming, global warming is something very common, what we talk about almost every day. But the most important fact is that as the globe is warming, it is not linear system. It is not linearly warming everywhere. The Arctic, especially warming nearly 4 times higher than the global average, and some part of Arctic even by 7 times higher than the global average. So is some part of Antarctica. And this non-linear, or what we call as a polar amplification, has to do something with essentially because everything on this earth happens with the solar radiations as energy. As the energy distribution is different parts of the world actually, so there's Antarctic and Arctic has been cold for a long time. But as ice start melting, it also becomes, normally it's a white body and start becoming a black body. So it start absorbing more and more. It's a kind of a feedback system. And then there are other factors which contributing to this place becoming more and more, warmer and ultimately losing large part of its ice. So if you look at the Arctic, for example, more than 50% of the sea ice has been already lost. It has relevance. This I will come back to this point. This has relevance to places like the tropical places like even Saudi Arabia or the Asia and so on. As the sea ice has been retreating quickly and very fast, it's been all the more during summertime, and it is expected by 2040 or so, the Arctic is going to be sea ice free during the summertime. It has a huge implication, not just in terms of the Arctic, but how the global climate system works, how the tropical climate system works, especially the intertropical convergence zone, which actually controls large part of our weather systems, how it's going to affect the global food security, because you will have more the food available, the fisheries available during in those regions. There will be more the possibility of getting more petroleum reserves in that region, and it can also, most importantly, going to become a highly geopolitical and strategically important area as the Northern Sea route is expected to open up. And this Northern Sea route could change the way we look at currently the global order, probably also implying the reason why people like the President Donald Trump has been talking about buying Greenland. The whole perspective is about this, the future strategy as it changes in the Arctic warming. So it's not all about just his wishful thinking. It has a very strong strategic reasons to it. So if you look at the Antarctica, for example, a large part of Antarctica, which is actually, as I said, it's a continent. Unlike Arctic, which is a sea ice, Antarctica is mostly land ice. Ice which can actually contribute nearly about 70% of global fresh water is frozen here as Antarctic. And you can see that in the West Antarctic is already melting quite a large part. And it's already contributing to a sea level, because currently the sea level increase is due to the thermal expansion or to the added water, the water which comes from these glaciers and ice sheets. And as it's increasing the global sea level, by end of the century, we are going to have at least an increase about 0.5 meter of sea level increase, which will have a significant impact on people, the coastal areas and small island nations around places like, especially in tropical region. Again, the sea level impact of glacier melting is non-linear. Where it melts, it does not contribute so much to the sea level rise there because of the isostatic rebound. But it adds more to the sea level, places like tropics and subtropics regions. So again, we should be more worried about what happens to the polar region than people who are living there itself. So why do we care? That's the question actually. We live in a place hugely remote from that region. a place which we are more worried about the heat waves and other things, the rainfalls and so on. But if you look at this particular slide, you will find that the impact of especially polar warming has a huge differences in what happens in atmosphere, the amount of precipitation, the rainfall you get, the loss of ice on the mountains, and how it controls the water budget of the rivers in the downstream, the happening of more droughts and wildfires existing, and the thawing of the permafrost. Permafrost is nothing but the frozen land in many parts of these high mountains and the polar regions. As they thaw, it affects the structures and buildings and roads, and as well as the living way of the people live there. We also have a warmer ocean, as we are already aware about, which impacts the wildlife, the marine wildlife. And rising sea level is already one factor which I mentioned. But actually, there can be more heat waves. There can also be more cold waves during winter, but there can also be more increasing heat waves. And ultimately impacting the food security of the entire globe. It's a globally connected world as far as the atmosphere is concerned and the oceans are concerned. So if you look at the global warming, which the scenarios which mentioned, 1.5 degrees Celsius could trigger a multiple climatic, what we call actually, the tipping points. A tipping point is one which beyond which there is no coming back. Once there's something lost, it's lost. You cannot get it back. And of which, the three stars which I put are one in the Greenland ice sheet, one in the circulation in the North Atlantic, one in the West Antarctic ice sheet loss. These are actually can happen even just this 1.5 degrees Celsius. And you must be aware, we are pretty close to it. Already in 2024, it's been considered actually about this 1.5 degrees Celsius actually, although it cannot be considered as a long-term average of it, but we are pretty close to it. So things are going to be very different in the next generation. In fact, even by the time many of us actually reach our end of our life, the things are going to be very different world than what we see. Even the places like Sahara and Sahel is going to be more greener, as the greening is happening, because you must be seeing the kind of the unseasonal rainfall, extreme rainfall sometimes happening in the places like the desert regions, which just cannot hold the water. That's going to be again impact the way the place is living. And warmer Arctic especially can drive extreme weather. You must have seen here this year in US, for example, there are extreme cold waves coming, sweeping all the way down south. We also have heard actually many times actually things changing, even the heat waves reaching Arctic. This is all because ultimately the way the Arctic and Antarctic is actually within the climate system exists actually, it's been very kind of a huge vortex around this Arctic and Antarctic region, which separates the tropics and subtropics from the polar region. As under normal circumstances, there is a strong jet stream around this region which separate these places. But as the Arctic warming more and more, you will have this meandering, sagging around, going sometimes down south, sometimes from south reaches to the north. So this is going to be a common phenomena we are going to hear more often now. For example, in Antarctica, in 2022, in one single day, a temperature increased by about 38.5 degrees Celsius in one place. It's again, we call actually something called atmospheric rivers, like the rivers on the land. You also have this huge amount, thousands of kilometers long, moisture-rich, warm air mass we call as atmospheric rivers. It crosses the boundary, what we used to call actually Arctic, so the vortex, the polar vortex. You can have in few days such a huge difference in temperature, which is going all the way from tropics to these polar regions. So as it happens, it can also finally impact the way, because actually the more and more actually this kind of atmospheric rivers are going to reach these regions. ultimately it can impact the ice shelves, which are nothing but the floating part of this coastal Antarctica, where these large ice sheets start moving into the ocean and where they start calving, forming icebergs. So this floating part we call actually as the ice shelves. These are we call actually, they are the belts for the ice sheets, which means if they become weak, the entire ice sheets start moving. It's a kind of provide a kind of a stability to those ice sheets. You see now, 60% of those ice calving events or the ice breaking events are during at least the last 20 years have been directly related to this atmospheric river reaching those places. So in any warming, even looking at the future warming projections, and increased events of the atmospheric rivers reaching Antarctica is considered to be impacting the disintegration of Antarctic ice sheets. So it does not look like so seemingly far away from our world. So what happens in the Antarctic and Arctic does not stay there. It impacts our life. For example, one large extreme precipitation event in India, for example, in way back in 2013, as well as actually the later recently in a few years back, is been found to be directly related to the Arctic sea ice melt. So that tells us actually why should a country which actually have larger issues to solve around your own doorstep should be worried about what happens in that part of the world. So if you look at even some of the large floods happening, we had especially a couple of larger floods happening even in the Himalayan belt in India, was found to be influencing what happens in the Canadian Arctic in terms of the snowfall and other things. So these systems it's not only one way, it's not a one-way street, it's a two-way street. So the link between poles and tropics have been informed earlier, but it's becoming more and more clear, more and more obvious, because earlier it was more of an academic exercise. Now it's found to be more an important area of one thing which we should be worried about, because some of the studies clearly shows that there's a substantial portion of even Arctic warming may be even directly connected from the tropics. That means we could be influencing what happens in the Arctic and vice versa. And the Arctic sea ice also could lead to increased tropical sea surface temperature, which we have seen in the Indian Ocean is warming much higher than the rest of the world, and leading to several things which we have not seen in, for example, in the Arabian Sea, for example, you have not seen so much of cyclones in the past. We keep hearing now more and more cyclone hitting in this particular part of the world. And that's going to be more increased because as the ocean is getting warmer and warmer, it's providing a lot of additional energy to it, the cyclone to become bigger and bigger and bigger. Then you can also have increased precipitation in the tropics. This is something which we should be in the unseasonal rainfall. I was talking about the extreme precipitation I'm talking about. And there is a potential possibility of, there is already, the models clearly show there will be a shift in intertropical convergence zone, which controls most of the climate of this part of the world. So for example, these teleconnections have been discussed in terms of, as I mentioned, it's a two-way street. The primary mode of this signal transfer from the Arctic to the tropics are the atmospheric, the large-scale planetary waves we call as the Rossby waves, which are essentially guided by the jet streams. As I mentioned earlier, actually, there is a huge jet stream around the Arctic vortex. And as the vortex is shifting, you can also it can change the jet streams, how they behave. And for example, in case the Indian summer monsoon or the Asian summer monsoon, which gives the rainfall to the large part of this part of the world, can generate highly anomalous highs, and it can carry forward actually these particular systems to all the way to the Arctic region. And sometimes, due to some reasons, such as the jet stream, in the North Atlantic get affected, it can also excite a Eurasian, waveform, the wave train ultimately can impacting because once the Eurasia region get affected, you can impact the climate system. So the Arctic can impact the monsoon systems, and it can also impact the mid-latitudes, especially the mid-latitude summer circulation, because it clearly shows that there is an interaction between the Arctic teleconnections which lead to persistent hot, dry, the extremes in the mid-latitudes. Although these things are not very completely purely known, but it's more and more becoming obvious and known these days because there are increased studies, because ultimately people realize now the importance of this to our part of the world. For example, this one particular study from our institute clearly shows there is a relationship between the Arctic sea ice melt and late season Indian summer monsoon rainfall, especially the extreme rainfall. And this increased extreme rainfall events in central India especially seems to be coinciding with the episodes of this reduced sea ice in this Arctic. And there are multiple reasons and the mechanisms to it, which I will not get into the detail here. And as we also see that there is an intensification of Arabian Sea cyclone, which I just mentioned a few minutes back, has a potential association to the Arctic sea ice melt. There is a clear intensification of, if you look at what we call actually as the potential of this formation of more cyclones has been increasing since 2000 in Arabian Sea. And this intensification of cyclones over the Arabian Sea is concurrent with a positive phase of warm Arctic, cold Eurasia, because, this system. And it's also, find to be that the upper atmospheric circulation associated with this particular phenomena, especially when it's in positive phase, induces meridional gradient within the subtropical jet, finally intensifying the anticyclonic circulation over India and reduces the vertical wind shear, ultimately favoring the formation of the intensified cyclones, what we see in Arabian Sea more and more these years. And areas which was not affected by cyclone could be affected in the coming decades and coming century at least. This is on a longer time scale. There have been clearly studies showing that. I mean, further back in times, even when the time period which was seemingly are exactly an analog for the modern world, where we have about 420 ppm, the carbon dioxide, that kind of scenarios we call actually as a mid-Pliocene warm period, nearly about 3 million years back, which is considered to be an analog for what today. That's exactly they find a lower Arctic sea ice lead to a stronger South Asian monsoon system. And that means this is something as proven through the long term as well as what we see in decadal and in interannual to seasonal level. So the home message from my side is that actually as the globe is warming, it's becoming more and more, the relationship between the tropics and polar regions becoming more obvious. Because the warming is much more several orders higher in those regions, and that imbalance is adding to what happens to the tropical region. So the polar regions are deeply connected to the global climate, the sea level of course, and even the tropical climate. And it could increase the sea surface temperature, as well as the areas which I mentioned, like the changes in the intertropical convergence zone, and the precipitation and so on. So therefore, they may be seemingly very unrelated and remote from our world. Here we have activities in Svalbard, and we increase that activities to the Canadian high Arctic, as well as the starting from this year and also increasing to the Greenland and the Arctic Ocean expeditions and so on. So that's how, that's the institute where it's situated in Goa. These are the stations which I was talking about in Antarctica. And these are the stations in the Arctic in Svalbard I was talking. And that's just finishes my talk. Thank you so much. And once again, I just want to impress upon you that actually, probably I tried to inform you that what happens in this part of the world have importance for even for the people who are basically talking about actually what happens to the places like Saudi Arabia, because ultimately this is a connected world. It's one earth. Thank you so much. Thank you for inviting me.
Thank you, Dr. Tampan, for the wonderful presentation. I think I don't need to tell any comment on that one, but I expect some questions from the audience.
Thank you so much. This is Dunya Abdelwahed from UNESCO office in Doha. I just wanted to share an information or a small comment. So this is why exactly I'm very happy to see this presentation here today as part of the conference, because this year has been proclaimed by the UN General Assembly as the International Year for Glaciers, and actually 21st of March will be the World Day of Glaciers as well. And there will be also an international report, a global report of the World Water Assessment Report, which will be also dedicated to glaciers. So thank you so much for this insightful presentation, and I think it contributes greatly to raising awareness on this issue.
Thank you. I think exactly, I just forgot to mention that actually because that's the awareness it is reached to the UN Assembly as well as the World Meteorological Organization, so on. And especially the cryospheric hazards, the hazards related to the melting ice, found in mountains, found in the frozen lands and so on. That's increasing dramatically. That's something which we need to be worried about.
Thank you very much. That was a wonderful presentation. I have a question, if you allow me to engage the previous presenter also, Dr. Ayman. My question is actually, what is the impact of climate change in the Arabian Peninsula on biodiversity?
Apologies, actually, I'm not the right person to answer that. I think Dr. Iman was, I think you should have asked this question to her, and she was giving a very clear, details to it.
Yeah, that's why if you allow me, if she is available, I want to engage her also.
You missed the train, I suppose.
Okay, thank you.
Definitely, you will get a chance to meet both of them later, and you will have a very good engagement afterwards. But any other questions, please? Yeah, I think there are two questions from that side.
I am a research engineer working in ARC-MST. My question to you is that you mentioned that the melting of the polar ice could cause SST increase. So by logic, I was assuming that probably when the ice melts, it's going to be an immediate lowering of the temperature on the SST. So how can you justify that, please?
You're talking about the SST in the where the ice melts. What we are talking about actually what happens in the tropics, because that ice by melting, by the time it reaches the tropical regions anyway, it's become normal water. What happens is actually what happens to the two way. One is actually the atmosphere systems actually changes, which impacting the ocean atmospheric interactions, which is different than what you're thinking about actually, that water contributes as the ice melts. These are quite a long the physical phenomena. Actually, there is a lot of papers on this actually. So I will not like to get into the, in fact, I can't say that even I'm an expert to that actually to give the mechanism of the details. Actually, it's more of connected to the, what happens in the polar regions impacting the mid-latitudes, especially Eurasian region, and then the circulation system finally impacting what happens in the upper ocean region, and finally leading to an increase in sea surface temperature. These are two different things which probably we are talking about.
Okay. My colleague has another question.
Yeah, good morning. Very nice presentation. My name is Muhammad Rizwan Ali. I'm a researcher in research and innovation. You have said that the global warming and other impacts in the rainfall and flooding of the desert kingdoms like Saudi Arabia and UAE. I would like to ask you the impact of the cloud seeding, particularly. The cloud seeding is a major contributor in rainfalls in the desert kingdoms. So I would like to have your input on that.
Of course, it's a controversial topic to be answered by me. But I will just say as an example, actually just met in last September, actually the president of WMO, which is actually the director of the National Center of Meteorology in Abu Dhabi, it's UAE. So we had an opportunity to visit their institute and actually to discussing these topics. So they have, I think probably at least what the flood which you saw in Dubai and that one has nothing to do with that, because they never had any seeding at that particular, cloud seeding at that particular time. Although cloud seeding is an important and very useful for the management of especially desert regions like this part of the world. It's been hugely successful. I would say actually I've seen that kind of success rate actually what UAE has on that. And I would say that is something which that's going to be the future anyway. And connecting that to the flood happened actually is not correct. I think there are a lot of scientific studies clearly shows that it has nothing to do with that. And there are real natural reasons actually why that ultimately happened. So I do not think what you said is correct. Yeah, I'm not sure more details to it.
I'm not exactly connecting the flooding due to the cloud seeding, but what I'm trying to say is the impact of the global change or the melting of ice having the rainfall effect on the desert kingdoms. If there is no cloud seeding, would that impact the same way as we are thinking that the melting of ice and the weather patterns are affecting the rainfall in the desert kingdom?
Yeah, so as far as the cloud seeding is concerned, you need to have clouds which are rain-bearing clouds. Otherwise, you can't do the cloud seeding part. That's the complete, the all scientific aspect of cloud seeding. And as far as what I was talking about, actually, this is other thing which I'm talking about more natural, which is actually happens because of this large-scale transfer of energy and momentum to the tropics because of what happens there. That is probably, that's again I was talking at with the WMO president actually. So that's one reason actually why UAE becomes so interested in joining the polar studies. They finding that there are many studies now shows that potentially some of their extreme rainfall have something to do with what happens there. So these natural things, what happens actually due to the warming to the polar regions, probably going to increase. And we probably can't do anything about it. Cloud seeding is a completely different area of study itself. Thank you.
Okay, thank you. Thank you.
Thank you so much, Dr. Tampan. There are scary facts always. It will alert the entire world. So he was telling about all these things. So we will move on. Next presenter is Dr. Susanna Carvalho, and Dr. Susanna Carvalho is also one of our collaborators of our center. Dr. Susanna, she is a senior research scientist and associate professor in the Red Sea Research Center, KSA. She moved to KSA from Portugal to work on a proposal for a research program with Saudi Aramco that was later named Saudi Aramco KSA Chair of KSA. With these few words, let me welcome Dr. Susanna.
Present some of our results that we are conducting at KSA and particularly in my research group. I would have been working with several stakeholders from NEOM to Saudi Aramco, as mentioned, but in this specific program, not only in KFUPM, but Dr. Ima in National Center for Wildlife and the whole team, and also some colleagues at KAUST. Some are here, Dr. Mark Dimek, and he will talk in a little bit, so stay tuned. And my research focus, since I came to Saudi Arabia in 2012, so I've been here for more than 12 years, has been on marine biodiversity. And marine biodiversity is critical in the sense that it's clearly connected with human well-being. So protecting marine biodiversity also means that we are protecting the livelihoods of millions of people around the world. So unfortunately, we know that we have been assisting to a huge decrease in marine biodiversity, and this has been linked to 5 major pressures from habitat modification, ocean warming, pollution, invasive species, and overfishing. Today, I'm going to focus mainly on the efforts that we have been doing regarding the biodiversity and specifically the invasive species and the fate and distribution of contaminants, as well as the response of Saudi species to environmental stressors. As Dr. Iman said, one of our major projects right now is with National Center for Wildlife, and we have been asked to provide a very detailed report on the status and trends of the presence of marine invasive species in Saudi waters. This is something that we have no idea about yet, but we know that from elsewhere that marine invasive species can have severe economic impacts, particularly in fisheries and aquaculture, but also can have impacts on human health. So we start to acquire fundamental knowledge that we were missing in the kingdom to try to translate it into actionable action so that we can safeguard the status of marine ecosystems in Saudi Arabia. So we use a combination of approaches that go from modeling, trying to understand the ship traffic, and we know that this is one of the major vectors for the introduction of non-indigenous species, so species that are not naturally from these areas, and fieldwork surveys, intense fieldwork surveys with standard methodologies that have been applied, namely in the US and Australia and New Zealand, 3 of the countries leading these efforts worldwide. And also using new tools, namely molecular tools, to help the early detection of these species and to support the prevention and the quick action to avoid them to spread in the marine systems. We have been focused in this project in artificial habitats, ports and marinas, because we know these are the critical hotspots for the presence of invasive species and then the stepping stone for them to go to natural habitats. For you to have an idea of the size of this effort, we have conducted integrated surveys along the Red Sea and the Saudi waters in the Arabian Gulf, including 22 sites in the Red Sea and 12 in the Arabian Gulf, and trying to cover the whole geographic extension of Saudi waters. We also did a seasonal collection because we know that some of these species can be more prevalent in different seasons. So we collected samples and we did these surveys in 2024, in February, May, August, and November. Doing this, we will also be able to try to understand in the future for a national monitoring program, what is the season, or what are the seasons that are more relevant, so that we can make our resources more valuable and do not waste, we don't want to waste time and resources. Hopefully, this is an effort that will continue, but right now we have put this on hold. Hopefully, we will get back to this long-term monitoring. So for you to have an idea of the intensity of these surveys, they include water collections for molecular analysis. So for those that have probably heard about eDNA, environmental DNA, we collect waters in this case, but we also collect some sediments at some point. And basically using probes, we will assess the presence of the species that are in a certain sample. And this can be native species of the Red Sea and can be non-native. And we deploy these, the second photo is actually a brick that is now colonized with a settlement tile that you see in the third panel. And this is a PVC tile of certain dimensions that is exactly the same tools that are being used for the monitoring of invasive species around the world. So we can also compare our results with what others are finding elsewhere. And we also scrape artificial substrates in these ports and marinas to try to understand what is the colonization. So what are the communities that are already living there and surviving there? And finally, we select organisms from different species, and we take photos of these organisms, and we identify them with morphologically, but also with molecular approaches. So we kind of have their barcode, that unique signature that we can use later for improving the accuracy of our molecular-based assessments that are faster and easier when you don't have a huge capacity in terms of taxonomy. So experts in all these groups. So what we started doing, because we didn't have, is like, and this is the first step, is like, what should we pay attention to? What should people in the government or in the agencies regulating these efforts should pay attention to? Which species? And this was something that we did based on the literature, based on the collaboration with the World Register of Introduced Marine Species. So it's a committee of scientists from all over the world, experts in different taxonomic groups, and they validate if these species the origin is the Red Sea or is in the Indo-Pacific, and they help us having a curated list of potential invasive species in the kingdom. We also have been working with Smithsonian because they have been working on this for like over 4 decades now. So they have a very good understanding of the distribution of these species. So putting all this together, we come up with a list of species that we know that are non-indigenous to the Red Sea. They don't belong here, but they are already here. Others that exactly the origin, and more studies are needed to understand if they come from here and we didn't know about them because we didn't have research on that, or if they actually come from a different place. And then others that also considering climate change or considering their presence in neighbor regions that may become invasive in the Red Sea. With that, we come up with a list of 181 potential invasive species in the Red Sea and 168 in the Arabian Gulf. And they are from worms to crustaceans and shrimps and to algae, so all these different groups. But some of them that we identify, both in the Red Sea and the Arabian Gulf, have been associated with severe economic impacts in other regions. We don't know here, but in other regions they have been affecting aquaculture and fisheries. So it's 2 critical species that we also need to understand, and to understand better here if they are affecting already aquaculture and fisheries or not. Doing these surveys, we keep updating this list. This list is always being updated, and we have been always in communication with the National Center for Wildlife, and this is something that we always encourage, is that there's a close communication with the authorities in a way that we can ensure that prevention measures and quick actions are taken. But one other thing that we have been showing with our results is that when we compare here you have a photo of a panel and the photo of the scrapings that we have from existing surfaces, that it's not always, we cannot find the same species with the one only approach. So we always suggest that we need an integrated approach, because otherwise we may be missing some of these species in Saudi waters. We want to make this effort easier for all the partners or the ones involved, the players in this effort. And we are making a website where people using molecular approaches can upload their sequences and can have a quick response if this is a potential invasive species or not. So this is something that we want to make available to everyone, and we know that these molecular tools are being more and more used and applied everywhere, but also here in the kingdom, and we want to facilitate the communication with the stakeholders to make sure that we have proper action. And as I mentioned, the shipping is one of the major vectors for the introduction of marine invasive species. So we know that the Red Sea and the Arabian Gulf, they are the target of a lot of shipping operations. We also did a modeling effort to try to understand what are the origins the ships come from that may have a huge impact or a major impact in the Red Sea and the Arabian Gulf. We did this effort for both Red Sea, Arabian Gulf. I'm going to show you some of the results that we got for the Red Sea. And some are very interesting in the sense that in 2 years we register more than 38,000 vessels coming to the Red Sea. More than 14 unique vessels coming from multiple origins across the world. And if you put these vessels all together, they represent 3.4 times the length of the Red Sea. So imagine like what would be a line of vessels, 3 times the size of the Red Sea that has more than 2,000 kilometers. And this definitely represents a huge impact or a potential impact in the season, in the region. But what we also found with this modeling is like what are the critical origins of the vessels that may be more impactful for the Red Sea. And this helps because the authorities can have a different approach based on the origin of the vessels and the potential impacts that they can have, and can guide biosecurity guidelines. We also looked internally in the region which ports were more connected and what are the ones that may be of a major concern to guide future monitoring efforts. So remember that we had these 22 sites in the Red Sea from 7 locations, and we identified Jeddah, Rabigh, and Yanbu as critical locations that should be monitored, because there are locations where invasive species are already present and locations with a lot of shipping traffic. But we also identify Neom as an area of future impact because of the coastal development and the recreation activities that we expect to have in the region. Being prepared is a critical step to minimize the impacts of invasive species. And what we are doing is trying to give tools and guidance to make sure that this is something that the kingdom is ready for. In this way, we are working with National Center for Wildlife, providing a guideline for biosecurity frameworks in the kingdom, identifying key stakeholders, identifying key agencies agencies that need to be in charge and leading this effort, identifying how the citizens can be connected, what tools can we put together to make sure that people are aware of this and they can act. But we know that they are not restricted to the ports, so we did a pilot study, also understanding what about coral reefs? Do they have already invasive species or not? Should we pay attention to these ecosystems, as well as seagrasses? They are critical ecosystem for fisheries, for example. We need to make sure that we safeguard these reefs. And in short, I'm not going to share a lot of the results, but this study we did in reefs off coast and the Jeddah port and marina in Jeddah, and we basically found that yes, some of the invasive species that we had found in the ports are already present in the coral reefs as well, and that some of these species, again, are of high impact based on what we observe elsewhere. And that depending on the tool, the molecular tool that you use, you may have different results. Again, highlighting the need for integrative assessments. But what we really don't know is what are the impacts of these species in the environment. And this is something that is a knowledge gap in the kingdom and that needs to be addressed. Are these species that are not native here, are they replacing native species? Are they affecting the fisheries? Are they affecting aquaculture? So this is something that the direction that we really advise the authorities to address, because it may be too late if we delay these assessments than to make to take some actions. But with all these collections, and Dr. Joy does ask about the reference collections, with all these collections, we are also contributing to have a biodiversity catalog for the species in Saudi Arabia. Not only the ones that are invasive, but mainly because luckily we find way more native species in these assessments. So we are providing a catalog of species that are present in Saudi waters. We are preserving the specimens based on the approaches that museums are using. So we can give this collection to eventually a future museum or a dedicated entity that wants to take this lead. But we also want to make this available to everyone. So we are working on a dashboard that people can look at the distribution of some of the species in the Red Sea and in the Arabian Gulf. And with time, as we get more data, also to look at their trends, if they are increasing, if they are disappearing, if they are expanding their distribution range or not. But unfortunately, it's not only the invasive species that we should look at. We know that there's a lot of coastal development in the kingdom, and we know that tourism activities are expected to increase. So with these comes different stressors that we need also to address. And some of them are related with pollution and namely medical waste as well, among others that I'm not going to touch now. But we are deeply involved in studies looking at the impacts of the classic contaminants like trace metals, but also emerging contaminants like medicines, like pharmaceuticals and personal care products. People will come with sunscreens as well, and what is the impact of these in the nature, the diversity of the Red Sea? We don't know, but we know that this again has been found as a major having major impacts in other areas. So we have been doing collections in the Thule region, Jeddah, and Alif areas with different anthropogenic pressures. We are collecting water, sediments, algae, corals, and fish, different fish, so that we understand what is the distribution of metals and some other pharmaceuticals in these organisms. and also in the fish in particular, we have different kind of fish from herbivores, from carnivores, so we also understand how these contaminants goes in the web chain and eventually affecting humans. In brief, we found several pharmaceuticals, several medicines already incorporated in the tissues of corals. And we know that their distribution in waters on the left and in corals is different. So the corals will accumulate these contaminants in a different way. We don't understand yet the mechanism, we don't understand yet why, but we know that, for example, caffeine, we found caffeine in all the tissues that we analyzed. We found painkillers, we found other contaminants in the tissues of corals. What we don't know is what is the level they can cope with. So we are also conducting ecotoxicological assays based on the concentrations of these contaminants that we see in the environment to understand what is the level that corals can cope, and these can help designing environmental guidelines to safeguard corals in the Red Sea. Very briefly, we also have been contacted by Red Sea Global about the impacts of desalination plants. So we did assays with salinity, and we found that even two coral species in the same area will have different sensitivities to salinity increases. This allows us to guide the deployment or the establishment of desalination plants and even the pipelines to minimize the impact on corals. And I will just skip. This one is, we are working with UV filters as well and antiscalants related to desalination. And to wrap up, our research is helping to detect early warning indicators to preserve marine biodiversity. We are developing molecular primers for specific species of interest, namely pests, but also species of environmental conservation interest. And with these, we can help guiding the development of environmental guidelines based on the response of native species, unlike some of the ones that we have right now that are based on regulation from the US and European Union that are not done with native species from the Red Sea. And thank you.
Yeah, please. Thank you so much, Dr. Susanna. Time for questions. That was a wonderful presentation, Dr. Susanna. Before they ask questions, there is a special announcement. The evaluation for the poster presentation has been started. So all the poster presenters are requested to be there near their posters, please. Dr. Susanna, before they ask questions, yeah, there is a question from that side.
Thank you for a nice presentation. I have a question. How does this high saline conditions affect the invasive success, especially in the Arabian Gulf? Is there any studies you did on that?
No. We actually think that the conditions of the Red Sea and the Arabian Gulf, namely in terms of the high salinity and temperature, can act as an environmental filter for some species coming from all over the world that they could not withstand these conditions. But that's why this modeling that we did took into consideration the salinity levels and the temperature levels of the ports of origin, so that we highlight the ones that are closer, like more similar, and those are the ones that we need to be more careful about. But there are no studies. this is something that we think, because we know that species have different tolerances, and we know that not that many species have the tolerance to the salinity levels that we have, particularly in the Arabian Gulf. But based on our analysis, that actually several species from the China, the Pacific, coming from Indo-Pacific, that can tolerate this, but also Canary Islands and the Caribbean, they have been identified as areas of concern.
Okay, thank you.
Thank you very much. I'm very happy to know that the sea and the whole ecosystems in the sea are being better understood. My name's Alan Duncan. I'm an architect from the Shetland Islands, the far north of Scotland. And the seas around Shetland are becoming warmer and less salty. So the whole ecosystems for the plankton, the worms, the seabirds are affected. The population of cod and fish is going down. I'm interested in these invasive species, and I'm wondering if we human beings can eat any of them. Because I know friends are very concerned at the UN that because of the climate emergency, the global production of wheat has gone seriously down. We're depending actually on wheat that's in the cupboard, in stores. We're not producing enough wheat to feed the population of the planet. We've gone from like less than 2 billion people, less than 1 billion people, to now 8.2 billion, and we're heading towards 11 billion people on the planet. So how do we feed everybody? I guess we have to find new things to eat, and that might be seaweed. One of the odd things in Shetland is we're exporting seaweed from the Shetland Islands in the north of Scotland to Japan. So I'm wondering if any of these invasive species could be food for us. Because I've driven from Riyadh to Dammam, and I see sand. I saw 3 camels, but I see nothing growing on the sand that human beings can eat. So hopefully in the sea we can grow something that we human beings can eat. Thank you.
Thank you very much for your question. And so there are 2 different angles in your question that I can address. One is the specific introduction of species, like for example for aquaculture. And most of the aquaculture efforts are based on non-indigenous species. And I'm not saying that, well, we definitely should encourage the aquaculture of native species. But there are ways that we can prevent that these invasive species become a problem in the environment. When this actually happens, and there are some examples worldwide where some invasive species have been used to actually feed populations. So they are already here. We cannot do anything about that. Let's use them. And this happens with fish. I'm not totally familiar with the terrestrial side. I'm more focused on fish, but I'm sure it will be similar in terrestrial. So yes, in some cases, there has been a shift towards let's take advantage of the fact that this species is already here. Food security is critical, so let's use that. That is, as I said, possible. But I do not think that we should encourage this. I think there are other alternatives that we can try to put together to assure that we have food for everyone. But at the same time, I'm not strict about this. I'm not going to say like absolutely not. If well managed, this has been applied elsewhere. In the kingdom, we have the case of barramundi, but we also know that barramundi has been spotted and is already being fished by the fishermen all over the Red Sea. That means that they are escaping from aquaculture. That means that if there are not biosecurity frameworks in place, namely in terms of sterilization of these organisms, they may interact and they may replace some of the groupers that actually the fishermen are after and that people really like in the kingdom. So it's an integrated and complex system, and we need to make sure that we understand the consequences and we have in place regulations and we enforce them to minimize the impacts.
Very nice presentation, I would say. My name is Dr. Naeem from King Faisal University.
Okay, sorry.
Hello. So I have one question regarding the invasive and non-invasive. You decide that whether the species is invasive or non-invasive?
Okay, very good question. Thank you for that, because I didn't have time to explain this difference between non-indigenous, so the ones that are not from here, and the invasive. So actually, what people recommend to use for the term invasive are the ones that have an impact in the ecosystem. Can be ecological, can be economic, or can be on the health of the human population. So these are the conditions for becoming an invasive species, and that's why I said it is critical that we advance our knowledge in terms of the impacts that these species are having. Right now, what we are doing risk assessments based on what we know from other places. So places that have been studying these species, and for those that we have here that have been found elsewhere, if they have had an impact in a different system, we put them as invasive. But again, as I said, this list is being constantly updated. We curate again this list as we go, as we get more information. And hopefully working with even the aquaculture facilities, we want to make assessments of their distribution here, and to understand from these practitioners if they, for example, have to remove them, because usually they clog the nets, and this affects the quality of the water and the quality of the fish. But right now, we are using this term invasive for those that do not belong to Red Sea. It has been confirmed, and that we know from other places that they can cause a severe impact.
You can come here.
Hello. One more question. Hello. Yeah. I am Dr. Jainath Gobi, a postdoctoral fellow in ARCMS. I have one question. It's an insightful presentation. What is the current status of genomic indices in eDNA-based biodiversity assessment?
What is the current state of eDNA-based?
Genomic indices.
MIC?
Indices, no. We assess the biodiversity. It's a new technique. What is the current status of genomic indices?
Genomic indices. Yeah, sorry. So, eDNA-based assessments by alone cannot replace visual observations. This is very clear, especially in the kingdom where we do not have proper DNA libraries. So part of this study and this project we have with National Center for Wildlife is to improve the libraries, the regional libraries of the Red Sea and the Arabian Gulf. Without these, we cannot make proper assessments based on molecular tools only. And that's why we are combining this strategy based on collections of organisms, based on their visual analysis, and based on the molecular work. What we know is that when we disregard the visual assessments, we have some detections of species that are very unlikely to be present in the Red Sea. And we just published a paper that will come out soon that shows that we suggest that only when we actually see the organism, we should assume that the species is here, because there are a lot of false positives when we use molecular tools alone. And this is a recommendation that we have been giving to all the stakeholders we talk with. Molecular tools are good, they are being developed, but they are not solving everything right now.
Yeah, yes, thank you.
Thank you, Susanna, for the wonderful presentation. I have one question. You showed a photo of corals, right? Treating the corals with different salinities. How do you determine the endpoint? Like, for a normal animal, you can say that it is dead, like LC50, but a coral is a colony, right? So how do you determine the endpoint?
So in these assessments, we are looking at multiple endpoints, actually. So different biomarkers, different, not only the tissue loss, we look at the amount of the symbiodina, so the algae that are associated with the corals. And we, based on these different parameters, we come up with what we call as survival. And the survival, as I said, include the coloration, includes the concentrations of symbiodina, and then that's how our end point is survival, but based on the assessment of multiple markers.
Okay, that's fine, that's fine.
Thank you so much, Dr. Susanna, and thank you so much everyone who asked questions and the speakers who answered, clearly. And we have to move on. The next presenter is Engineer Adnan Al-Ayani, and he is from NCEC, National Center for Environment Compliance. Engineer Adnan is an accomplished professional with over a decade of experience in the fields of environmental technology, renewable energy, oil and gas. Holding a master's degree in mechanical engineering with a focus on environmental clean energy production and use, he has worked in various roles, including Director General of Environmental Technologies at the NCEC, with 19 internationally recognized certifications and a portfolio of ongoing 10 patents. He is also a certified trainer in robotics, drones, and emerging technologies. With this few words, let me invite Engineer Adnan to deliver his presentation.
Assalamu alaikum wa rahmatullah. First of all, let me thank King Fahd University of Petroleum and Minerals for hosting this wonderful and high-esteemed conference. And thank you so much for having us and making us part of this well-organized conference. In this presentation, we will be covering smart technologies and environmental monitoring that will serve a more sustainable future. In this presentation, we will focus on giving solutions to all the environmental challenges that we might have for any sectors. My name is Adnan Al-Ayani. I am the Director General of Environmental Technologies at the National Center for Environmental Compliance. In this presentation, we will cover these points. All right. We will start with the environmental framework, institutional framework in the Kingdom of Saudi Arabia. I want to give you an overview of the framework in the country, and then we will go swiftly on to what environmental technologies are, what is the definition that we have approved of, and we will give some examples of some technologies in many of the three environmental mediums, water, air, and soil, and also some examples of technologies in other sectors that will serve many mediums as well. And then we will talk about the artificial intelligence, the importance of artificial intelligence, and how can we approach or get into making smart cities. And then we will be covering some of the papers and researches that we relied on to make our validation and evaluation of technologies valid. And then there will be a small gift at the end of this presentation, so I encourage you all to stay until the end and see what's going on in there, which is something related to environmental investment. And there is a little gift in there that we can provide, inshallah. So environmental institutional framework in Saudi Arabia goes under the umbrella of MIWA, Ministry of Environment, Water and Agriculture. And we have, as you can see, 5 NCs, national centers, starting from National Center for Waste Management, which is called MWAN, and National Center for Meteorology, which is NCM. Also, we have National Center for Vegetation Cover Development and Combating Desertification, NCVC. Also, we have National Center for Wildlife, NCW, and National Center for Environmental Compliance, NCEC, which I personally represent now. NCEC is a primary body governing environmental compliance and monitoring, which legislates and enforces environmental law and its executive regulations. Our mandate is very basic. We just protect environment whatsoever, and to protect it, we need to preserve the resources from deterioration, and that's why we have many executive departments that takes care of each and every element in the environment. We have too many areas of work in the NCEC, such as, not limited to, issuing environmental permits and issuing environmental licenses. And the permits, licenses are different. So permits are for those facilities that might have potential environmental impact to the society, and licenses for the entities that might provide environmental services. Also, we have environmental monitoring and assessment, and that goes for the 3 environmental mediums, air, water, and soil. And we make sure the quality assurance to these 3 mediums. Also, we have environmental inspection. And to do the inspections, we need to make site visiting to facilities to make sure they are environmentally compliant to the executive regulations. Also, we have emergency planning. And we have, in this area, we make sure the facilities are ready to respond to any emergency. And also, we receive violation reporting. For example, if you are seeing any violation in any mediums, you can call 988, and I repeat, 988, to report that violation, and one of the NCEC representatives will come to that site to make sure the environmental condition of that violation. And then we have a guideline to, we have almost more than 50 guidelines for all the sectors, all the activities that we think there is a potential environmental impact to it. And we have laboratories to run samples and test results, and also we train people, individuals, to be qualified to evaluate environmental issues. All of that goes to the country transformation towards environment, and this is derived from the Vision 2030, which has too many goals in it, and we sum them up into 4 points here, which are related to environmental technologies, and they are stated as enhancing manufacturing, local manufacturing of environmental technologies, which will enable the country to import or export technologies outside the country rather than importing them inside. And also, this will create a database for us of verified environmental technologies that will help us, identify how to solve any environmental challenges. MIWA, on the other hand, align with the Vision 2030 by raising environmental awareness to the kingdom, developing reliable network environmental NGOs, non-governmental organizations, and also roll out research and development strategy for the environment. The NCEC also align with the alignment of the MIWA by supporting and motivating environmental technologies, and therefore they have established the General Department of Environmental Technology, and this is the department we represent right now. And in that department, what we do is as follows: we evaluate, verify, and make or create a database, and also we engage with people to show them what technologies are used to solve any kind of environmental challenges. Now we spoke about environmental technologies, and we do have too many definitions for environmental technologies. And I would say environmental or technology in general is a tool that will serve an area, speed up the process to achieve that goal in that area. So if I say industrial technology, it is a technology that serves the industry. If I say medical technology, it's a technology that serves the medical. And when I say environmental technology, it's a technology that serves the environment. And we came up with this approved definition that we hope it can be used for institutional researches in the coming days. Environmental technology is refit, and I will just read it to you because it is very valid and I don't want to miss any words. Environmental technology is referred to the practical application of environmental science and scientific methodologies to develop devices, equipment, and products with added environmental value. And this is really important. These technologies play a crucial role in measuring indicators of environmental impact, which represent a positive or negative change affecting the environment as a result of human activity, and as the doctor mentioned, anthropogenic activities that might cause a lot of problem to the environment. By leveraging these technologies, we can enhance environmental protection, prevent and mitigate effects of pollutants, and address pollution sources to ensure compliance with the environmental regulations while preserving natural resources. So this is the definition that we came up to the environmental technology, and we hope it can be taken into all the researches, especially here in the KFUPM. And we put there with different color extinguished a text which is added environmental value, and we meant by that to represent a more beneficial or less harmful environmental impact compared to other alternatives. Otherwise, if there is no adding value to that technology, then the technology is no use. Now we will move swiftly on to all the technologies that we have, and I mentioned before, we will go over the three environmental mediums. And I will try to speed up a little bit here because it took some time. We have this technology, which is a photocatalytic air filtration technology, which is a technology that relies on the sunlight or UV lights to be activated in order to reduce the impact of some chemical compounds, such as sulfur-based compounds abatement will be reduced from 70 to 80%. Also, nitrogen-based compounds abatement will be reduced by 80 to 95%. And VOCs will be reduced as well from 60 to 80%. This technology can be used to purify industrial emissions and control odors in sectors such as oil and gas and other industries. We have another technology which also serves the air medium, which is a dust suppression technology, and it is a chemical that can be used to put over a dust that can fly over an area. As you can see there in the picture, we have before and after using the technology, and you can see there is in the left side of the picture, you can see there is a dust flying around the area. After using the technology, the dust is gone. Now it is clearer. We can breathe normally there by using this technology, and it is eco-friendly. These technologies are verified by NCEC, by the way. There is a technology serves the water medium, which is robotic technology for water network inspection. As you can see, we have a lot of work, a lot of constructions on the road, and that requires us to, block the road and make it difficult or make a traffic jam to the road because we cannot identify where the problem is. So we have to, make excavation in a very long scale or bigger scale to make sure where, to identify where the problem is. This technology, and I don't know if you can play this video up there, the one down there. If you can, that would be helpful, because I want you to visualize how it works. So this technology can go through the pipe and check the thickness of the pipe and send notification whether this area needs to be replaced or needs to be fixed, or maybe there is a leak in there. So we can, from there, we can identify where the problem is by using this technology. There is a technology that we often use, which is a drone, and the drone is very useful to check areas where we can, as human, reach easily. Drones can be a great help to scientists to identify and gather and collect data. And as you can see, we have a UUV here, which is unmanned underwater vehicle, and also we have UWV that also can do the same thing, but it's on the surface of the water. And in the picture there, you can see there is a solar panel attached to the UUV that can make the battery life goes for a long time. This technology actually checks the quality of the water and also sends us some data, real-time data of that water. And we can from there check whether this water needs to be purified or treated or not. And it will give us something like the pH levels, the temperature of the water, the salt, oxygen, and so on. And also the grease. If there is a grease in there, we can get some information about it as well. There is a soil bioremediation, and I really want that to play. Can you play the video? I don't know where those people are. Okay, so it's a technology. It's a chemical used it's a material made of some sort of bacteria that can dissolve the oil, and instead of making excavation to that area, we can just collect them or move them to an area where we can just collect all the contaminants or pollutants into one area, instead of making a big, huge excavation to that area. We have a low-carbon cement technology, which is different than the conventional and traditional cement. This technology is used to reduce the conventional cement and use a cement that has zero clinker, which, and clinker is bad for the environment. This cement can be used as an alternative to the traditional cement, and it is very useful. And I also have a video there, but unfortunately we cannot play it. We have here a smart acoustic monitoring technology, which will measure the noise, the ambient noise of an area. This technology can also identify whether, from the sound of the noise, whether we have a leak in that area, or we have a leak like of water or maybe a gas. Also, if there is some sort of cracking in the system, and that technology can be used in factories. It will send notification to the control room to tell them there is a potential sound that looks like a leak in that area, so send someone out to check it out. So this is very useful technology. here is a material that can be used on the material, on the cement to collapse a building. Now, if we want to demolish a building, we have to, use TNT explosion to, get the demolition happened. This material will make cracks to the cement and will make the demolition, the collapsing, very smooth. So we are reducing the noise of the explosion, and we are also reducing the air pollution that happens from the explosion. We have solar thermal waste technology. This is, as you can see there, it's a big lens that can melt any hazardous material. And can be recycled and used for another material. It helps significantly to the what they call it, a sustainable economy. This material is used in Portland, in United States. It's not well verified yet, but it can be a very huge or a life changer to some of the toxic materials. If we use this carefully, we can, instead of dumping the medical waste to the landfill that cause more harmful to the environment, we can use this technology to mitigate this problem. And we do this by the use of artificial intelligence, and we have a lot of experts in artificial intelligence in the NCEC that can read the algorithms, the machine learning algorithms that will help us analyze based on the data given, analyze the current situation of the environment, and also predict what might happen in the future by using the data. And to do that, we need a big data. We need data that from there we can predict the future, and we can understand the current situation of an area. Also, remote sensing is a great help. We rely on satellite to gather data for a bigger scale in the country, especially if that project is huge. And also, we can use drones and other sensors that will help. Here we have geospatial technology such as GIS, and as you can see in the top, since 2009 until 2020, there is a huge, significant change to that area. And from there, we understand the environmental load to that area is huge. So we might say, as NCEC, we cannot give a permit for any more activities to that area. Like, for example, if there is someone interested in planting a factory in there, we might say, no, we cannot give you that because the environmental load to that area is huge. So we cannot give that, which would help the human health. And also at the bottom, there is a monitoring of the construction. Like, this is actually the Lion project in Neom. We see the ongoing process of the project, and from there we can tell if they are doing well or there need to be some amendments in the process. We use the Internet of Things devices, such as drones, such as sensors, to give us a real-time data, and from there also we can gather information to help the decision makers make decisions. And all of that will help us reach something we call smart city. And smart city is a city that relies 100% on technologies. Like, for example, in the picture up there, we can say if there is an air pollution to an area, we can identify where that pollution is coming from, what it is, and where the source of that pollution is coming from. So it gives us a full control of a city. that helps us, run the city environmentally correctly. And all of that is based on papers and researches, and I have a wonderful team who relies too much on researches and papers given or made from universities such as KFUPM. That helps us actually make the evaluation to the environmental technologies. And that's why we are here to strengthen the collaboration between our entity and universities such as KFUPM. Now what we are doing, and we need help from all of you, and I hope I'm not taking too long, we are working on activities, all the activities that might have a potential environmental impact. And from there, we know what sector is that activity associated with, and what might be the environmental impacts, the environmental challenges of that activity, and what challenge is the right technology that can be used to mitigate or maybe stop that challenge. So this is ongoing work that we are doing right now, and we of course need help from universities such as KFUPM. Finally, so again, NCEC relies 100% on using the best practice environmental technologies in the world to make sure all the outcomes from the NCEC is accurate and based on international benchmarking. Therefore, we came up with lots of investments that we thought it's important for you to be part of the change that we are planning on making. And these investments are, as you can see here, we have more than or about 30 environmental investments. And this is a really important slide, and I want you to take a picture of it, or maybe you can ask the organizers for a copy of this slide, a copy of this presentation. This investments, we have, like for example, now you can see the trend, the growth of the revenue since 2023 until 2030, which has more than 15% growth in the revenue. And we split all the investments into 3 waves. The first wave has 15 investment opportunities. For example, if we have manufacturing of air monitors and filters, it has a 0.93 revenue coming from it. Also, we have soil remediation, which would give about 3 billion riyal revenue. These opportunities is well studied. It has a feasibility study ready for each and every opportunity. So I would like you to take a picture of this. If you are interested in one of these opportunities, I would like you to scan this QR code, which will take you to an email of the General Department of Partnership and Investment Attraction, and they will be more than happy to help you with signing maybe MOU with you, or maybe a pre-visibility study for the investment that you are interested in. And also, this is the gift that I told you I will give you at the end. If you choose one of these investment opportunities, we will link you with the environmental fund, and the environmental fund will be glad to help you with funding this opportunity investment. And also, we will link you with the SIDF, Saudi Industrial Development Fund as well, and they will also help you with funding this opportunity. So I would like you to take a picture of this if you are interested in any of the opportunities I just mentioned. And that would be the end of me, so thank you so much. Is that it?
Thank you, Engineer Adnan. We're running short of time, so but still we can allow one question, please. One question. Please.
Assalamu alaikum.
Walaikum salam.
Good morning. It's here, over here.
Ahlan.
Hi. First of all, thank you so much, and I appreciate your presentation. Massive information in very short time. I think every technology that you have mentioned need a separate presentation. Yes. So thank you for that. We appreciate it. I am Dr. Muhammad Al-Mustafa, representing Mr. Salim. We are Golden Ring Office, طوق الذهبي for environmental consultancy. So we consider ourselves as your partner, as your, of course, kind of customer, hopefully, inshallah. You have no idea, according to our vision in our company, that we encourage this kind of events because, you know, consultancy office work as a mediator, as a link between you as a regulator and the activity or business owner. So it's a very unique role. We are proud to play it. So that's first of all, thank you so much. And I appreciate your great work, of course, during the impact of every activity and the solution, the proposed solution. It's helped us a lot and, you know, minimize the deviations between our perspective and your perspective to the minimum. So thank you for doing the homework of our own. Thank you so much. You know, a lot of things that we have to discuss, inshallah, and I thank you, and please keep the good work, and thank you so much for that. Thank you. I appreciate it.
Appreciate it. Thanks. So that wasn't a question, right? Okay, thanks.
For the informative presentation. Now we have to move on to the next presentation. It will be by Dr. Mark Dimmock. He is the Marine Director of KSA. Dr. Mark Dimmock obtained his PhD in Ocean Sciences at the University of Wales, Bangor, UK. He has 25 years of experience in marine fisheries data collection, stock assessment, and fisheries management. In the past, he has worked as a researcher, supervisor, and occasional lecturer at the University of Malta. Dr. Mark previously worked as an independent fisheries consultant for a variety of entities, including universities, NGOs, governments, international organizations, and private companies. He has been with the KSA since 2021, managing mostly the fisheries-related projects. With these few words, let me invite Dr. Mark to deliver his presentation.
Okay, hello. So my talk will be focused mostly on management. And I would like to start with some basic concepts to lead where I want to go. Yesterday we saw some nice presentations on what's going on land, on the terrestrial ecosystem. And we all know about the importance of nature conservation, and now in Saudi Arabia this is picking up as well. In many parts of the world, the concept of nature reserves and protected areas has been quite well established. Okay? At sea, usually this is what we see. There's a huge difference from this, because we see the trees, people like to go out, enjoy. We don't see the if one of these places is polluted, we see it immediately. When it comes to the sea, we just see a blue shadow going on to the horizon. And why I'm mentioning this? Because what's happening on land, there's a big contrast of what's happening at sea. Okay? We do not see all these activities. There are several anthropogenic impacts, was mentioned briefly by Susanna, that are happening all the time, including, this is an anchor from recreational fishermen or recreational activities. A coral that would take hundreds of years to grow, it can be destroyed in a second. Fishing lines, fishing nets, species discarded at sea, capture of that is a humpback wrest, which is a protected species. If these things happen on land, we would see several people in jail. But unfortunately, at sea, this doesn't happen. Okay? Why? Because we don't see these activities. Okay? So I would love to see what is happening in Alula, for example, like the Prince opened it. The activities that are going there, the rewilding, the stopping of the anthropogenic activities, the killing of the orangs, the hunting, this stopped completely. Why at sea we're still having all these issues? Okay? And this is where I want to lead. Fishing has been done for hundreds and thousands of years. Okay? It is one of the most, let's say, primary sectors, primary jobs. But nowadays, we moved from a traditional sailing boat to very fast boats, lot of equipment, they can move everywhere. So what happened, what used to happen like 50 years ago, 100 years ago, now we have a completely different situation. Technology, as we saw from the previous presentation, can be extremely useful, but it can be also damaging, especially to the environment. So nowadays, management is much, much more important than what happened 50 years ago. Because some people working in the sector may say, but we have been doing this for generations. True, but you didn't have 250 horsepower engines on your boats. You didn't have GPS sounders. You didn't have fish finders. Okay? You couldn't go on reefs very far in a day and come back. So things change a lot. So while managing natural resources at sea, the first priority is to stop or reduce or control or manage the anthropogenic impacts. There's a lot of research going on in, everywhere around the world, okay, including Saudi Arabia. However, most of this research, which is extremely useful, we try to find solutions and technologies to solve problems before we stop the impacts. I like the presentation on the terrestrial again, because in the management system on the terrestrial, first they stop the impacts, and then you start to restore and manage the system. At sea, it's not working. I'm speaking this globally, okay? There are many problems around the world. I've been working, I worked 25 years. I spent 10 of these years with the United Nations. I worked in 20 different countries. I saw a lot of very high quality science, like we're seeing also in this conference. I saw very well-intended people from the governments that really want to make a change. A lot of conferences like this one. Politics, and millions, I should say billions of dollars spent on research. However, in many parts of the world, things are not working properly. We knew about human impacts. I work in the fishing sector. The first overfishing started being documented in the 1800s, more than 200 years ago. We know about the problems. We know. On land, we stopped hunting. At sea, we cannot stop fishing completely, but there needs to be more management. So why it is not working? Why? And that would show you the solution. Because some communities managed to overcome this. The main issue is not science. The main issue is governance or management, okay? And that is why the title of my talk. Because in business, if governance or management is not good, the business will fail. They will go bankrupt. In environmental management, unfortunately, until the environment is completely destroyed, okay, things will continue. But we don't have to arrive to that situation. This is also the biggest topic of climate change. We had a discussion about climate change. Okay? That's why we're trying to do something about it. So I will illustrate this with an example. In Australia, they have one of the best ecosystem-based management in the world. Every year, they publish a report, this is from 2020-21, yes, describing the state of their resources. When we speak about fisheries, it means the exploitation of any marine living organism, being a fish, being a lobster, being an abalone, okay, a mollusk, anything which is harvested from the sea, including plants. If there is harvesting of seaweed, for example. This is all under the cap of fisheries. So what are the results from this report? So basically, 95 of their stocks are not risk of exploitation, meaning there is sustainable. This conference is about sustainability. So this Australia managed to have 98%, not 50 or 60 or 70. If you look at the global situation, 50% of the stocks are overfished. I come from the Mediterranean. In the Mediterranean, it is about 80% overfished. 20% are sustainable. Okay. In Australia, they manage a high. Furthermore, 90% are of the stocks are certified. What does it mean, certified? Meaning there is a body, an auditory body, outside of the country. The MSC headquarters, it's an international organization, is in London. They go audit the fishery like a proper business and check that it meets the criteria of sustainability. Once the fishery passes through the criteria, it is then given a stamp. And you tell me, but why Australia is doing all these things? Firstly, because of the concepts sustainability. Then there is a business line into it. If your seafood has this label, you can charge 3 times, 4 times the price. So a fish with a fishery with this label in the Western world, like in the US, in Northern Europe, in Australia, can fetch higher prices. In Saudi Arabia, this is works as well, because all the restaurants and the hotels, which are 5-star, like the Hilton, the big ones with international chains, buy only this kind of seafood. They only buy certified seafood. They will not buy seafood which is not certified. Why? Because they have to keep the international standards. And then they charge appropriately in their restaurants. If you go to eat in the Four Seasons restaurant, the fish there is quite expensive. Why? Because it meets these criteria. So all these way of working has, apart from the environmental sustainability, the business side. Just to a small on the MSC. MSC is based on 3 pillars. Sustainable fish stocks, so an assessment to see if they are overfished or not. Minimizing environmental impacts, so all the impacts are shown. A fishery would not pass this if they have all these impacts. And then effective fisheries management, which I will be talking about here, okay? There are many, so how do we arrive there? How do we achieve this level of sustainability? By having these kind of results and then eventually certification. How do we arrive there? There are many publications around the world, including from the United Nations, FAO, which is the Food and Agriculture Organization for the UN, and many other publications around the world. Basically, in a fishery, which is an economic activity, all the assets in the fishery are assessed. What are the assets? In a business, you have capital investment. You have the human resources assets, okay? And so on and so forth. These are the assets which are assessed in the fishery. So when the industry, this is all coming from the industry, together with the management, they assess the captured fish themselves, which are the production, okay? Recreational activities, because at sea, you know, there are many recreation, and so on and so forth. The protected species, the habitats that we heard a lot here. Habitats are considered as having an economic value, okay? In Saudi Arabia at the moment, there's a lot of development for tourism because they recognize the important economic value of the coral reefs. That's why we are doing all this research. Social amenities, so what these habitats can provide, which we call also ecosystem services. Economic effects, so how much revenue can we get and how we can improve this revenue. And then the governance system. Even the governance system is assessed as an asset. If the government system is not working, something needs to happen. And then we consider external factors. Why? Because in most of the production systems around the world, in everything, fuel, for example, is one of the most important factors. If the price of fuel goes up, the business can go easily bankrupt, okay, in any sector. This is especially important in fishing because it's one of the biggest costs, the cost of fuel to go out and catch fish. Once these assets are identified, because this is a general overview. However, when doing management, we go into all the detailed assets. Just to give you an example, in my experience, because I did this in several countries, you can identify between 100 to 150 assets. However, in reality, one cannot address and improve or deal with the issues with every asset. So we do risk assessment. In the risk assessment, basically, you take every asset, you do a complete risk assessment. I cannot go into detail about this, but eventually, the business is to identify the low risk, so things that we can, okay, say, this is not a big issue, against the high risk assets. Destroying coral reef is a high risk issue, because without coral reefs, you cannot have fish, you cannot have tourism, you cannot have many other issues. If you overfish, if your resources are extremely low, there is no food, there's no seafood coming. It's high risk issues, okay? And then management is done first for the high priority issues, okay? And this is the system. So in KAUST, what we're doing at the moment is trying to identify this issue. This is an example, and the status of the resources. Behind this, I just put this slide to show you that there's a lot of work and research being done. What we're trying to achieve is all this science will arrive to one, what we call here in the Gulf region, KPI, the key performance indicator, which is the status of the resources. Is these resources fished sustainably or not? At the end, we want sustainability, and we need an indicator to determine this. The second aspect we are working on a lot, and I'm describing this, I'm using pictures from Saudi, but this is a global discussion, is the human aspect. Because, as I mentioned before, you cannot just stop fishing. So there needs to be, when identifying these issues, and after they have been identified as high risk, we need to work with the local communities. And in the case of fisheries, there is a lot of aspects or branches dealing with the management people, so people in the government, people in the authorities like NCW, the fishermen themselves and their families, recreational activities, and then the boats themselves, because within the boats there is a whole system around that. However, if I had to draw and structure this approach, it could be something like this. So this is a management framework where you start in the beginning, as I mentioned, identifying the assets, doing the risk assessment, and the next step is to develop what we call a management system. Those who are working in business and also in the governments, we are all aware about strategic planning, right? I think everyone heard strategic planning. This is strategic or business planning applied to fisheries. And this is the plan. Because all this, once this process is passed through, we will have a plan on how to do things and work within a plan, not work reactively. Most fisheries around the world have been managed in a reactive mode of way. Something happens, the head of the cooperative goes to the minister, we have this problem, solve it for us. This is reactive. This doesn't work in the long term. And the minister tries to solve it because he needs to get the votes to get re-elected. Okay? Most advanced organizations managing the marine resources have independent organizations. In Norway, for example, they established the Marine Resources Authority. That it's independent from the government because these issues are for extremely long term, 10 years, 5 to 10 years, not short term. And this is how it looks like if we, let's say, apply it in practice with identifying the problems, discussing this, doing the research, discussing this with the stakeholders, and eventually implementing all the activities. Most of the activities I saw today and yesterday are done. Why? Why we chose to do this project? How many projects did we see? Why? Why not another project? Who decided this? Where is the planning coming from? I'm sure there was some thinking in the government. Someone came up with, let's do this. It could be politics. It could be many issues. However, the most efficient way to move forward is, before starting to implement projects and activities, these should be discussed in consultation with the stakeholders, which could be the users, in our case, in my sector, it's fishermen, okay? The tourism authorities, like diving, the responsible authorities now in Saudi Arabia, for example, there is Shams, NCW, MIWA, and so on and so forth. This leads to more effectiveness of the system. It is happening around the world. I will tell you, most of the world is in a very bad shape. In Europe, in the Mediterranean, where I come from, this has started to pick up in the past 5 years. In Australia, it started in the 2000s. And in fact, they are very famous for the Great Barrier Reefs, extremely productive systems, okay? In the United States, things started to change around 10 years ago. And once they adopt this management system, you know, the US is considered like the hub of technology. They have been collecting data with NOAA, with the military for decades. But still, it wasn't working. Now they are adopting this governance system, and these are the stocks which are being rebuilt starting. You can see the dates. 2004, 2019, 2017, 15, these are their results. So recently, in the past 10 years, things are starting to work, okay? Not because of the science, because of the governance. Because the science is good. It's good in many places. And at the end, this is what we'd like to see. You can see the proud fishermen with the nice big fish. This is a case study in Turkey where it was the same problems. After implementing this approach, after 5 years, we have the cooperative coming, showing us, look what we catch. We are so proud of what we did. Not the government, we did, because they were actively involved in this process. Okay? Once you have a result like this, you are sure that things are working. So, I will close my talk to say what is happening in Saudi Arabia. Because at the end, I would like to give a little pitch on the local situation. In the GCC, we are still in, I will say, I worked mostly with the UN in the MENA region. So in the MENA region in general, we are still with the old approach. These new approaches, ecosystem-based, haven't been applied. In Saudi, we managed to have the first case study in NEOM, okay? Thanks to the NEOM authority. Why? Because then it's about politics, culture, and you tell me why you managed to do it in NEOM. Because the NEOM managers are coming from Australia. And they recognized how important the head of the NEOM Nature Reserve, he is from Australia and New Zealand. They realized, they know how important this is because they saw it working in their country. So we managed, it wasn't that difficult to convince them. They said, yes, this is what we have to do, let's do it. But when I speak with other stakeholders, it's extremely difficult to get this on board. Because many times they say, this is for Australia, it doesn't work here, you know, we are Arabic region, is different, blah, 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 blah. And in NEOM, we are having a success because we managed to go through the process, we developed the management system, we have the first management plan, the stakeholders, the fishermen were extremely involved. This is a typical management scheme, how it looks like. I'm not going into detail, Okay? However, inshallah, this year, this plan will be officialized with the government, with the Ministry of Environment, with MIWA. Okay? So it could be a success story. I personally worked on this, and in Saudi Arabia, you have a lot of resources. However, I personally work on this in other Arabic countries with much less resources, like Lebanon, Egypt, for example, Tunisia, and we still manage to work. Because at the end, it's not about how much money you put in. It's about the discussion in the governance system, the discussion among the stakeholders, the talking, meetings after meetings, breaking the ice and moving ahead, step by step. So, to close, we would like to see here in Saudi Arabia more this kind of approach, establishing MPAs, because when you have a marine protected area, you can define the boundaries, because some of the problems are when the boundaries are, so you say, okay, I will do this for all the Red Sea, it starts becoming complicated. NEOM, we were lucky because there's a boundary. This MPA can be done in Farasan Islands, for example, and I know the NCW is working towards this. Asir region, okay, and so on and so on, because these regions, they have the MIWA on top and the governorate that can support the establishment. Again, always with the fishermen at its core, okay? We cannot adopt the same approach on land because hunting is very destructive. At sea, because of the biology of the species, fish and birds or mammals are completely reproductive strategy. Fish produce millions of eggs. A mammal can produce 1 or 2 offspring per year. It's a complete system. But at sea, we can still have the fishermen part of the system. And I hope that Saudi Arabia will try to move in this direction and the Gulf in general in the future. This is the way to make things work. Thank you for your attention.
Thank you so much, Dr. Mark. We have time for just one question, please. One question. One question from there.
Hello. First, my name is Dr. Dave Oswald from King Faisal University, as well as representing DE Design and Environment, which is a consultancy and technology company. I'd first like to thank you for your presentation, as well as Dr. Cavallos. You're doing outstanding work, very forward-looking. So my question for you is whether or not you're considering including or incorporating economic valuation of ecosystem services into your ecosystem-based management plans, because this is something that has been starting to be used in other parts of the world, and there's some success that's being realized in terms of identifying negative environmental externalities, such as with the Seychelles and in the Caribbean region where I work quite a bit. Thank you.
Yes. The simple answer is yes. There is a misconception a little bit of what ecosystem approach means. Ecosystem approach or ecosystem-based management doesn't mean the marine ecosystem itself, but all we as humans part of the ecosystem. And as humans, economics is very well entrenched into our ecosystem. Governance, social and cultural issues, okay? So when we go through this process, the biological ecosystem is just one component, and then we address everything else. So yes, it's a simple answer. Thank you.
Thank you so much, Dr. Mark, and definitely you will have more questions. You can approach all the speakers. They will be here until this evening, and you can also send emails. And all the people are well-known people, and if you search in Google, you will get their email address, and you can contact them also, please. We have to move on. Next presentation is by Dr. Will Le Cusname, and that will be the last presentation for this session in the morning. Keynote speaker, as a keynote speaker. And Dr. Will, he is a director, International Center for Ocean Protection and Use in CIFAS. He is a principal scientist at CIFAS with a technical background in ecology and modeling human interactions with the environment, with a focus on biodiversity and fisheries. Will is the CIFAS Middle East program leader, and he is currently based in the British Embassy in Oman, leading the UK Gulf Marine Environment Partnership Program. He has a particular interest in understanding interactions between human activities and the seas and how this can be affected by climate change. Dr. Will has a track record in publishing modeling and experimental studies on climate change and ocean acidification. And let's welcome Dr. Will to deliver his speech. Dr. Will, please.
Thank you for that introduction, and thank you for the invitation to participate in this conference. Yes, I'm Dr. Will Lacane from CFAS. CFAS is the UK government's specialist marine science and advisory agency, and we've been working in the GCC region for the last, 15 years and longer, partnering with entities across the region to build understanding of the management of the marine environment and human impacts on it. I guess more importantly, after a long and very interesting session, I am the person standing between you and your lunch. So I presume the thing you are thinking about most now is I hope this person is good and I hope that they are quick. No guarantees, I will see what I can do. So thank you for the talk so far. We've been hearing a lot about various human pressures, human activities impacting the waters of Saudi Arabia. We heard a bit about climate change at a global scale. I think it is important that we keep talking about climate change. As we seek to manage the environment and the waters around Saudi, we have to expect there will be a shifting baseline. The environment will be changing around us over time. And in order to understand how to address that, we need to focus in and pick out what are the key impacts and what can be done to build resilience to address this. I mean, we're here talking about climate change. It's quite warm outside anyway. You know, why do we worry about this? What this plot shows is the temperature change in Dammam over about the last 100 or more years, and you can see there is a significant... This one's better? Sorry, was I? Is that better? Excellent. I don't know. You can see there has been a significant change, and it's been ramping up recently. This will continue. This is happening. There is nothing we can do about this. And actually, I think one of the points that I come to when thinking about climate change, it's not so much a challenge for our science, it's actually a challenge for our imaginations to conceive how the world will be very different in the future. So, why are we talking about climate change in the context of the sea, in the context of the marine environment? Basically, the sea matters. It matters to us as a society, it matters to us as people. We depend upon the ecosystem goods and services the sea provides, and those goods and services depend upon the status of habitat, species, and communities. And as they are impacted by climate change, they will impact the benefit and well-being of our societies and ourselves as individuals. Climate change operates at a global scale. Marine environments operate quite typically at a regional scale, and the work that I want to talk about at the moment is part of some work we were doing in combination with ROPME, the Regional Organization for the Protection of the Marine Environment. This is the Regional Seas Convention that covers the Arabian Gulf, the Arabian Sea, and the waters off Oman. And by taking this regional scale, it's possible to kind of understand the broader context of what can be done at a local scale. You can see here the kind of boundaries of the ROPME Sea area. When we consider climate impacts upon it, the ROPME Sea area, in a lot of the work that ROPME does, is split up into three regions. The inner ROPME Sea area, that's the Arabian Gulf, the waters off Dammam here, Duran. There is the middle ROPME Sea area, which is the Arabian Sea, and then the outer ROPME Sea area. And these are quite different ecosystems that have very different sort of drivers and characteristics, and as climate change progresses, they will respond in different ways. The inner ROPME Sea area is a very shallow sea. The Arabian Gulf, as you all know, it's very hot and it's heating quite quickly, and it'd be driven by many of those temperature changes. When you get to the outer ROPME Sea area, the waters off the Omani coast, that's a very deep upwelling driven system, and it will be the kind of changes in the upwelling driven by some of the kind of high atmospheric teleconnections we were hearing about earlier, which will be some of the things that really drive the change there. Within the context of the Paris Accord, when looking at how society, how the world can respond to climate change and its impacts, there are two broad approaches. There is what's called climate mitigation. How can we reduce the greenhouse gas emissions into the atmosphere? And that's something that we need to do collectively at a global scale. But whatever we do about greenhouse gas emissions, the climate is changing and will continue to change. A lot of the change is locked into the system. So there is another track about building resilience. How can we take adaptation actions to prepare our societies and our ecosystems to adapt to these change? And that's very much the work that was focused on. The ROCME member states agreed in 2017 to establish a marine climate change task force. And then a couple of years later, this regional action plan was established, and CFAS was the kind of technical partner working with ROCME to deliver this. It was a multi-year plan. COVID happened in the middle of it. That led to a few interruptions. And it went through this kind of stage of looking at what's the impacts of climate change, what do we know, what is happening already, what do we think is going to happen into the future. So we're just hearing about in the last talk, once you start looking at possible impacts, you end up with very long lists of things you could possibly worry about. How do you focus in? We then went through a risk assessment exercise. How do you go from a long list of concerns to some priority things to focus on? And then ultimately, you know, all this science is great, but what can you do in terms of adaptation and resilience building actions? And so then this program looked at trying to provide practical recommendations about resilience building actions. What I want to do is very quickly talk through these three steps of this process. I could talk for half an hour or more on each of these steps. Don't worry, I'm not going to. I know lunch is coming. But I'm just going to give a kind of snapshot of the process, because I think it's important to understand the process. It can be repeated at different scales. It can be repeated at national scales. It can be repeated elsewhere. And also just to draw out some of the key messages. I said this work focused on adaptation. As many of you know, there are a number of marine habitats that can take up carbon, and so there is a role for the oceans and the marine environment in the kind of mitigation story, and there was a strand of work that also looked at that, but I'm not going to talk about that this morning. So the evidence review. We're starting to worry about marine climate change and how it can impact the world around us. So the first thing we do as scientists is, what do we know now about the existing and possible future impacts? And we were keen to look at this in terms of the kind of underlying physical and chemical drivers of climate change. What's this leading to? Well, you know, how's temperature and things changing? Then, how will this affect biodiversity? What are the kind of different components of biodiversity? What do we know about their responses? And ultimately, the important bit is this kind of bottom strand. How does that translate through to impacts on society and the goods and services we deliver? And this work has been published. There's a QR code there, which you can kind of look at this in more detail later. This work was done in conjunction with scientists and experts from all 8 members of the ROCME Sea area, the 6 GCC states plus Iran and Iraq. And the purpose of it was to try and establish this kind of authoritative regional baseline of information, drawing on knowledge and expertise from around the region. I mean, you can talk about this in detail. I mean, in terms of the climate change drivers, just a couple of the key points. Many times when people talk about climate change, we see pictures of melting icebergs, we see pictures of kind of stranded polar bears. Actually, in many ways, the Arabian Gulf, the hottest sea in the world, is actually at the forefront of climate change. There are issues around melting glaciers. What we are seeing in Europe and a number of areas is, as our waters get warmer, the warm water adjusted species from the south are moving north and replacing the cold water adjusted species, which are again moving closer to the poles. In the Arabian Gulf, as it is the warmest sea in the world, there are no species which are adapted to warmer conditions that can move in to kind of fill these ecological niches as the waters get warmer. And in terms of the kind of drivers, what we see is in the Arabian Gulf area, there are rapid temperature rises, and this is very significant. If you look at the kind of outer ROCME Sea area, the coasts of Oman and the kind of northern Indian Ocean coasts of Iran, there it's potentially changes in cyclone frequency, which may be very significant impacts. Again, I'm not going to go through this slide in detail. You know, what are the impacts on biodiversity? What do we know on the kind of responses of different species and habitats to climate change? I mean, just to pick out a couple of examples, we're all very aware that coral reefs are considered very sensitive to climate change. We've seen a lot of bleaching in the Gulf. We've seen bleaching around the world. Recently, you may have seen kind of headlines about a major bleaching event in the Great Barrier Reef, and that's known to be very temperature sensitive. But conversely, not everything is as sensitive, and the evidence suggests that many seagrass species can actually be quite temperature robust. So whilst we talk about climate change, you know, it's easy to get a bit lost in the doom and gloom, but there will be kind of what you might call climate winners as well as climate losers, and it's good to keep that in mind moving forwards. So, and then each of these steps, you know, there's a lot more detail behind this. How does this translate to impacts on society? We've been hearing about the importance of fisheries and aquaculture to society. Yes, we do very much expect to see changes there. There will be changes in the availability of different species as they move around, as the suitable habitats for them adjust. There can be impacts on the very fast-growing aquaculture industry in the region. At-sea cages may be more exposed to increases in harmful algal blooms in the kind of areas in the outer Rottnest Sea area. If we see increased cyclone activity, the kind of physical risks from adverse weather conditions. Also, something that came up here in our study was the impacts on kind of water and energy security. Desalination is critical in the region. It's what many of the kind of cities around the coasts of Saudi Arabia and the GCC depend upon, and they are exposed to physical risks, sea level rise, increased storminess, but there is also potential for increased jellyfish blooms, increased harmful algal blooms, and there have been examples around the region of desalination plants being having to close down for several days at a time in response to blooms. So there are a number of mechanisms by which climate change can affect the societies we all live in and depend upon. So anyway, the evidence review came up with this very long list of things that you could be worried about. We don't have the time, the resources to really kind of run around and to address all of them. And if you start trying to fix the small problems, you're not putting the time and effort into addressing the main problems. So that's when we took this evidence review and went through a kind of risk assessment process. We composed an initial, what we called long list of risks, 15 related to biodiversity and habitats, and 30 risks associated with society. And we said, what's the relative concern around these different risks? And this is following an approach similar to what's been used by the International Panel on Climate Change, the IPCC approach. We looked at the proximity of impacts. When I say proximity, how soon are they going to happen? Are these impacts we're seeing now or going to occur in the next few years? Or are these impacts that might occur at end of century, and so they're not so pressing for us to worry about now? And we also looked at the magnitude of the potential impacts. Is this something that might just have localized impact on a species at a few bays, or is it going to have a regional impact? We find when trying to do this kind of whole of a marine ecosystem, whole of society risk assessment, that the amount of information and evidence available to you is very patchy. And you kind of say, well, do we just use the really good qualitative scientific evidence to provide our advice? Or do we allow ourselves to use a kind of wider set of more kind of loose information sources, maybe studies done in other regions which are applicable for this region where there hasn't been so much studying? And so amongst all this, it was important to look at the confidence in the assessments. And again, following the kind of IPCC approach, with all the risk assessments, it took account the confidence in terms of how much evidence is available and whether or not it's consistent. I won't go into the details of the kind of scoring process behind the risk assessment, but the different risks were assigned to scores on their proximity, how soon they occurred, and the magnitude. The magnitude considered both the environmental magnitude of the impacts and also the social and economic magnitude of the impacts. And that's just kind of illustrative there of some of the kind of criteria used for environmental impacts. And then you bring these together to get an overall risk score. Don't worry, this is all documented and I'll provide you with links later. I won't go into this now, but just to show there is a kind of repeatable and documented process by which we come to these conclusions. So I guess in many ways the kind of, what is the answer? What is it that we're worried about at the whole of Rockme Sea area region? And you can see the kind of traffic lights there going from the greatest risks at the top. There's a lot of concern around coral reefs, that's well known. There was surprisingly what came out of this was a concern about potential increases in harmful algal blooms. I mean, that you can see there's less confidence associated with that conclusion than there is about the conclusion on coral reefs, all the way down to things like, sandy beach habitats and seagrass habitats are considered less at risk at climate change. But through this, you can start drawing out where is it we need to focus our attention for kind of management and responses. That was for the whole of the Rockme Sea area. We then broke down the results by the different regions, because part of the reason the HABs is coming out there, that was very much driven by changes in the upwelling that we might see outside the Gulf, so driven off the coast of Oman and Iran, where they do have this upwelling system, where there already are very large algal blooms. This is showing for the inner Rockme Sea area, and you get a slightly different breakdown, and at this sub-regional scale, you can see different risks coming out as being of priority. So those last tables were just the ecological risks. We then brought this all together alongside the socioeconomic risks, and you could bring them out and you could see things like coastal communities' impacts from the physical damage of climate change, declining fisheries productivity came out, and again, you can see how is this going to affect society, what are the costs we may have to bear for this, and again, this enables this kind of systematic and strategic view of where we need to focus our response efforts. And again, this risk assessment is available for anyone to see, and there's far more detail there. And as I explained at the start, I will not attempt to go through all this in detail at this stage. So that's all great. We've kind of wondered what's going on with climate change. We've kind of got some evidence together. We've identified some high risks. That's great. None of that is actually leading to any change on the ground. What you really need to get to is what are the adaptation actions? How can you build resilience to these changes, bearing in mind they're occurring? So within this exercise, we looked at some of the high risks that came out: fisheries, coral reefs, desalination plants. And again, looking back at the sort of approaches applied by the IPCC, when they talk about building resilience, this gets broken out about kind of physical resilience building. This is kind of engineering solutions. You can build seawalls to protect against flooding. You can try and do kind of coral replanting and these active physical interventions. But there are also adaptation actions and resilience building things that look at an institutional approach, kind of economic interventions, insurance products. How do you kind of make society more robust to these changes, and also kind of social changes and how we as our behavior and our education can adapt. I mean, in the few minutes I have left, I'd be very happy to talk about this at much greater length. I mean, just to give you the kind of flavor of the sorts of things that came out of this. For fisheries, we applied, kind of a hazard control approach, which is more typically applied in a health and safety environment, about minimizing impacts and then how you address the downstream consequences. And you can see one of the key points that came out of this is healthy fish stocks and ecosystems are more resilient to climate change, and I refer you back to the previous talk. And I guess one of the points there is investments in good environmental management are investments in climate resilience. But there's also, engineering things you can do around protecting the infrastructure for fisheries, diversifying the range of species that you catch. Again, it's kind of spreading the risk across a wider ecological portfolio, if you want to use those terms. Corals, I guess we hear a lot about, you see these lovely photos of people planting corals out and coral gardening. This is great. We can do these active interventions. But whilst the temperature is still killing corals, whilst we have sediment runoff from coastal developments going on, we can carry on planting corals all we like, but if the pressures that are killing them already are still there, they will carry on dying. And it's a bit like if you want to fill your bath, the first thing you do is you put the plug in. You can turn the taps on as much as you want. If there's no plug in the bath, it's not going to fill up. So much like with fisheries, one of the main ways of building climate resilience is to protect what you have now and minimize current pressures. Briefly, of desalination plants, I mean, as I said, these are critical to the communities around the Gulf, and there are a number of both physical risks there, storminess, flooding, sea level rise, storm surges, but potential kind of ecological risks around harmful algal blooms and jellyfish blooms that can very much impact them. And there are things that can be done at a local engineering scale in relation to individual desalination plants, and then there's a kind of wider strategic, systematic way about how can the societies of the region look to minimize their demands on desalination plants to build their resilience. So, just to kind of wrap it all up, there are a number of far more detailed technical reports available on the ROPME website via that QR code. I had to cover, or I chose to cover, a lot of material at high speed there. I guess some of the points I wanted to make is that climate change is impacting the Arabian Gulf, the ROPME Sea area, the waters of the Kingdom of Saudi Arabia. This will continue to occur. This has significant impacts on our ecosystems and our biodiversity, but this also has social and economic impacts, and those are the bits we really worry about. It is possible to undertake detailed studies which focus and can provide evidence-based kind of recommendations on actions to take, and the sorts of approaches I've just run through there are kind of repeatable, they're well documented, and you can apply them at a kind of municipality scale, at a national scale, and for just sort of individual climate pressures rather than all of them. So if you kind of take your studies forward, please do consider this style of approach to evaluating the long-term risks we face and how you can kind of develop prioritized and strategic advice. Thank you.
Thank you, Dr. Will, for the informative presentation. We have time for just one question. One question, please.
I think everyone's hungry.
There is a correction. Actually, we will continue with the parallel session. We have 3 sessions, 3 lectures each in this room and another room. So afterwards only we'll go for lunch. Yeah, please. Yeah, there are 2 questions. See, already they are here.
Yeah, I am hungry. I'm interested in things that we could be growing, like in the sea, that might actually be good. Like in front of my house in the Shetland Islands, there's a mussel farm, and as far as I know, there's not a whole lot of damage that occurs from mussel farming. We have salmon farms as well, but the salmon farms, the salmon is fed, and they're fed with colored pellets. So the white fish in the area of the salmon farm are now pink because of the salmon farms in Shetland. But I'm wondering if there's something good that we could be farming. I'm also wondering if there's seaweed that we could be growing and eating. Thank you.
Yes, I will go with the short and simple answer rather than the long and complicated answer. All of the choices that we make in our life about our consumption patterns and our production patterns have different implications for their impact on the environment. There are less impactful ways of producing food and resources and more impactful ways, and as you've identified, things like bivalves and sort of seaweeds can provide resources with less impact than some of the other kind of resources we extract from the sea. It's a very generic answer, but that's the short and simple answer. Yes, there are things we can do which are more beneficial than other choices.
Hello, my name is Zahra and I am a chemistry student, still undergraduate. My question is, you said the team had their work interrupted because of COVID. I was wondering if there were any noticeable changes after the team came back to work after lockdown ended.
Yes, I mean, I guess what I should clarify is this study was based on existing evidence. We weren't collecting new evidence, because when you try and look at kind of whole ecosystems at a regional scale, we weren't commissioning new surveys. It was based on kind of documented existing surveys. So the time scale we were working at, it hadn't allowed kind of new field studies to be written up and published. So I guess that's a simple answer. In terms of our working, the main thing we noticed is everyone we were working with across the region now appeared on a small screen rather than around a table in front of us.
Thank you so much, Dr. Will. We are looking forward for the collaboration, future collaboration, fruitful collaboration. We completed our today morning sessions for the keynote speaker sessions. Now we have parallel sessions, one for the marine ecosystem, which will be conducted here. We have we have 3 presentations under marine ecosystem, which will be conducted here, and 3 other presentations in room number 103 under technology and fisheries management. So I request people to redistribute. Some of the people should be definitely there. And those who are interested in the technology and fisheries management, they should go to room number 103. And here, marine ecosystem will be continued. I call upon stage Dr. Marius Jerimko from King Abdullah University of Science and Technology to deliver his technical speech.
Perfect. Okay, perfect.
Hello, there is a correction. Parallel session will be conducted in room number 101, not 103.
Yes, so I'm happy to be here, and I'm glad that I was invited and the opportunity was given to me to tell you how to be healthy and functional, and how NMR techniques, biophysics, and metabolomics can help us to see connections between our health, this what we eat, and between this what we actually, the way how we are living. So just to understand our life, we need to go to molecular level, which will tell us how our proteins are folding. And folding is a complicated multi-step process that depends on many factors, environmental factors, like nature of the solvent, temperature, pressure. And there is an Amphibian dogma that tells us that the entire protein structure is encoded within its amino acid sequence, but we see that also environment matters also on a molecular scale, not only on the macro scale, like in our case. So we have a very complex biological unit we are constructed from. This is cell. And in cell we have proteins that are structured and unstructured, and the ones which are unstructured, their fraction is quite high, as we see, especially in eukaryotes. We are all eukaryotes, and once they encounter their molecular partner, they adopt proper shape and they gain function. Thanks to this, we are functioning. And the problem is that not always protein folding goes well. sometimes it goes in a wrong direction. It results in many molecular problems. Some of them are not so toxic yet, like soluble fibrils, but when they grow, they become insoluble, and we see these protein tangles in many diseases, like Alzheimer's diseases, like Parkinson's diseases, and many others. But honestly, we don't know which oligomers are poisonous. I would bet that the ones which are soluble are still poisonous, not the insoluble one, because if something is insoluble, it's not achievable to the molecular system anymore, unless the amount of deposit is so high that amyloid pores are formed and content of cell is released and cell simply dies. One of the main problems connected with the increasing prosperity in many countries of the world is diabetes type 2. Now it's dominating type of diabetes, about 90% of all cases, because this is simple truth, we are overfed. And we need to battle it. It's also, this disease is also related to aggregation of protein called amylin. And in my group, we were, among many other projects, working on the identification and isolation of compounds from seagrass. We heard a lot of good things about seagrass, and now we will hear some more. And these compounds have really interesting features because they resemble many already existing inhibitors of amylin aggregation, and they have three-dimensional structure and high molecular flexibility. And these 9 and 10 are very interesting. On the next slide. Yes, so on the next slide, you will know why they are interesting. So, because they can create networks of hydrogen bonds. And, yes, it works. So now we see that there is compound 9 and compound 10. And compound 9 has very interesting feature. It means it has lower mobility than compound 10. Why is it important? Because the hydrogen bond donor, OH, and hydrogen bond acceptor, O, are on the opposite sides of the ring. And when we see that we add our compound to the amylin, it facilitates the aggregation. Really promotes it about 1,000 times. It occurs faster. Why? And why the compound with open ring, when we add it to amylin, we observe inhibition like 10 times. The explanation lies from the networks of hydrogen bonds, because in case of rigid ring, like rigid 5-membered ring, we have in case of compound 9, we can observe such, this is our hypothesis, such phenomenon that when beta sheets are formed, because beta sheets are the most important secondary motifs for the aggregation, then this compound enters in between beta sheets and supports the formation of the plaques, because contributes to the hydrogen bonds formation. In case of compounds that has open ring and it's much more flexible, these hydrogen bond donors and acceptors are theoretically also observed in its structure, but they cannot actively participate and foster the network of hydrogen bonds. That's why aggregation doesn't occur so quickly. This is how we can act against the diseases related to food on molecular level. And here I would like to see to show you the general approach to study food and also our metabolites, how our organism processes the food. This is so-called metabolomics. And this is very, very, let's say, broad discipline. Main methods which are used for metabolomics are here. as one can see, NMR and mass spectrometry, what I mentioned before. But there are two main things, actually drawbacks of these methods. That's why they are complementary. In comparison to mass spectrometry, NMR is far less sensitive. It means we see much less, especially it corresponds to compounds which have low concentration. But in the case of mass spectrometry, if we go deeply into the method, we see that there is one problem. With mass spectrometry, what we observe, we don't observe mass of the compound we study. We observe M to Z, so mass to the charge of the ionized molecule. So mass spectrometry is a destructive method once. We do not see the molecule itself directly in a native state, and there are groups of molecules that do not ionize. But there are further consequences of this approach for mass spec, that we cannot study natural relations between the amount of one metabolite to another. That is why here we are in the moment when NMR comes into play, because NMR is non-destructive methods that offers us a possibility to see the metabolites in their native state, so it means in natural relations between themselves, and we can also draw more conclusions thanks to this knowledge on the basis of metabolism. There is also, as I told you, in case of NMR, the sensitivity is quite low, but there are possible some improvements we developed in my group. I know it looks a little bit scary, but thanks to the modification of pulse sequences we use in our measurements, we can increase either sensitivity and also the resolution of our spectra. And resolution of our spectra can increase up to 20 or 30% metabolites we can distinguish from our mixture, which is a lot. And we also can increase intensity, and I will now show you the example. In collaboration of Date Palm Institute in Al-Hassa, we are actually conducting one project that we would like to correlate the level of maturation of dates with the level of metabolites, nutrients in them. And there is a problem with dates that sugars are the most dominating metabolites. So, thanks to the fact that they have specific chemical shifts in NMR, we develop the method, as you can see on the right slide with respect to the observer, that with the sugar suppression method, we have significant increase of the signals of metabolites of different types than sugar, and we can simply analyze them despite the fact in normal NMR spectrum, sugars sugar signals overwhelm other metabolites. But thanks to application of our methods, selective elimination or decrease of sugar signals, we can study also other metabolites in dates and their ratio also with time. We also develop, here I will not show methods to selectively getting rid of some fatty acids and nucleotides, thanks to their specific chemical shifts. So this is what I wanted to show, and I'm ready for questions.
Hello, my name is Zahra and I'm a chemistry major.
Yes.
I would like to ask again, even though this is, I believe, something you already mentioned in the slides, but I would like more clarification.
No problem.
Yes. About the NMR, you said that it has a lower sensitivity, is it because it is able to study things in their natural without altering them? Is it this case? I did not quite
And no. It's because of Boltzmann distribution and the and our availability of excitement of molecules with the energy transfer on the molecular level. It's in molecular physics because of the Boltzmann distribution when we have molecules in magnetic field. So some of them absorb the energy and go to the higher energy state, and these ones we see, but some of them not. And the ratio between the ones which go to the higher state in the external magnetic field and which don't, it's called Boltzmann ratio or Boltzmann distribution. And unfortunately for us, spectroscopists, it's not in favor of our studies because really tiny minority of molecules go for these excitement states. And there is also another issue that isotopes we are very often interested in. Luckily, it doesn't apply to proton, but isotopes like C13 and 15 we are also interested which are important for biomolecules, are in low numbers in terms of natural abundance. I mean isotopes like C13 or N15, so the ones which are active for nuclear magnetic resonance, it means we can see them and do not have quadruple effect.
Thank you very much.
You're welcome. Yes. Okay, so time is done. Yeah. Okay.
Thank you so much, Dr. Marius. Our next presenter is Dr. Amal Al-Khamdi from King Saudi University. Dr. Amal, please.
I have to introduce myself. My name is Amal Al-Ghamdi. I am an assistant professor at King Saud University, Department of Botany and Microbiology. I recently completed my PhD at KAUST. And today I want to thank the organizers of the second GiKS or Green Future Sustainability in the Kingdom of Saudi Arabia to give me the chance to present my research. So given the massive global challenges on the food security in the coming decades, securing yield is one of the importance in sustainable agriculture, with the crop loss projected to reach up to 60% by the coming decades. It's an issue to secure yield and improve the crop yield by applying eco-friendly solutions. It's an issue in low-lying land of sub-Saharan Africa, as the rice farmers have a significant loss of the rice yield from 3 to 6 tons per hectares per year to 1 to 2 tons per hectare per year. It's resulted from the sea level rise, resulted in the flooding and saltwater intrusion and prolonged dry seasons. It's unfortunately affecting the rice farmers, as many of the rice farmers have to abandon up to 30 hectares of their rice yield, mainly due to salt buildup. So the actions are required to secure yield in the main producers of rice in Nigeria, especially with millions of Nigerians lack food and many millions of their children are malnourished. As scientists, we noticed that whereas plants suffering from high salinity and flooding may have a hypoxic effect leading to damage or plant death, like mangrove plants, where they have the ability to grow in the coastal shores under these conditions, some other plants may survive at the same conditions. So we believe that Abyssinia marina or gray mangrove in the coastal area of the Kingdom of Saudi Arabia, they have the ability to live under these conditions and thrive in the same time. So we hypothesize that these plants are hotspot for biodiversity and the niche for eco-friendly solutions that we can use to support the living or growth and sustainability of other crop plants. We choose the Nippon Pari rice as it's well-studied genomically, it's sensitive to flood and salinity, and it is also having similarities with the Avicennia marina genetically. So we ask the question, are the bacteria indigenous on the Avicennia marina able to help other crop plants? Actually, we answer this question for the desert plant. We have a huge collection of bacteria derived from desert plants, and we prove in our lab that we can use it to help other crop plants. So the main objective of this study is harnessing the microbiome of the mangrove plant to help support the growth of other crop plants under saline conditions. And we reach this approach by enhancing the crop yield, improving the salt tolerance, and fostering sustainable agricultural practices for increasing productivity while preserving the environmental health. To reach this, we did many approaches. First, we have to study the microbiome using cultural independence. And we use the plants in the soil area, in the coastal area of the Red Sea. We divided the plant into different compartments, including leaves, roots, and the area around the roots, the rhizoplane and rhizosphere, and also the endophytes of the roots. Then we extracted the DNA, or what we spoke about, the environmental DNA, and we amplify it, and then we identify the biomarker taxa, the important species there, and we try to study the function and prediction of these organisms. As we use the amplicon sequence variances, it was 100% similarity of the species that we can find. And we successfully covered over 40 phyla, mainly affiliated to Proteobacteria, Firmicutes, Bacteroidetes, and Actinobacteria. For the abundance of the genera, we have found also, here I'm showing the relative abundance of over 0.10%, and it's showing here the red, the high abundance, and the blue showing the low abundance. And we can see that there is an effect of origin on the ASV we found in each of the compartments. Then we tried to nitrogen fixation genes, etc. Nitrogen fixation genes, etc. So we have found that these functions indicating the role of microbiome in the plant growth and sustainability. After that, we tried to isolate these bacteria using cultural analysis, and we have found a number of strains. It's showing here the 256 case strains. We call it Avicennia caust strains, and we found that they are mainly affiliated to Proteobacteria, and they're derived mainly from the rhizoplane and rhizosphere, and very few, 9%, were coming from the roots. For the plant growth promoting traits, we also test the bacteria, and we found that over 50%, reaching 80% of them are positive for the iron sequestration, which we call it here siderophore production. They are also positive for pectinase production and other plant hormones like aminoacetic acid hormones by over 50%. These strains were all mainly highly tolerant, so they resistant to high salinity, and they are resistant to high temperature. After that, we reached the point when we answer the question if we can use this bacteria to help other crop plants overcome stresses and while increasing the growth. And we tested this collection first on model plant. Then we found these two best performing bacteria, and we sequenced them, fully sequenced them. And we found many characteristics showing that they have the ability to tolerate stress, as well as induce the growth of the plant, as showing here in this table. The two strains are, we call it AK164 and AK171. We try to test this on the crop plants we mentioned before, the rice, and we investigate different parameters like biomass, yield analysis, and physiological assessment. In this slide, I'm showing the outcome of the greenhouse experiment in the normal soil where we don't have any stress. And in the top, you can see the differences in the number of tillers, which are the number of the leaves that's carrying the seeds. And we found a significant enhancement below in the number of tillers when we compare the yellow boxes, which is the control, with the other boxes, which is either of the two bacteria or their combination. In the middle, you can see the effect on the panicles or the structures that are carrying the seeds. And below, you can see the different differences, significantly increase or enhancement, differenting between the mock or the control in the yellow box with the other treatment with the two bacteria and their combination. And also, there is a significant enhancement of the spikelets per panicles, which is a parameter for the yield increase. The last one, in the right, you can see the effect on the grains, which is the yield. The top showing the effect on the size of the grains, comparing mock or control with the combination treatment. And below, you can see the effect on the size, the length, sorry, of the seeds. Below, you can see the significantly enhanced of the number of grains per plant and the weight of grains per plant comparing to the control. So we can see here clearly that this inoculated plant with our bacteria shows enhancement in the grain weight, number, and length. This is the same experiment where we can see the effect on the plant on this saline environment. We can see the same pattern. So the main feature of our research that using this bacteria with the seeds enhance the biomass, double the biomass, sorry, and enhance 10 times more panicles and 4 times yield. It's interestingly that this combination also shortening the life cycle of the rice, which means more harvest per year for each farmer without affecting the yield. Here I have to show this because it's one of the mechanisms we found that this bacteria, as you can see in the last column, the sovereignization is helping the plant to make the roots more rigid and decrease the radial oxygen loss affected from the hypoxia condition. So to conclude, we can say that using our bacteria is helping the plant to do some molecular changes and affecting the hormonal of plant that we treated with, and then we found the symbiotic benefits in the plant growth and yield. Actually, this research showing us that we can test this synthetic community on other crop plants like wheat or maize, and it's also reproductive for the benefiting the Saudi Green Initiative of planting more mangrove trees around the kingdom. With this, I have to thank my employer, King Saud University, and my previous school at KAUST and supervisors. Thank you so much for your attention. Is there time for questions? Okay.
Thank you, Dr. Amal. We have time for one question, please. One question.
First of all, thank you so much for your wonderful presentations. Your data looks really amazing. Actually, I'm from animal biology. I'm an animal biologist and not from the plant. But since you are talking about the stress-related issue, I just want to ask you, because in the stress, there are two factors, is a long-term and short-term. So in your study, you consider what duration the stress, long-term, that is acute or chronic?
Yeah, it is long-term because this variety of rice we use is sensitive to salinity and waterlogging, so they cannot produce any seeds or yield if they are continuously affected with salinity. But for the purpose of our research, we have to give the plant some time to revive again, and so we can compare it with our treated plant. If we treated the plant for the 3 months with salinity, the plant will die. So we have to have some space for the plant to thrive, and then we can compare the yield. So I think the yield is taking more than four months to produce. So this is a good amount to test the plant for this.
Because in animal, if you continually give the salinity changes, the species can able to adapt. Is there a condition in the plant?
No, the plant will die. Actually, you can see the image I just showed. The plant was suffering. So even the seeds we got from the control is empty, mostly empty. It's like nothing for rice farmers to have as the effect. When we use our bacteria, it's different.
Is there any biomarkers are you concentrating to check the stress-related issue for the plant?
If you mean the glycemic index,
yeah,
that's in the process. Actually, we are not done. We just have this data from the greenhouse and some of the physiological characteristic of the roots. And genetic also transcriptomic analysis we did, and we found the genes that is upregulated with the use of our bacteria. So I think it's an alteration of the genetic makeup of the plant.
Thank you so much. Yeah.
Thank you.
Sorry, we have to move on to the next presentation. Dr. Amal, once again, thank you. Next speech will be by Engineer Khalid El Nabot, and he's representing International Federation of Surveyors, and he's a national delegate of Commission 3, Spatial Information Management. Engineer Khalid, please.
Assalamu alaikum. Thank you very much, King Fahd University, Dr. Loai and his team for giving me this opportunity. Our relation go back to more than 10 years we have been working. The topic of my presentation is related to technology, but the team of Dr. Loai decided that this must be presented, and we were lucky that we can also show it to you. I have to say the technology is outside presented. I am talking in my role as a national delegate of the International Federation of Surveyors, but some of you might know that I'm also involved in the private sectors, otherwise I cannot pay my trip. So, I would prefer to keep it, as you see, the logo of the conference and the logo of the university, since I want to advertise today not the organization who supports the university, I want to support the university who invested in this important technology. I will be talking about bathymetric topo survey. It's a very new technology. I have done my PhD 2006 about LiDAR for urban survey, for terrestrial scanning, but a few years ago we start to use, instead of a red laser, a green laser. Why? Because we want to penetrate through the water, we want to have the surface of the water, and we have to see the seabed. So how it's working, this is the topic of my presentation, and next slide should be right, yeah? Yeah, here we go. So overview, I will be talking about this technology, how it's used, the limitation, and for sure some performance and application, and I will have some case study to show from the region. We have also an example, very nice, which will be at the end. It will be the same as the gift we saw before about the application. Here we go. This is an example from Italy. I don't know if we have someone from Italy here. This is a very nice example from Italy. And this is showing you the advantage. So we have a high resolution photogrammetry. And when we use the LiDAR for bathymetric, we are measuring. And this is a bridge where I will talk about the application later on. This is a bridge between where acosonder cannot go, sonar, or even a traditional survey. So there is a gap, and we saw a wonderful presentation yesterday and today about terrestrial and about underwater survey. Coral reef is very important. We say we need to protect it everywhere, but how we can protect it if I'm not allowed to measure and monitor? And this is what you can see. Again, here we go. This is typical data, what you get. You can measure the topography under the sea level. You can measure the sea level. For sure, we have some limitation. I'm not going to say this is a great solution. It has also some limitation, but the development in the past 3-4 years have been really great. So the principle, it can be mounted on different platforms. The principle is sending a green laser, which we call it the green wavelengths, and then transmitted is the laser pulse reaching the sea. And the advantage on the water surface, there will be some diffraction here, you will see, but there is a solution how we can correct it. So I am receiving also an echo signal, and based on that, I can measure my water surface and for sure underwater. So how it's working? Here we say the refraction correction. How I do my refraction correction when I hit the sea level, this is the laser. There's a dot, we call it point cloud. I don't know how many people are familiar with the LiDAR technology. We calculate point cloud, the density of the point cloud. This is the accuracy I'm getting. And then later on, I calculate my sea level and for sure the refraction in order to absorb the better, as much as better result possible. So carrier platform, I mentioned before, and you will see it live. This is what I like if everybody interested, or anyone interested, just to have a look. You can see it outside. It's a real bathymetric sensor which mounted on a helicopter UAV platform. But it can be mounted on an aircraft. We have already, since 2 years, an aircraft running a great project, which I will show at the end in the region. It can be mounted, as I said, on a drone or even on a helicopter. We can have a pod, and on the pod I can mount it on the front of the helicopter, because sometimes helicopter, let's say, is less and easy to rent in the region. So each platform has advantage and disadvantage. If we are dealing with government, then it's easier to use because they can get easy permission. A drone is a very sensitive topic, needs special permission always, so that's why. But we are very flexible to mount it on different. As you can see here, some of the results, the great advantage that you can also still absorb and get some data, point cloud from the terrestrial. So you can combine. Here we go. So bathymetric depth measurement. So I am looking to measure the depth, and I want to check mainly the object and in the water columns. So in this case, when you are measuring, you are getting such a nice color map, and you will see some noise. This is a noise reflection for sure from area where I cannot not reach. So in this application, especially on a shallow water, is very, very helpful. And here is the example. So different application can be a coastline area where you need to measure. It can be for acquiring some data. It can be also for an inland for some rivers. If the water clarity is enough, which I'm going to talk about how we measure later on, because there is definitely some limitation, and I'm going to explain it later on. So different application example, as you can see, and what is the expected performance of the sensor? So we got, for sure, some factor which can impact the performance, and it's simply how clear my water. Is it a black water? Definitely no chance. Is my water clear? I have a lot of waves. How is the weather condition? All play a role. This is a factor can impact my good result out of it. So to be very critic, it is a great solution, but it is not a unique solution what I can use daily. So I need to look to some condition of my weather, of my wave. Is it after the rain, before the rain? They are all factors which I need to be considering before I start, especially for the observing, as you see on the sea flood. So we have used, for sure, different factors on the VMOC state, as you know, code where you can measure. So even if I'm going to fly on my platform, I have a limitation on my speed. So we recommend definitely 5 pound meter per second to get a good result from the bathymetric measurement. And this is showing you the wave height and the characteristic showing the WMO sea state code. So Seki, how I measure Seki? Who was familiar? For sure you know the traditional way where I use the target. Everybody know, reflection, white, black and white is important to see the clarity. So I need to measure my Seki depths, and for the one who is not so familiar with it, simply the bathymetric sensor we are using, we call it times 1.5 clarity of water. What that mean? Red Sea is great. I can see even sometime when I'm flying over up to 10, 50 meters, still the water very clear. And in this area where it's not allowed to send ROV or send the surveyors because he will kill this nice coral reef. So there is the only solution to cover this area. The gap, we call it the gap exactly between. And if my water is clear and I can see with my visual eyes up to 10 meters, I guarantee for you I can measure up to 15 meters down. We will see some example now from a very, very close region where we are now, and amazing photo. For sure not so nice as the others, but I selected some nice where you will love it, some nice results. So how it's working? As a private organization, we are sponsor and a German organization from the private sector now. And here, how's the solution? We work with a Regal since years, and this is the sensor which I will be talking later on. This sensor is mainly made for a platform, for an aircraft. But how it's working, as you can see, you are capturing and combining topographic survey to a bathymetric survey. So the airplane can combine a red and a green laser. Red laser for terrestrial survey, a green laser for an underwater survey. Both of them are delivering a point cloud data. I can add also a high-resolution camera. We have implemented in one Diamond 62 aircraft, which is in the region. We have full access and using this solution. And we are talking here about 65 kilo sensor, so it's neither quite a good platform, but the same technology, it's outside mounted on a drone helicopter. It can be also used. It's the same principle. So how it's working, you will for sure familiar with. You can immediately stream and see your data. So the controller in the airplane, he can send the data also to the ground. And this is explaining to you. So as I said, it's not the great LiDAR data from terrestrial because this laser is made not for purely terrestrial. So if you are going to make only terrestrial survey, we have another, which is a red laser. But in this case, it's more than enough to know my trees, and especially about the presentation before mangrove was my question related, how are you surveying, which platform you are using? For mangroves, I think it's great because when we are using a red laser, I can penetrate through the leaves and I can measure the under the water. And what if I'm measuring the water and the seabed, that means this is the most important information I need. So this is another example from some rivers we have done. Topographic survey, and jump to the next, because I know I am the bad guy who is standing between you and the lunch, but I will promise to make it as fast as possible. Good. This is an example we have, I mentioned before. 2 years ago, Dr. Luai was really eager to get the solution, but the Center of GIS in municipality of Doha, they bought Diamond 62. This is their own aircraft. We have integrated, we took one of the seats. As you see, the Diamond 62 aircraft got 4 seats. So everybody can afford, if you like, to buy an aircraft. But we decided here, in this case, to use it for the survey. So we get rid of 1 seat, and we put very nice sensor, the bathymetric sensor, as you see here. In this case was the 880 G2, and you can see it It's also with camera. You can have a high-resolution camera. And this is from inside the aircraft. I like to show the case, how it's working. So the nice operator will be sitting behind, pilot, co-pilot, and the mission already done. So the Center of GIS and the municipality of Doha, they have done a great project. The idea was to protect, the same as going in the Red Sea or in the kingdom. But for sure, the size of Qatar can maybe allow to finish the project faster. So the project is already actually done. We finished end of January. Today is done, but they will be monitoring every year. So this is why they invested in this technology. So they own the technology. Some nice case result. Now you see also nice photos like everyone, but I would like to show you some result more. This is what you get. This is also a preliminary result of the survey, but we can see that we have 0.50 digital elevation model out of the nice picture you saw before. Here again you can see 2.5 meter minus 10 meters, so I went under 10 meter to measure simply. If someone familiar with Qatar can recognize some, I love the last one, which is really giving me a tree inside the water or underwater. Well, and as a summary, so the airborne bathymetric sensor is a great solution. I am done, summary. So it's a very useful solution, but still has some limitation. For sure, we need to look of an optical method, LiDAR bathymetry. Water quality, I mentioned before, is very, very important. The water as clear as better to measure. We have a data over 20 meters already depth, but the water was really amazing, clear. And for sure, water surface condition is very, very important. In sea or in the river, the bottom characteristic play also important role. That's it. I am at the end of my slides, and I have to say I choose this as the last second because my presentation was last second. I like the slide. I like the university. I have a relation for the university over the last 12 years. But we have done with the team of Dr. Loai a great job, and our team, they have done a 3D scan of the university. I recommend everybody to look to the data. As a not a bathymetric, it's only LiDAR survey of the whole building. And I recommend everyone to have a look and see this nice result. Thank you very much. Enjoy your lunch.
Thank you, Dr. Khalid. We can go for one question, please.
Thank you.
Myself, Abu Bakr from Qatar University.
Oh, great.
It's a very nice presentation. And it's wonderful to see very high resolution bathymetric data. But the problem for us researchers, it's very difficult to obtain the data for us to do the research, due to strategic reasons. What is your comment on that?
I can guarantee for you 100%. You can get my contact later on. I am a good friend of the Center of GIS head.
Okay.
And he is a very nice person.
Actually,
he is very open to cooperate,
Yeah.
and I'm sure I can guarantee for you after to get you in touch and to get the data.
Thank you so much, because it will be very useful for us for the numerical modeling for hydrodynamics, waves, and so on.
I mean, you are a Qatar university, you are not private, so
Yeah.
they are also a government, so they support a lot of universities. As long as you are not going to use it for, let's say, private purpose, it's fine.
Thank you so much.
Thank you.
Thank you, Dr. Khalid. There's a special announcement. Let me call upon stage our Honorable Director, Dr. Loai. He will be announcing the Best Poster Award of yesterday's sessions.
Sorry for disturbing you again, and thank you for attending this event. And we are looking to see, inshallah, more of interaction. Just would like to announce as an appreciation for posters, without ranking, just the best three, we believe, according to the committee that we formed, لمياء السلمي جامعة جدة University of Jeddah Department of Biochemistry لمياء السلمي. She's around? Okay. Can we have? Yeah, come please. So let us call. غادة أبو الخيل أو أبو الخيل إمام عبد الرحمن بن فيصل يونيفرسيتي. فادية. Okay, yes, we need to announce she's not around. فادية البعيمي إمام عبد الرحمن بن فيصل University. Thank you for everybody. Let us go to our lunch, okay? And we'd like to see you again after the lunch. Thank you. Thank you very much.
Good afternoon, esteemed guests, speakers, and participants. It's my privilege to welcome you to this afternoon session of GiKS 2025. My name is Rinad Safi, an undergraduate computer science student at KFUPM, and I'm truly honored to serve as your host for today's inspiring discussions. Under theme 4, Smart Technologies in Environmental Monitoring. To commence this session, we have our first keynote speaker, Dr. Jico Burrell, the Deputy Director at the General Organization of Coral Reefs and Turtles in the Red Sea. He will share insights into ecosystem management considerations in the face of coral bleaching. Please join me in welcoming Dr. Burrell to the stage.
Very much, and good afternoon. Salam alaikum. It's a pleasure to talk after all those fantastic talks this morning. So, we're going to talk about coral bleaching, and can I advance these slides on the stage, or? Okay. So, I'm sure a lot of you know what coral bleaching is, but in case anybody doesn't, it's something that it's a term we use to describe corals that go white. And the reason they go white is because they're stressed. And corals actually get their color from microcellular algae that live in their tissue. And if they lose them, you can see straight through their tissue. And you can see the skeleton on the other side, which is white. So it's a bit like looking at your arm, and you can't see any skin or any flesh, but you can see the bone. And essentially, it happens because they're stressed, most often by temperature. So this is actually a time-lapse video. It's not at real speed, but it's showing what happens to a coral when it loses the microcellular algae that live in the coral tissue. This is a coral bleaching in front of your eyes. But as you can see, there are still tentacles in the coral. So it's not dead when it's bleached. It's still a living organism. Now, the actual reason that corals bleach is most widely thermal stress or temperature stress, temperatures that are higher than normal. And last year, or 2023, 2024, was a global mass bleaching event, by which I mean it was an event or a time when corals bleached pretty much all around the world because we had high temperatures, seawater temperatures, air temperatures. It's the fourth global event, but it's also considered the most severe. Now, as a result, that's something that nobody can manage on a local scale, which was something that was referred to in the morning talks. It's very hard to manage the cause of stresses in the marine environment. And these panels actually show the sea surface temperature anomalies throughout 2023 and 2024 in the Red Sea. These are average values from NOAA satellite data, so this is the sea surface temperature. And the reason I'm showing you this is just to show you that the temperature is above what it would normally be, ranging up to 4 degrees centigrade, but that's not the same all throughout the Red Sea. It's spatially variable, and it varies with when it happens. So, for example, in 2024, we had quite high temperatures, 3 to 4 degrees above what you would normally see in the northern Red Sea in June, July, August, and part of September. But that wasn't quite the case for the central or the southern Red Sea. And we actually had quite high temperatures in the southern Red Sea, 3 degrees above normal in October, November, and December. So it's just to give you an idea that it's spatially variable, temporary variable, which adds complications to managing the impacts on coral reefs. I'm just zooming in a bit on the key months where it really was warm. This is a metric, the degree heating week metric. It essentially describes, it's a combination of how long temperature was above normal. It's a NOAA metric. They have classified it as degree centigrades weak. Now, to put this into perspective, all around the world, the general expectation is if you get 4 degree centigrade weeks, then you would expect to see corals bleaching. If you get 8, you would expect to see corals dying. And in the Red Sea, we had anything up to 32 in some of the regions. So it's a very, very extreme stress. Something that most people would consider would wipe out their coral reefs. So if we can't manage directly the cause of the stress, what can we do? So we basically, and this was referred to as well this morning, we have to identify the risks and do a risk assessment, and essentially it'll move on to some resilience considerations a bit later in the talk. But we basically need to identify the reefs that are most at risk, which are the reefs that are most impacted by the bleaching disturbance, and then identify and manage any other potential impacts that might compound the stress or the degradation of the coral reefs or disturbance to corals. Then we can prioritize conservation and management actions that are specific to all the compound things, and we can treat each reef in a case-by-case scenario or each region. But we cannot be everywhere at once. So to identify where we saw bleaching, and this is a summary panel or summary images of surveys that our coral team at Shams undertook from the north to south of the Red Sea through 2024. We surveyed in July, September, and November. The first survey, we managed to survey 112 reefs. Second and third survey was closer to 60, 70 reefs. But essentially, we've overlaid the percentage of corals that were in a normal state, a pale state, a bleached state, or a recently dead state. And that's what the pie charts are. We've overlaid that on the sea surface temperature anomalies. So the colored Red Sea in the background is showing where it was above the normal temperature. And then the percentages of bleached corals are shown in the pie charts. Really the take-home message is that there were more corals bleached in the southern regions, so the Farasan Banks and the Farasan Islands regions, in the July. So we believe our surveys then were the closest to the peak of bleaching. In the central Red Sea, I would also suggest that our survey in July was closest to the peak, but the percentage of corals that were bleached was pretty high all throughout the 3 surveys. Whereas for the far northern regions, I'd say that the peak of the bleaching was closer to our September survey. So that's what I'm trying to point out. Now, we obviously can't manage the stress, but we can manage the potential other things that would be deleterious to the corals after a bleaching. And one of those is that there's generally a competition between algae and corals for space on a reef, and stressed corals, especially if they die, are going to be overgrown or are likely to be outcompeted by algae. Now, removing algae is not necessarily a smart approach, but if you can get hundreds of thousands of small helpers to remove the algae for you, then that is not a bad approach. That's actually probably the way to go. And by that, I mean to actually protect fish that eat algae. So there are a variety of fish, and we've been surveying those as well, that will remove algae, and they'll essentially not completely remove algae, but they control its development. They'll stop it overgrowing a lot of the coral reef, and the more herbivorous fish or fish that eat algae, the better for managing a coral reef community. Our surveys, and this is the data from November, would indicate that there's also variability in the different regions of the Red Sea in the abundance of herbivores. We surveyed something like 25 genera or families of, I believe it was genera that we classified these 2 of reef fish that eat algae. And I'll just point out that these surveys are nearshore reefs, and so they're not fully representative of the inshore-offshore variation. But one approach to managing an ecosystem is to to manage things like the fishing pressure on the fish that are useful for controlling a compounding threat that could exacerbate the impacts of coral bleaching by further reducing coral cover. And another potential threat, and I say potential because there's still a lot of work that needs to be done for these sea stars, but there is a sea star called the crown of thorns starfish, or sea star, that is known to eat corals around the Indo-Pacific. But we have a very unique situation in the Red Sea where the species found here is only found here, it's endemic, and it's understudied. There are only 11 published studies for the species Acanthasta benzii. But in other parts of the world, these sea stars are considered one of the top threats for coral reefs. And for example, in Australia, when they did a risk assessment to see what can be done about bleaching, because bleaching can be this overwhelming threat to reefs that, because we can't manage the cause, people get a bit concerned about what we can actually do to preserve reefs. One of the best actions for Australian reefs was to control the crown of thorns sea stars, because they hone in on stressed corals. And so they're more likely to eat bleached corals or diseased corals. And in fact, this picture at the bottom left shows a bleached coral that has a very circular algal growth patch on it, which shows that the white portion of the coral is still alive. So that's this bottom picture here. The white portion is still live tissue, like in that video I showed you at the start. But the green patch, that's little filamentous algae that started to grow, and because when the crown of thorns sea star eats the coral, it leaves bare skeleton, but it also leaves a bit of a mucousy layer. That's fertilizer for the algae. So you have this uniform patch. And the picture above it is actually a sea star on a coral, and you can see where it's eaten the coral and has moved on to a bit of live coral, and then there's a bit of algae growing on it. And essentially, they eat the coral by wrapping, they exude their stomach, they wrap it around the coral, and they just digest the coral. So we're concerned that these could potentially be something that worsens the impacts of a bleaching event on reefs. But we needed to get an idea of whether that was a real case or not. Well, first of all, crown of thorns sea stars are not present on all of the reefs in the Red Sea. They're more likely to be present on reefs in the southern two regions, Faroe Banks, Faroe Islands, also the central Red Sea, but they're much less frequently observed on reefs in the northern Red Sea and the far northern Red Sea. And so that's the map in the center, which has the pie charts. But what we did see was in the bar graph on the right, if we look at the dark blue bars, essentially we've got the abundance of crown of thorns sea stars on the y-axis, and then the 5 different regions from south to north on the x-axis. But we saw an increase in the abundance of crown of thorns sea stars after the peak of bleaching in the Faroe Banks. And then we also, on some reefs, not all reefs, saw a slight increase of crown of thorns sea stars on some of the reefs in the northern and far northern reef area following the peak of bleaching in September. Now that's just an indication that there may be an increase of sea stars coming to bleached reefs to feed after the peak of bleaching. But again, I must emphasize that we still need to do a lot of work. There's a lot of differences between the species in the Red Sea and other areas, and probably the main one is that the species in the Red Sea only grows to 40 centimeters approximately in diameter. The ones in Australia can grow up to 1 meter in diameter, so they can eat a lot more coral. Coral disease is another potential thing that could stress corals after a bleaching event. So corals are weaker because corals essentially get most of their food, up to 90%, from the microalgae that they lose when they bleach. So if they're suddenly only getting their food by catching things with their tentacles, so plankton, they're weaker. They have less energy to defend themselves. And disease is one thing that can increase on bleached reefs a few months after the peak of bleaching. One thing you can manage there is to manage the water quality. And I forgot to say with crown of thorns, what people do in other parts of the world is they actually manage the threat by removing crown of thorns or injecting them with something that kills them. So that's one way to manage, to stop these things killing corals after a bleaching event. Because essentially you want to stop the bleaching event getting worse with all of these compounding of things. These are 3 examples of things that could damage a reef after bleaching. But because we can't be everywhere at the same time, we need to work at also where to prioritize. One of the key things for prioritizing is knowing how the reefs differ in general. So one of the things that we've started, which actually started this month, is we've contracted Fugro to habitat map the coral reefs of the Red Sea. And that's something that will progress through this year. A detailed habitat map allows us to make very informed decisions about which are the key habitats, because coral cover and coral diversity differs according to the specific habitats that you're looking at on a reef. So having this information is almost key to designing any monitoring program or any management action. So that's very key to managing at an ecosystem scale like coral reefs in the Red Sea. But we also need to assess differences in the actual community and the ecology of the reefs. And probably the simplest way to describe it is that we like to collect data that informs us of what the likely change is in a coral reef community, because a coral reef community is dynamic. It's never the same today as it will be next year. And there are certain types of information that you can collect that give you an idea of what's going to be on that reef in a year or 2. For example, if you have very high coral cover this year, then there's a chance that unless there's a major disturbance, there will be a lot of juveniles next year because there's a lot of reproductive individuals. If you have a lot of coral recruits, even if the coral cover is low, so a lot of baby corals, then there's a chance that that coral community is still supplied from a healthy reef, and so there's a likelihood of corals recovering after, even if there's low coral cover. But then if you also have predators like crown of thorns sea stars, that's something that's an indication you have a threat on the reef. If you have herbivores in good abundance on a reef, then you know that there's a good control on the algae. So we essentially call this indicator data, and we can combine that together with the data for the threats, or indicator data on the threats. We're essentially getting data that gives us insight into the likely change, and with that we can estimate or create a resilience estimate, likelihood that that reef is going to recover or return to a state that it was at before. And the map on the right it's a preliminary exercise, but essentially we're testing this idea, and it gets stronger the more data we collect. But we can then classify the reefs that we've surveyed and we collect data for as to whether they have a high likelihood of recovering or withstanding stress, so therefore they have a high resilience, or whether they have a medium or low resilience. And the more data we have, the more detailed that distinction can get. Okay. So essentially we can minimize impacts in some ways. Some ways is to reduce the human presence or the visitation to reefs, reduce anchoring by installing mooring buoys. We can try and manage or minimize ship groundings. But we can also intervene. And restoration was touched on before in some of the talks. The very difficult thing about restoration is it can't be done everywhere because it takes quite a lot of effort. So it needs to be targeted, or it needs to be more nature-based. And one aspect we're looking at for that is to try and detect coral spawning slicks. So a spawning slick is when a multitude of corals reproduce at the same time. They release their gametes, and these initially float to the surface of the sea so that they can fertilize. At that point, they can be detected much like an oil slick with satellite imagery. And ideally, a larger scale approach to restoration would be to be able to gather a small portion of those larvae and direct them to settle on a reef, so that we're not needing to gather gametes from a variety of corals. We've got a natural mix from the ocean of what would naturally be there, but there would be one option to try wider scale or restoration over a larger spatial scale. And other things to reintroduce species that have been overfished, like the sea cucumber. Sea cucumbers play quite an important role in filtering sediments and improve water quality on many reefs. So if they're absent on a reef, that's potentially one thing that is just a chronic stress to that reef. Again, it's something that can be an intervention or a management action. There are essentially way too many individual actions to go through, but here's a list of some. It's managing visitations, managing pollution, managing fishing, so reducing overfishing in certain areas. If there's slow coral growth on a reef, trying to reduce the physical impacts. But all of these different actions would essentially be allocated on a case-by-case basis, reef-by-reef case. How much effort does it take to apply one? Because stopping people fishing in their favorite spot is not a good option. It takes a lot more work than somewhere where people never go to. Essentially, these are tools in the tool bag. So, in a nutshell, for ecosystem-based management, we're trying to address long-term challenges. We're trying to build reef resilience so that the reefs themselves can persist under threats, because we can't control some of these threats, or we can't predict some of these threats. And we do want to consider the entire Red Sea, but again, we need to break it up into smaller portions. And essentially, our management should promote natural processes, because that's less human effort and hopefully less cost in the long run. But it's essentially a blend of biodiversity conservation and interventions for restoration and management interventions. But we have to adapt our approach. We can't set an approach today and expect that to be the same approach for the next 10 years. So we need to monitor on a regular basis. And this year, we have monitoring teams that will be in the water every month of the year, surveying reefs from north to south, and we're targeting hundreds of reefs so that we have up-to-date information on the condition of the reef. We want as much data as possible of these indicators that give us insight to the potential dynamics of the reef. We're trying to do as much as we can ourselves, but we can't do this all alone. So we are also adopting a very collaborative approach, because there are many people in the kingdom with the skills and already gathering a lot of data that is relevant to this management. So collaborations involve decision-making, how to actually plan the monitoring, the methods that we'd use. It's important for the methods to be as consistent and standardized as possible so that the data can be compared. And more entities or more stakeholders make it easier to implement changes and monitoring. So we have a bunch of collaborations. And that, in a nutshell, is how we, at SHAMS, see ecosystem management for the Red Sea. And the case study, coral bleaching, given that it is one of the major threats to, or potential threats to reefs in the Red Sea at the moment. To take questions.
So in managing these things, do we think about unintended consequences?
Unintended consequences, yes. I'm trying to think of a good example, because there's such a long list of potential unintended consequences. Maybe an example was recent considerations of how best to introduce sea cucumbers to reefs. So we have to be very careful that the sea cucumbers are healthy. We don't want to introduce disease to a reef, for example. So we actually refused to introduce several batches of sea cucumbers because they'd been held in aquarium tanks for so long, or for too long, or something delayed the actual action, or because it wasn't determined yet whether it was appropriate to release them on a specific site because there wasn't a survey. So there are so many things that go around an action before you actually can do it, but then that's just one example. So we have a fairly large team. We rely on as much published scientific information as we can find, and where we can't find it, we seek collaborations, and we'll increasingly seek collaborations to fill in the gaps. So we don't want any unintended consequences. We definitely want to follow best practice in anything that we do. Mm-hmm. Well, we would definitely never introduce a native species ourselves, but I think NCW is doing a lot of work with KAUS, good work to explore introduced and non-native species. It's also something that we pay attention to in our work, so that if there's ever a chance of detecting something like that, we wouldn't let it slip past. Thank you.
Excuse me, sir. Regarding artificial reefs, I believe it was one of the solution of coral bleaching, that we can make artificial reefs and try to boost the population of corals. Where is Shams from these kind of projects?
Okay. We have a whole department focused on coral reef restoration. It's not the department I work in. But essentially, they are focusing on specific areas with a view to learning lessons that can be applied more widely. And there's not a lot more that I can say, because as I say, that's not my specific area of expertise.
Hi, I'm here.
Ah, hello.
Okay. What is the most surprising discovery you've made about coral conservations at Shams?
Personally, or
Yeah.
as an organization?
Okay, personally.
Personally, because my experience is from the Caribbean, from the Indian Ocean, from Eastern Africa, from Australia, places like Papua New Guinea, and there are some very unique reefs here. The Sham reefs. I've never seen anything like that, with these right-angled edges that drop off on a vertical reef. So that for me was very fascinating.
Okay, thank you.
Assalamu alaikum. Just a question. What is the difference between Shams and National Wild Center?
The very detailed difference, I wouldn't be well, Shams is a government organization, and I believe that NCW is a ministerial department. We're all related to MEWA, to MEWA, and I believe there has been some transition in oversight of coral reefs for specific parts of the Red Sea. NCW still manages marine protected areas. NCW is also responsible for coral reefs in the Arabian Gulf, I believe. But am I missing anything? Beg your pardon? the marine protected areas and reserves, yes. So, I mean, essentially, I'm a junior intermediate staff member. I'm not privy to the higher level decisions, but I would say there is so much work to be done that we all need to be working together for the same reasons, because nobody can do it alone. Thank you very much.
Thank you, Dr. Pearl, for that enlightening discussion. Before we move to our next speaker, we have an exciting announcement to make. The Best Poster Award for the first day goes to Fahd al-Buaimi, Aryam al-Ajmi, and Madawi al-Bassam. Please, give a huge applause to these students. Next, we are delighted to invite Professor Emmanuel Anert, full professor at UCL Leuven at Belgium. Professor Anert will speak about vulnerability assessment of the Arabian Gulf-sensitive coastal infrastructure to oil spills. Please join me in welcoming Professor Emmanuel to the stage.
Thank you very much for the very nice introduction, and thank you to the organizing committee for having me here. It's really very nice to be here. I mean, there's a lot of very good energy over here, and it's great to discover all the things that you're doing at the moment in Saudi Arabia. So thanks very much for this invitation. My talk is going to be about oil spills. And we're going to look at how we can prepare for oil spills, how we can monitor them, and afterwards how we can forecast the dispersal. So we're going to look at the Arabian Gulf. You know very well this area. So let me see if I can work with this. Yep. So this is the area where we're going to look at. And as you all know, I mean, the Arabian Gulf is a very busy place. So if we look at maritime traffic in the Gulf, this is what we see. So this shows is a heat map showing the density of vessel movements through the Gulf over one entire year. And you can see there are places where it's pretty red, and you see the scale that it goes beyond 10,000 hours of cruising per kilometer square and per year. You can see how this shipping density, I mean, depends on the EEZ, so the white lines that you can see there are the limits of the territorial waters of each country, and you can see how from one territorial waters to the next, I mean, you can see large changes into this density of traffic. And you also know that maritime traffic is a source of pollution. And one typical kind of pollution that occurs very often all through the world is illegal ballast cleaning. So the vessels, I mean, they just open up the ballast and to clean them illegally. They're doing that usually at night. And when you spot them, this is typically what you see. So you see the vessel there moving forward, and in the trail of the vessel, you can see this spill. And this is really a very diffuse source of pollution present all through the world, and it's really a pain in terms of marine pollution. Now, if we look more precisely, more specifically, sorry, at oil and gas tankers. So this is just the traffic density for the oil and gas tankers. And then what you can see these main shipping routes for the tankers going to the different oil terminals. And you can see the main oil terminals appearing on this map. Oh, by the way, I didn't tell you on the previous map, the little stars that you can see on the coastline, the purple stars are the oil and gas terminals, and the little triangles, they are the desalination plants. We'll come back to that just after. And you can see these main tanker routes. You can see them going to Ras Tanura, for instance, Ras Laffan in Qatar, to the terminals in Iraq up to the north. So you have a very high density of tankers, again, along these shipping routes. And again, in the case of tankers, you can also have some incidents. And one of them that's occurring more and more frequently now is due to the dark fleet of tankers. As you have heard, there's more oil smuggling at the moment because of the sanctions that were put in place on Iran, on Russia. And as a result of that, there's now a larger and larger fleet of dark tankers. So these tankers, they're not registered, they're not insured, they're very old. They do switch usually off their identification system, so you don't know where they are. And they're performing this kind of dodgy operations at sea. In this case, these two tankers were caught transbording oil from one to the other in order to disguise the provenance of the oil present on one of the tankers. Things did not go well, and there was an important leakage. I don't know if you can see it on the picture, but there was quite an important oil spill that took place a few months ago near the island of Karg in Iran. Now, all these different sources of pollution, they can also come from, offshore activities. So, as you know, again, there are many offshore platforms in the Gulf, many pipelines, and these also can have incidents. Here, as an example, there is one here. This one is in Saudi waters, and actually we spotted it by chance by looking on Google Earth. So if you go to Google Earth and if you're zooming on Google Earth, you will find this picture there, just showing a leakage at an oil platform. And so you have all these different sources of pollution, and this pollution, of course, has impacts on many different things. On marine ecosystem, we were talking about coral reefs just before. It has impact on the reefs, on the ecosystem like seagrass meadows, mangroves, public beaches, but also on coastal infrastructures. And the one that we're going to consider here are desalination plants and oil and gas terminals. Of course, you realize that for desalination plants, it's a very bad idea to pump water containing oil in the desalination plants because there's a high risk of clogging the system in the desalination plant. For the oil and gas terminals, it's a bit less severe if you want, because you could say, okay, I can travel through an oil slick. But usually when you're having a slick, you're going to put in place mitigation measures. You will put some booms to limit the spill, and these are going to prevent the passage of the tankers. So it has an impact for both the desalination plants and the tankers. So what we did here was considering, all the desalination plants around the Gulf, and for instance, this is the one here in Jubail, not very far away. The oil and gas terminals, this is the one here in Ras Tanura, and we try to figure out what is the risk that these different infrastructures are facing from oil spills. And this risk is not negligible, in my opinion. And one way to see this is to look at Qatar. We're taking Qatar as a particular case, and we look at the desalination plants and the oil and gas terminals in Qatar. And if you look just on the eastern coast of the country, you have three main desalination plants. You have one near the port of Ras Laffan, you have one in Abu Fantas, one in Alul. Like that. And these three desalination plants, they're covering about all drinking water in Qatar. I think 99% of drinking water in Qatar is coming from seawater desalination. So that's really something huge. And the port of Ras Laffan, so the yellow star over there, that's the entrance of the port of Ras Laffan. Through this entrance, which is 2 kilometers broad, you have about 21% of all liquefied natural gas exported worldwide that goes through this particular entrance. So it means that you're having about 100% of all Qatar desalinated drinking water and about a fifth of the global LNG production that goes through places that could be impacted by a spill. And the fact is that these places are very close to each other. Within 100 kilometers, you have all the desalination plants. Within 10 kilometers, you have the entrance of the port of Ras Laffan and the desalination plants producing 1/3 of the drinking water in Qatar. So it means that even a kind of a minor spill could just shut down both the desalination plant of Ras Laffan and the entrance of the port, and a more major spill could just shut down the 3 desalination plants in Qatar. Now you know that in terms of drinking water reserves in Qatar, I think they're having something like 4 or 5 days of reserves. So it's a strong vulnerability. You could really imagine the situation where from one day to the next, all the drinking water supply would be just cut off. So it's something quite severe. And when you look at that, I mean, the question that comes up is how can you handle this vulnerability? And of course, what you might say, and a very sensitive answer would be, okay, let's monitor, let's look closely at what's going on in the Gulf water in order to identify spills as quickly as they occur. And to do that, you would use satellite remote sensing. That's, again, a very good idea. And the most classical satellite that you would use is a radar satellite, because radars are very good at spotting slicks at the surface of the sea, because the slick is very smooth as compared to the rougher sea surface. So you could identify the slick with a radar satellite. But the issue is that these satellites are not always over the Gulf. I mean, the most common one is Sentinel-1, the one from the EU. In Sentinel-1, normally when things work well, you have 2 satellites. Each of them is a 12-day revisit period. So it means when the 2 satellites are operational, you have 1 image every 6 days. And up to the end of 2024, just one of them was operational. The other one was just broken. And they replaced it. So now there's a third one in orbit to replace the first one that was broken. And you have this 6-day revisit period. But I mean, over 6 days, a lot of things can happen. And between the 6 days, I mean, you're just in the dark. You don't have a clear view of what's going on. So then you could supplement these images by other type of images, like optical images coming from Sentinel-2, Sentinel-3. And by doing that, you can improve the revisit time up to maybe 3 days, something like that, if you're lucky, if there are no clouds, if the image is taken during the day. So you see that you don't have a clear picture every day of what's going on. Then what we're going to do here is try to figure out where you should look in priority in order to identify the offshore area where the risk is located. I mean, these oil spills that could reach one of these desalination plants, they cannot come from everywhere. There are some places from where they have a higher probability of reaching the plant. I will try to figure out where these places are located. To do that, we're going to use an oil spill dispersal model. So that's something that we have already heard of yesterday. So we're going to simulate the dispersal of oil spills, and we're going to do this backward in time. So we're going to reverse the course of time to do that, and I will explain you this just after. To do this, we're going to use ocean currents data. We're going to use wind data. So this is what it looks like. One thing that you already see when you're looking at this animation, it goes a bit quick, sorry for that. You have the wind there on the right, and this wind, you see that it's often going to the southeast. And this wind going to the southeast, these are the Shamal winds. And as you all know, I mean, in the Gulf, the most dominant wind pattern are due to the Shamals coming from the northwest and going to the southeast. There are other winds, but they are weaker. It's really the Shamal winds that are the stronger. And these Shamal winds, they're playing quite a big role in shaping the circulation patterns that you're having in the Gulf water. And then we're going to use another dispersal model to do this. Here we're using a Norwegian dispersal model, so developed by the Norwegian Met Office called Open Oil. It's an open source model. And from that, we're going to derive oil spill risk map distribution that we're going to discuss. So just to explain you how it works, this is the idea. We're going to start from the infrastructures for which we want to assess the risk. So I mean, we're releasing the oil on the desalination plant, say, and then we're moving backward in time to see where the oil came from in order to identify the high-risk area. So it means that we're releasing the oil is propagating backward in time, and we're keeping track of all the places through which the oil is traveling backward in time. And after some time, say 1 week, a few days, we look at all these places through which the oil went through, and we're building this probability map. So when it's red, it tells you that from this particular point, there's a rather high probability of a spill to reach the corresponding infrastructure. Okay? So this is giving you the risk that you're taking. And once you know this risk, what you can do is, I mean, combining this risk with maritime traffic. And maritime traffic tells you where there are many vessels. So you know where the risk is high, you know where there are many vessels. If you have the two together, you have a high exposure to maritime traffic incidents. And that's something we're going to compute as well. So if you're doing this, this is the kind of maps you obtain for the entire Gulf. So you can see there are places, I'm sorry, I don't have a pointer to show you on the map, but you can see there are places where the risk distribution is quite elongated. And that's typically the case along the UAE. So look at the UAE coastline. You can see this rather long thong of orange colors that goes along the coast of the UAE from Sharjah going down to Abu Dhabi. So all this area has a high probability of being the source of spills that could reach desalination plants or gas terminals. You can also see that for Ras Laffan, the one we saw just before, you have this elongated tongue going towards the northwest. This, again, mostly driven by the Shamal winds. For the Saudi terminals, you can see that the area is much smaller. And there's a reason for that. The coastline of Saudi Arabia is aligned with the direction of the Shamal winds. So it means that these Shamal winds are not going to push the oil towards the coastline. It's just going to transport the oil somehow parallel to the coastline. However, the UAE coastline is just perpendicular to the Shamal winds, and there you have a much higher risk coming from this orientation of the coastline. So this is for the risk patterns. If you look at that throughout the year, and you're looking at the seasonal variations, what you see is that, first of all, you see that some infrastructures have a much higher risk than others. And in this, it's a bit of a busy graph. So I mean, usually I'm telling the students not to do graphs like that, but I mean, just stay with me. So that there are different colors, and the different colors are representing the countries. So blue is the UAE, orange is Qatar, green is Iraq, and Saudi Arabia is in purple, there in the middle. And there what you're seeing is the evolution of the total risk. The total risk we computed by integrating this spatial distribution over all the Gulf to have one single number for one given infrastructure. And we're looking at that month by month. So what we can see for the infrastructure with the highest risk, the one in the UAE and Ras Laffan, is that the risk is peaking in summer and in winter. And that's normal because, as you know, the Shamal winds, that's the strongest in summer and in winter. So that's where the risk is the most important. For other infrastructures like the one in Saudi, so the purple lines, there you see you're having something much more stable throughout the year. Because these ones are much less influenced by the wind, because the wind is blowing parallel to the coastline, so it's less influence and you have a much stable risk pattern and a lower value of this risk for these infrastructures. Good. So now what you can do as well is computing the time it would take for a spill, moving from one given area to reach the closest infrastructure. Okay, how long do you have to do something, to put in place something? Of course, this time is going to depend very much on the wind strength, on the current magnitude, and so forth, so it changes throughout the year. And here we're taking kind of the worst-case situation. So we're taking the fifth percentile, so we're looking at the 5% of the worst cases, okay, just to be on the safe side, and we compute this arrival time. What do you see is that it's pretty reddish, and reddish means not good. And it means that it takes something like less than 3 days for a spill to potentially reach the closest infrastructures. Okay, so in this kind of worst-case situation, in 3 days, you could be facing a spill reaching the infrastructure for all this area in dark red and in dark orange. So it means that you don't have much time. And if you think again about the revisit time I was talking about with my satellites, 3 days is usually the best you can do between 2 successive images from the satellite. Okay, so it's you're facing a risk that is not negligible. Now, if you're crossing this with maritime traffic, okay, you're taking the traffic information, you overlay this over the risk patterns, this is the kind of map that you obtain. So there you're having areas with a high traffic and a high risk. What do you see? You have a very large area along the UAE coastline, okay, because it's busy over there are many vessels, and you have a high risk. And what you can see as well, I mean, I did not draw, unfortunately, there the borders of the EEZ on this map, but this area, I mean, it overlays with Iranian waters, and it overlays with a disputed zone, actually, between Saudi and Iran over there, the lesser termed area where there's been some disputes in the past. And you can see that it's a pretty broad area. You're also having a kind of a large area going from Ras Tanura and extending to Ras Laffan, potentially going to Halul in Qatar as well, where you're also having this high exposure. And finally, you see that you have high exposure zones there in Kuwait, near the main terminal, and in Iraq with Abbot and Kahot, the two terminals in Iraqi waters. This gives you the time evolution of all this, because I mean the marine traffic was not steady through time. So if you're looking at the time evolution of tanker movement from 2016 to 2022, you can see that for some countries you have quite an increase, while some others it stays more steady, but I will not spend too much time on this graph. And instead, now that we have identified the area where we're having most of the risk, I mean, we can look a bit at what we can do. And the classical approach is really remote sensing by using radar images. And here I would like to briefly present you how that's working. And people nowadays are only talking about artificial intelligence, machine learning, and so forth, and that's a very good idea. But I think we should not throw away the old techniques. I mean, they've been tools that have been used for years and years that are working fine, so they should not be thrown away to be replaced fully by these new approaches. And the classical technique is to do a segmentation. So you're having an image like this one, you clearly see a spill there in the middle. What you're going to do is looking at the frequency spectrum of this image. So you're looking at a distribution of different frequencies in the image, and you're computing a spectrum for all the image. And then afterwards, what you're doing is dividing this image into small patches. And for each of these patches, you compute again the spectrum, but just over this patch. And what you're expecting normally is to have kind of the same spectrum on the small patch than on the full image. except where you're having a spill. Because on the spill, of course, the frequency spectrum is going to be quite different. And there you can see you have a bimodal distribution with two peaks. One of them corresponds to the background, which is the same as the full image, and the other one corresponds to the spill. And then you can extract the deviation, and you can figure out the extent of the spill. So that's the old idea, if you want, of this segmentation. Now, of course, there are some issues, there are always issues in life, and one of the issues is that there are many things in the water that looks like oil spill, which are not oil spills. These are lookalikes. It could be an algal bloom, for instance. It could be an area with a very low wind, so that the sea surface is very flat. And all these can be mistaken with oil spills. And in that case, it's very useful to use machine learning, because these things are going to have different shapes as the one you would expect from an oil spill. And there, with image recognition, so this kind of classical machine learning algorithm, if you do a bit of machine learning, you have heard maybe of YOLO, ResNet, this sort of algorithm. They can be very efficient to distinguish these things. So this is an example here. You see that there's a spill in the top right corner there of the image. There's a lot of black stuff in the left corner of the image, which are not oil spills. You're applying the algorithm, and you can really identify in green the oil spill, and in red, all these bits that are not oil spills, actually, thanks to the machine learning algorithm. And there you identifying the spill in the right part of the image. Good. So now you got a spill, you have identified the spill, what should you do? You should be able to forecast as quickly as possible what's going to happen. And for that, I think it's very important to have an operational forecasting model. So a tool that tells you every day, like a weather forecast, what's going to be the state of the sea in the coming days, so that as soon as you identify the spill, you're able to predict, to forecast where it's going to go, and also knowing where it came from. Because one thing that's really important is being able to identify the culprit, who is responsible for a given spill, and for that you should also be able to simulate the dispersal backward in time to figure out the origin of the spill. So just to show you what it looks like, so this is the kind of interface that we have developed in the group, and it gives you a daily forecast of the state of the sea. This is the temperature. And one thing that we do, we're using very high-resolution models so that we can explicitly represent all the details of the coastline. And as you know, the coastline over here is very complex because of all these artificial structures. And these artificial structures, they do deflect the flow. They have an influence on the circulation. So we're simulating explicitly the flow in these structures. And then as soon as you have identified the spill, you're able really to locate it on the map. You're indicating the type of oil, the size of the spill, the different weathering processes that are going to decompose the oil. And then very quickly, you're able to simulate the dispersal of this spill in order to know where it's going to go. So you see here, we're running the simulation, and then you're moving forward, and you have an idea of the area that is going to be impacted. And in this example in Bahrain, you can see directly which of these tiny islands, artificial islands, are going to be impacted by the spill. And you can look afterwards at the oil budget. So this tells you what fraction of the oil is evaporated, what fraction got stranded, here in yellow. And you can see at what moment the stranding begins. And you can see what amount of the total spill will eventually get stranded, so that you can really prepare your mitigation measure or the operation that you're going to conduct to limit the impact of the spill. Right. So to conclude, in my opinion, one single oil spill could have very dire and severe consequences, and these consequences, they could apply both on the water and on the energy supply. And the thing is that in the Gulf, I think that both are very intertwined. The places where you're producing water are often very close to the places from which you're exporting energy. And it means that if one is impacted, the other one could get impacted as well very, very quickly. So it means that you really need to use monitoring to identify the spills as quickly as possible, but often these monitoring resources are not sufficient. Often there's too much time between successive images, and so you need to complement, I think, these satellite observation resources with something else. So either extra satellite resources or something like drones, aircraft, something that provides you a higher frequency of monitoring in the zones that are most at risk, that present the highest risk for your coastal infrastructures. And once you have identified a spill, I think you should be able to react as quickly as possible. And for that, an operational forecasting model is really the tool that you need to know what's going to happen or to identify the culprit at the origin of the spill. Thank you very much for your attention. We're good. I guess so. Thanks.
Presentation. It's really important to locate the oil spills, but what is after that? how are you dealing with any treatment of these oil spills?
No. You're absolutely right. Of course, this is the beginning of the story. So afterwards, you have all the containment measures, the cleanup operation if it reaches the shore. And this, I mean, I'm working in the university, so I don't do this. But absolutely, you need to have all these procedures, all this material, this equipment, this personnel, trained personnel, available within the country in order to react quickly. So I think, again, I mean, I know that in some places these are being contracted to companies outside of the country. Again, my feeling is that this is not a good idea because you need to have this in place within the country in order to be able to react as quickly as possible. Yeah. So you need the trained staff, you need the equipment within the country to react as quickly as possible once the spill is detected.
Yeah, as a microbiologist, we have a lot of research about the usage of microorganisms to for biodegradation and removing of these spills. So I hope you find a way soon and treat it locally.
Yeah, indeed, because the chemical treatment is often, I mean, it's working to dissolve the oil, but I mean, it has an impact on marine ecosystems. So if you have biological measures to treat the oil without harming the marine ecosystem, that would be very useful indeed, yeah.
Yes, thank you so much.
Thank you.
Hi, is the model applicable to other types of spills, so plastic or chemicals or other kind of?
Yeah, we're doing that for sediments. We've been doing that for microplastic. I mean, we're doing that for coral larvae actually as well. So I mean, yes, of course, the behavior is going to be different in the water. In the case of an oil slick, I mean, it's being influenced directly by the wind. In the case of plastic, plastic is going to be influenced as well by the wind, but coral larvae is not going to be the case. So yeah, once you have something in the water, I mean, what you need as a key ingredient are the ocean currents, and that's why I was saying that it's important to have good quality ocean currents with a high spatial resolution. But then, yes, it can be used for anything else present in the water. Absolutely. Thank you.
Thank you, Professor Annert, for those valuable insights. Our third keynote speaker is Dr. Aman Singh, Senior Hydrogeologist at GSI Environmental Incorporation in USA, with more than 15 years experience working as a consultant in academia and research, and as a government regulator. Please join me in welcoming Dr. Aman Singh to the stage.
Hi everyone, good afternoon. First of all, I'd like to thank KFUPM and Dr. Lai for this invitation. It is just an honor to be here and to hear this awesome talks. It's very different. It's awesome. Okay, so we're going to shift a little bit. So we have done a lot of ocean, so we have a lot of surface water, we have heard about it. And now I'm going to talk about groundwater. Okay, but the applications are the same. So I'll start. So I'm from GSI. Yesterday, Dr. Sarab gave a little talk, like a presentation about GSI and other applications. So we are a consultancy based in US. So in this one, we are spread about. We have done worldwide projects. We are a mid-sized company, but we are a very niche company. We always are given challenging problems. That's our selling point, that we always do very challenging problems with all the other most consultants say kind of no. They hesitate to do it. That's our strength. And we do all kinds of modeling work. We do remediation, surface water, groundwater, air, mostly related with water, a little bit of air pollution, remediation, yeah, whatever. Yeah. This is our service areas, basically, again, as I said, water resources. And we also like to publish. So that's another our key strength. We like to publish. So most of our, like, if you search, Google search our Sarab's name, Dr. Sarab's, you'll see how many publications we have contributed to at some point. And yesterday, he was very humble not to mention Montreal USD. He is the author of this ModFlow USG, which is one of the most widely used groundwater modeling software. Okay. So today I'm going to focus on, my talk is going to focus on data. Okay. So we always, like groundwater, we have limited amount of data, right? We cannot drill up every part of the world. So we have limited data. So what we want to do is we want to extract the maximum from that data. And we have traditional methods, like Dr. Emmanuel said. There are traditional methods, but we also try to merge it with them, the AI-based method, data science, or machine learning, whatever you want to call it. It's all data science-based methods. So today, my talk is going to focus on how a case study, I'm going to present a case study where we use this data science-based method to help a client in California, where I'll go into that one. That's a case study. Then we're going to talk about 2 more methods. So I'm going to talk about first 3 methods, but they're just data science tools have applications everywhere. Like you think of something and you actually can do it. And nowadays with AI tools, ChatGPT, or we like this code cursor, I will say it, and they are very accessible for students. They are very easy to use, very interesting to use, and so people should try. I'll give a shout out to those guys. And so, okay, and the third one, data fusion. Again, data fusion is when you have multiple sources of data. Again, so we have traditional data. Now we are trying to integrate it with some other kind of data, which is a challenge. It sounds easy, but it's not as easy because the data, the way we collect the data is different. There's an old data set and there's a new data set. So you need to be careful when you're fusing the 2 different types of data. And then we use this subsurface tomography. This is again data-based exercise where we're doing X-rays of subsurface, right? Statistical analysis, again, trying to see the scenarios, trying to see what's happening, right? Because modeling is, again, there's a very famous saying which you might have heard, all models are wrong, some are useful. So basically, it's a model, right? It's not reality. So you have to understand that. And to explore its applicability, you have to do uncertainty evaluation. How good your model is, how good is it predicting. The last one is optimization. In the end, everybody wants to save money, right? In the end, I'm drilling wells. I want to get the maximum out of the wells. That comes to optimization. And this is all only selected applications of data science, okay? And there is, just keep going. Okay, so this is one of the case studies we did in California. So we are based in Irvine office, California, that's Hollywood, Los Angeles. So this is the work we did for WRD, Water Replenishment District. It is one of the biggest water managers for Los Angeles basin, the whole basin. They manage the whole water. So basically what has happened through the history is that, because it's in Los Angeles, right? So they have been pumping water they were pumping water, historical water. So what they did was, due to this pumping, there was a lot of seawater intrusion, saltwater intrusion, okay? So there was a lot of big saltwater plumes coming towards the LA. And in around 1970s or 80s, they actually see it. They found it. They wanted to stop it. So what they did was, so dotted line you see on the screen, there are 3 dotted lines. So basically what they did was they built this barrier system. So this is a collection of wells along the dotted lines, which is to prevent salt water from getting into the basin. So they want to stop this water. And these wells are running throughout, 24/7. So they're pumping in water, they're just separating it out. They're pushing, keeping the salt water at bay. So basically the idea is, okay, we don't want salt water to come in. So, but basically what happened, because there was already salt water, so there's already salt water, and you can see the size of this plume. So there's already salt water, now they created the barrier. So we have fresh water on the right-hand side, but we have a big plume stuck in the middle. And the volume of this plume is 600,000 acre-foot. California has this weird units, okay? So not the California, US. We like to be different, so we use this acre-foot unit, which is 600,000 would be around 800 million cubic meters. So that's a lot, okay? So this much water, okay, is there. It's a salty water. So what the WRD wants to do is, okay, if we can extract this water, okay, clean it up, and put it back in, if we can, so that we created a supply for the emergency. It's a backup supply. When they need it, they're going to use this water. Okay? But then it serves two purposes. It's actually clean up the plume, and it's a source of water. It becomes a source of water. It's a source of water you save for the future. Okay, California, another thing we commonly use is surface water is your checking account, and the groundwater is your saving account. You save it, you use it when you need it to use it. Okay, so GSI was tasked with this work. Okay, so we know the plume. What we were tasked with is, okay, we come up with this model, okay, set up the model, and then run the scenario. Okay, where do we optimally locate the wells? Where do we get the water from? And then predict it. Okay, then predict it, okay, how the water quality in this area, wherever we're pumping from, is changed over time. And that we did with the model. And this one, again, we generally, when I was talking yesterday about here, the general perception is US has a lot of data. But the big thing is there is never enough data. We're always looking for more and more data. So in this case, we had some data, right? We had some selected points, but it's not good. It's not like long-term data. So we use this method called TFN analysis. It's a transfer function noise analysis to get some long-term trends, okay? In this slide, I have what is generally typical model setup. How do we set up the model? So how do we get the model going? So we first set up the model, we validate the model, and then we run the scenarios. Okay, this is normally, typically, the modeling procedure. Okay, in setting up the model, we need more data. Okay, and the way the groundwater works is you actually have you drill some holes. Okay, you build your framework, you fill it with your properties. That's hydraulic conductivity, storability. Those are the properties which allow water to flow. Okay, and then you run the model for different scenarios. Then you put in your pumping wells. Okay, what's happening now? What's happening now? Those scenarios. So in this one, what we did was we used this TFN analysis, transfer function analysis, which I'm going to talk about next, to actually fill in, to add in the data. Okay, again, so just the big difference here is it's a groundwater. So we don't see it everywhere. So we only sample at certain locations. So we are trying to extract as much as we can from the data. So this TFN analysis is basically a signal decomposition, okay? Like the electrical engineering folks have been using it for years. Now it's pretty easily available through machine learning tools, okay? So in this one, what we're trying to do is we observe water levels at a point, and we know that there are some pumping wells around it. And there's a recharge, which is another stress. And the water level at that particular location is responding to any change in any of these stresses, right? You change your pumping level, and you change your pumping rate, and the water level responds to that rate. So the TFN analysis is trying to isolate the effect of a particular well. And why is it that useful? Because what we can do is, if we can isolate that effect, we can get the properties of the material from that effect, okay? And that's where we want to fill it, the material, the model in. So we are building the model, again, filling in the properties. So we want to, and the main reason, one more reason, we were using this one is, for TFN analysis, we don't need to go to collect another data. We don't need to get new data. We have existing data, and we are extracting this information, which traditional methods don't do it. So that's why we went to machine learning. Again, same thing here. Basically, what we're doing is we have observed water levels. We are decomposing it to individual effects. In groundwater, to do this individual, get this individual information, what we generally do is we go to a location, drill a well, and do a pumping test. So, okay? So what they do is they pump up water for 72 hours, or sometimes a week. And then they see how the water, they're pumping up this water, how the aquifer is, the water recovers, okay? And based on that recovery, we estimate the properties of the thing, again, okay? Because we cannot drill everywhere, so limited information, extracting the best. But with TFN analysis, what we have done very successfully is that we've used the existing data. So what we do is, we measure the location for, let's say, 3 months. And instead of going to a site, digging up a well, and then doing the pumping test, we are using the data which has been measured, right? We can use the historical data. There are some wells which have been measuring this level for years. So we have tried to use that to come up to extract these groundwater properties, which can tremendously improve our model. Okay. So this is an example again. So in this one, what I have is on the left-hand side, what you see is the pumping rates from 2 wells. So DP is Delton Park well in this one, and then the City Yard well. And then there's a background noise, and then there might be recharge. So basically, again, just decomposing it, right? So basically, we observe the levels, you decompose it. And in the end, you would get something you're seeing on your right-hand side, the individual well responses at the location. And then you can use these responses to get the properties which you can put in your model. Okay, so this is just the results. So, okay, for these wells, this is how the plume we started with was in 40 years. Again, we're running the model for 40 years and seeing what happens. And again, I won't go into details, but there are, again, constraints on California has these constraints. We cannot extract 500 ppm more than water less than 500 ppm TDS, chlorine. So all these constraints have to be satisfied when you're doing this model. And so these were the conclusions. Okay, we had to choose. We gave them an option of 2 or 3 wells. They decided 2, the client. And yeah, the idea was, okay, how long can they sustain it? Because they're spending this money to build a treatment plant, or they're expanding a treatment plant, right? So they want to make sure that the treatment plant is going to make them money. Okay, everything comes down to money. So in this one, the constraint was, okay, how long can it actually supply the water? And the model told us it will be around 25 years, it'll give water at least 500 ppm. And yeah, another thing we had to check was, okay, is it going to affect, because it's a polluted, kind of contaminated area nearby. So we shouldn't be pumping so much that the contaminated plume is moving towards, it's causing problems, actually, basically. So what we did till now, this is the second method, right? We use a lot. This is called clustering. So basically, it's an unsupervised learning method. Machine learning, very popular for AI methods. Like anybody into AI must have heard these methods. So first one we were doing at a point location. Now this is a geographical. Okay, so we're dealing with space locations. The TFN works at one point. And this one works in a location. So basically in this one, in groundwater, another bigger problem is that we have open wells, right? We have wells which have been there for years. And we don't know which unit are they actually screened in. That means which unit is contributing to that water. So a lot of times, we don't have that information. Most of the time, actually, we don't have that information. So that's when we use this kind of clustering method. It's basically all clustering does is, it's going to, so you look at the wells and cluster it, okay? Cluster based on a similarity. It's going to make some groups, and it's going to tell us. And you can see here, okay, we have 6 points. And now, when we do actually clustering, we see the blue ones are in one group. So it's not only based on where are they located, it's based on what are they observing, how are the levels changing, again. And this method is fairly popular, like in any kind of image processing, they use clustering all the time, okay? And we're doing is looking at how close the points are. Again, this is just a little bit of what the method is. Edge is the similarity, okay? And this is now, I'm going to skip the data. So this is the example we did. So we are looking at this aquifer units, and there's a new well, okay? We want to see which aquifer, which formation, which unit in the groundwater system it's pumping from, okay? Do the clustering. And now it tells you, okay, it's pumping from the deeper units. And this is a pretty simple example. Actually, frankly, like if you look at the slopes, you can actually make out from your eyes. Okay, I know it. But if I have only 2 wells, it works. If you have 1,000 wells, it doesn't work. That's where you need machine learning. Again, advantage of machine learning, scaling, right? Big data. Okay, one other thing advantage it tells us is that a lot of times we have these wells which are actually clustered. So let's say we have this LA model I'm talking about, right? So basically there is a cluster of wells in one location because that's where people live. And there's a big data gap on the other side. So when you run the model, you actually bias the results, and then even the model screws up because not all the wells are behaving the same, whereas they are actually very co-located to each other. So that's where clustering also helps. So basically in this one, what we did was the red one is, we're calling it super hydrograph, but it is not actually observed hydrograph. It's a combination of all the other dashed lines you see. Okay, so the model actually is better, easier to conceptualize. Again, the key point here is that the clustering really can be useful in improving the conceptual model and the calibration. And one big thing clustering can really help is outliers, right? Because every data set you have it'll have outliers. And that's where clustering can really help. Okay, the last one I'm going to talk about is the spectral analysis. And Professor Emmanuel just talked about spectrum, right? Thanks for, I'm not going too much into it, but it is, so yeah, it is pretty simple, like simple analogy, right? So basically everybody has done the prism, everybody has seen the rainbow. What it does is you are passing the light through a prism and then you're actually arranging them in a particular order so that you can actually see the different colors, right? And that's the whole idea. So you do the spectrum analysis, you do the fast Fourier transforms or Fourier transforms, you actually move the data from a temporal domain to frequency domain. And once you're in frequency domain, you can do so much more stuff with it. For example, I'm going to skip this. This is just a definition of what I said. You're moving from a temporal domain to frequency domain. Okay? And this is the application, and this is only part of it. So these many tools become available. Once you're in frequency domain from a temporal domain, okay, you can look at the cross-correlograms. So you can coherence function, gain function, the orthogonal wavelets. Wavelets opens up a whole new word for it. So now, again, you're using the same data, but you're opening so many windows. You can actually observe it. You can use it to do so much stuff. And I have two more applications here. So this one is, again, so we went to the, this is the simple correlation, okay? So in this one, what we did was we had the wells, 3 wells, and we wanted to say they're doing the same unit. Which well is the most productive one, okay? And simple fast Fourier transforms will give you this one, and in this one, we can easily see which one is actually the most productive one. Similarly, another application was input-output relation. Again, fast Fourier transforms helps you, okay? And this is a list of various applications. So transducer is where we measure the water level in a groundwater well. So if I observe the water level and use the Fourier transform, the spectral analysis, this is a list of stuff I can do, okay? I can see where it will be most productive. I can estimate the properties which I can use to build the model, okay, numerical model. Then I can see the vulnerable areas in aquifer. Overexploitation, I can see the safe yield. Safe yield is how much water I can withdraw without causing any adverse effects. Then I can use the outliers, right? That's the whole idea. Optimal sampling frequency, right? Because we sample the data. And this all can be extracted out of this very, not simple, but it's still easy to apply a spectral analysis. Okay, this is my summary slide now. Again, traditionally, you can have you have limited applications. But when you apply these machine learning methods, you actually open up quite a bit. So that can be used for new insights, optimize decision making, and predict future trends. Okay, these machine learning methods actually improve a lot. They help you a lot. Conclusions. Pattern recognition, again, outlier analysis, data gaps. You can interpret the relations which are not easy to see. Okay. And the last one, I have future trends. And again, the biggest takeaway for what I'm trying to pass on is the data science tools have wide applicability. And with all the new chat GPTs, Cursor, anything else, they are very much accessible. So it will be highly recommended. Okay, thank you. That's me, and any questions? Okay.
Thank you, Aman, for very interesting talk. My question about the recent fire, is this disrupt your modeling and your findings?
No, no. So we are in the southern part of LA, and the northern part was on fire. So we were, the only thing we got was smoke, lots of smoke. Lots of smoke, very high winds, so.
You are safe. Good.
Thank you. Okay. Thank you.
Thank you, Dr. Singh, for that thought-provoking session. Next, we have Dr. Abu Bakr, Research Associate Professor at Qatar University, who will discuss climate change, numerical modeling of waves and currents, marine biogeochemistry. Please give a warm round of applause for Dr. Abu Bakr.
Assalamu alaikum. Very good afternoon to all of you. We are moving to the end of the conference. I think all of you are tired, but I'll try to make you more energetic. The topic which I have shown just before is something different, taken from my CV, I think, my areas of expertise. That was not my topic. This is my topic of today's talk, which is ecosystem restoration in the Arabian Gulf, some initiatives. Basically, I am a physical oceanographer, but I'm also part of multidisciplinary projects. Yeah. How to operate this? Which one? Which one? Arabian Gulf is very unique because of its hyper-arid temperate climate. You are all aware of that. Because of that, the climatic features, the oceanographic features are totally different compared to the other world oceans. The sea surface temperature is usually very high, the salinity is very high. Then the current patterns, there are typical current patterns. Professor Emmanuel was talking about this before, the circulations which is along the coast of Saudi Arabia. And there are eddies, not all of them I have shown here. Apart from this, we have found small-scale eddies around the EEZ of Qatar. Professor Emmanuel and myself were collaborating in that, and we have a publication on that. We used a SLIM model, which is owned by UC Belgium, University of Catholic Belgium. The Arabian Gulf act as a natural laboratory for the climatic change impacts. Any climatic change impacts immediately reflects in the Arabian Sea. Any small increase in, for example, any small increase in the temperature that immediately reflect in the Arabian Gulf. That's why there are a lot of degradation of coral reefs because of the increasing temperatures compared to the other world oceans. Then there is loss of seagrass, and there is some impact on the mangroves.
So in today's talk, mainly focusing on two key topics, mangroves and reefs. Basically on the restoration aspect. This particular photograph which you have seen on the left side, which is in the north east side of Qatar. The place is called Fahd. The mangroves which you have seen is planted mangroves. This is not the natural one, which has grown up to the level of the natural mangroves, but it took 2 or 3 decades to accomplish this level. The gentleman who is in the picture, who is one of the mangrove experts in Qatar, Professor Jasim Al-Khayat, who is my colleague. He's very active, mashallah, in this age. And the only species, mangrove species, which we see in the Arabian Gulf, which can thrive these extreme climatic conditions, is Avicennia marina. Very recently, last week, this paper was published, which gives a review of the significance of Avicennia marina in the Arabian Gulf environment, which details about the ecosystem services, the impacts, and the restoration. The second topic I'm going to talk about is about the reefs, which is artificial reefs, which we have implemented along the Qatar coastal waters. And this paper is describing more about its performance assets and biomimetic functionality of the artificial reef. Of course, the mangroves and coral reefs, they are giving almost similar ecosystem services, including provisioning, cultural, regulating, supporting services. Moreover, there is connectivity between the mangroves and coral reefs in the form of the fish larval transport, the larval distribution, the juvenile distribution, and so on. So there is a strong connectivity between mangroves and coral reefs. Yeah, if you look at the mangrove cover in the Arabian Gulf, this picture shows the Arabian Gulf coast. The more distribution of mangroves is by UAE, followed by Iran, and Saudi Arabia and Qatar is almost around 6%, and Bahrain and Kuwait together accounts less than 1%, where the mangrove cover is relatively less. Here, the Saudi Arabia means it's including only the Arabian Gulf side, but not the Red Sea side. Yeah, if you look at this particular graph, it shows the declination in the mangrove cover from 1980 to 2020. You can see there is a strong declination compared to 1980. In 2020, there is almost 40 to 45% declination. And the strongest declination we found is around 1990 to 1996. That was the Gulf War time because of the more oil spills and other issues. But if you look at from 2015 to 2020, there is not much decrease in the mangrove cover. It doesn't mean there is no loss of mangroves. It is because of the secondary mangroves which has grown either by planting or by the dispersal of the mangrove seedlings. Yeah, this particular paper reviews about the mangrove coverage using the satellite data, and they found that there is not only loss, but there is also gain in the form of secondary mangroves. You can see here, Qatar has the net gain is positive actually in Qatar, but in Oman still yet to be improved, yet to be restored. Bahrain is more or less the same, and UAE, Saudi Arabia. This particular paper addresses the entire GCC. You can see the Red Sea coast and the Arabian Gulf coast. So there is not only loss, but there is also gain. But we have to be improved. We need more restoration efforts to meet the ecosystem challenges. Yeah, this particular paper, which published in Remote Sensing Applications, Society and Environment, there are plenty of authors from different countries. Fortunately, I am one among this. And this addresses about the secondary mangroves age distribution. For instance, you can see the Saudi Arabia here, where 70.4% of secondary mangroves. Here the distribution is classified like, the mangroves which was not existing before 1986. So the areas where the mangroves was not existing in 1986, that only considered as secondary mangroves here. So based on that, the age classification also done. So less than 5 years, there is a strong growth. The age of less than 5 years, there is a strong growth in Saudi Arabia, about 70.4, which is promising actually. Yeah, there are some initiatives in the Arabian Gulf for the mangrove restoration. I am not going to give more details into that, but from 1986 onwards, most of the Arabian Gulf countries started the restoration. For instance, Bahrain prioritized the conservation of mangrove ecosystem and associated ecological services. In Ras Sand area in Tubli Bay in 1986. And they keep on continuing their restoration plans. But not only Bahrain, Oman, then UAE, of course Saudi Arabia. Saudi Aramco has established mangrove plantations along the Arabian Gulf and Red Sea coast since 1993, and a mangrove eco park in 2021 that conserves about 64 kilometers square. This is just examples, but there may be many more. Unfortunately, in Kuwait, their efforts are not very successful because, because of the high chilling conditions and high temperature, which is not quite good for the mangroves in Kuwait environment. And we have recently a project which is awarded by Qatar Foundation, EarthNA, which is to restore mangrove restoration in Qatar, a critical assessment of the ecological and socio-economic benefits. So through this project, we aim to plant about 40 hectares of mangroves in few locations around Qatar. And Qatar University also part of this project, and we are doing the ecological assessment. And 2 days ago, I was in the field for the data collection for this project. And there was some initiatives before, although it started in 1981. Qatar created Al-Reem Biosphere. Yesterday, Ms. Donia was talking about this biosphere, which is along the northwest coast of Qatar. Unfortunately, those mangroves were not grown much. Its height is very small, maybe up to 1 meter. It is primarily because of the high saline conditions, because its proximity to the Gulf of Salva. It's very high salinity there. So the high salinity has an impact on the mangroves in this region. I'm moving to the second topic, which is the reefs, artificial reefs, which we call it as mushroom forest artificial reef. This is the artificial reef which you can see. It's a concrete structure, but particularly designed for this purpose. We are preparing for the deployment in our ship, RV Janan. This is the design of the array of the artificial reef. You can see its top, it's like a mushroom. This was patented in 2020, and this was done by my colleague, Dr. Bruno Giraldes. This is the length and dimensions of the mushroom. And this mushroom was physically tested at University of Queensland, Brisbane, for the impact by the currents and waves. For example, the scars under the currents, you can see we have two models, the small one and big one. you can see on the leeward there is a sedimentation. I mean, there is an accretion of sediments because when it is deployed, there will be a small vertex. It creates a small vertex that generates a sediment in suspension. It ultimately deposit on the leeward of the structure. So you can see in both. This is from the sea where we deployed. You can see there is a sediment accretion on the leeward side, but the other side is, a little bit of reduction. And we deployed this mushroom artificial reefs along the north coast of Qatar. We deployed 240 such artificial reefs. Each pack has, like 12 in numbers. One group is 12. Like that, 120 in one place, and another 120 maybe another 1 kilometer away. Like that, we deployed. And what is the impact is that the ecosystem is improving because of this artificial. That's what we are expecting. So this short video will explain to you what is the impact, what is the advantage of this. So this is the installation we did from our ship. So it has been deployed at a depth of about 10 meters, 10 to 12 meters depth. So day one after installation, you can see very small fishes around these structures. So after 1 month, you can see the difference. The juvenile fish started to appear, searching for shelter. It's a good shelter for the fish. From the big fishes or any other threats. Yeah, now you can see slightly bigger ones also coming in this place. And as the days gone on, more biofouling, more nutrients, more favorable conditions for the ecosystems to live there. So month 2, you can see plenty of fish, and the size also bigger. Yeah, the thing is that, this kind of artificial reefs are needed. The coral reefs, we know that we cannot restore the coral reefs, the natural coral reefs as it is, but we can do this kind of artificial reefs to restore our ecosystems. So this is an example. You can see after 6 months, the big fishes, very big fishes are coming there. So this is the favorable conditions for this fish to live there. So, but what the message I can tell you is that, not all the ecosystems cannot be restored. For example, the coral reef, as it is, the loss is a loss, but it may not be permanent if we can probably able to restore them. So that should be our future agenda to conserve our marine ecosystem. And this video is provided by Dr. Bruno, my colleague. And thanks for listening.
Hello, sir.
Hi.
Thank you for your nice presentation. As I can see in the video, the small colony of artificial reefs you have been deploying, I have 2 questions. Is this artificial reefs supposed to grow coral on it? If so, what did you do with the pH of the cement? What was the solution?
I'm not an expert about the structure. You know, the structure is done by another company for us, so I'm not familiar with the structure. Yeah.
Okay. Also, I saw in the video some coral on top of the artificial reef. This was planted. This was not growth in it, because
it was planted. Yeah.
Yeah. The size of it. I mean, somebody did put it on top of.
Yes. Yes.
Okay. So, okay, there is no any information about the pH solution.
No, I'm not sorry. I apologize.
All right, thank you, sir.
Thank you so much for the nice presentation. I just want to ask, how frequently do you monitor these like coral reefs? And would there be any value added of something, some technology where it would frequently or like have a long-term monitoring and analysis of the coral reefs going around?
With this artificial one or the
yeah,
natural?
for the artificial one.
Yeah. This one every month the team is going and monitoring. Actually, the one which I mentioned, Dr. Bruno, he's the one. So yeah, every month they are going and monitoring.
All right, thanks.
I would like just to add one, let's say, information.
Okay.
That we produce honey from the mangrove tree, and everybody is talking about the mangrove, and that honey is unique. This is only for the information.
Thank you. Thank you so much.
Sir, regarding the design, you say it was patented.
Yes.
In this area, we usually have trolling knots. Trolling knots.
Yeah.
Will this design avoid the trolling knots damage?
This particular one we deployed in the area of Qatar Energy, so where the trawling is prohibited actually.
Oh, I see.
Yeah.
So it's a preserved area,
Yes.
so we cannot.
Yeah.
Okay, thank you.
Okay, thank you. Thank you so much.
Thank you, Dr. Abu Bakr, for that fascinating talk. We will have our parallel sessions on technology and environment starting at 3:30. These sessions will delve deeper into practical applications and research innovations in environmental technologies. Parallel session 1 will take place in the main hall, and parallel session 2 will be held in room 101. Please refer to the agenda for detailed topics and speaker assignments. Those who have the presentation, make sure to provide your materials in advance. Finally, to conclude the keynote sessions, we have Engineer Omar Ibrahim Abu Nayyan, Director of Specialized Technologies at the National Center for Wildlife. He will share insights on the topic of technological transformation for sustainable conservation. Please join me in welcoming Dr. Abu Nayyan to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you everyone for joining us here, especially it's a Thursday end of the day, everybody's kind of exhausted. But I promise this will be insightful and we will have full clarity and transparency. Starting with transparency, a quick disclaimer for everyone to read. Since we're in an academic setting, then this is usually a nightmare. I will highlight later which parts where AI was used. So the National Center for Wildlife is one of the 5 national environmental centers in Saudi Arabia, which is mandated with the conservation, rehabilitation, and preserving natural ecosystems in both marine and terrestrial settings. The main vision for National Center for Wildlife is to have a sustainable and flourishing ecosystem from both marine and terrestrial. And today we're going to be talking about how we're reaching this mission and goal of having a flourishing, sustainable ecosystem using advanced technologies and some practices that have been developed over the last 3 or 4 years. So we have 4 main strategic goals, the first of which being a complete digital transformation of the current practices and future practices in National Center for Wildlife, which includes, internal communication, external communication, automation of process and workflows, apart from the technologies. Also raising operational efficiency, which is one of the key points, is to make sure that everything that we're doing is very efficient, very eco-friendly, and making sure that we're using and utilizing our assets as best as possible. Building and developing a central database, which is usually a very big challenge for almost every entity in every field in the world, is to have a database where all data sets are standardized and harvested for insightful information. And fourthly, developing business intelligence, which supports decision making. From that, we had a journey that started with the establishment of the National Center for Wildlife. Who is not aware of the beginnings of the National Center for Wildlife? It used to be called the Saudi Authority for Biodiversity, Preservation and Protection, which then, with a royal decree, was launch of the 5 national centers, which included the National Center for Wildlife in 2020. Starting from 2021, we started with a very large endeavor of gathering all the need that was from all the different departments in the National Center for Wildlife, understanding what they are doing, understanding what is the most challenges they're facing, how we can support them, understanding workflows, current technologies being used, the methodologies, etc. And building these requirements, which then fostered into acquiring technologies. So we started acquiring technologies and testing technologies in 2023. We started implementing these technologies and using them as part of procedures to carry out mandatory tasks. And now in 2025, we're looking into further innovating and developing on what we're currently using and what we learned from using these technologies in our reserves. As everybody knows, Saudi Arabia is has a very diverse environment and landscape, marine and terrestrial. So when we're implementing a certain technology in all of these environments, we get very insightful knowledge and information of what works, what doesn't work, and what's more efficient, most efficient. So to summarize the goal, we're truly trying to provide our leaders, researchers, rangers, reliable data on demand to enable accurate, impactful actions. This is the bottom line of what we're trying to do. We're trying to make sure that they have data that's reliable, dependable, quality controlled, that they can make decisions based on it and have a peaceful mind about the decisions. Basically, we're trying to create the real superhuman. So a normal ranger can only operate 1 camera at one time, can only monitor 1 drone at one time, or can only monitor a certain species at one time. But now with technologies, 1 person can do the work of 10. 1 person can see for hundreds of kilometers above water, underwater. As one of the questions before about monitoring the coral reefs, we have underwater 360 cameras that are monitoring development and changes in some habitats that are under critical risk. So this is what we're trying to do. We're trying to build the superhuman. So before implementing any technology and after understanding all the challenges that are currently faced, we always have to look forward. It's not about bringing the technology that's today and having it today for this year or the next year. We're trying to make sure that we have a methodology that enables the development of technology over time and adapting technology over time to make sure that we're always at the front of technological development, of ensuring efficiency and accuracy in our decisions and in meeting our goals. So basically, first we start identifying challenges and identifying needs of the business. And of course, in this process, we also look at best practices that are evolved in the world right now. And then we adopt and activate these technologies. After that, we seek feedback from the field, from the researchers, from the rangers, even from collaborators and stakeholders that are outside of NCW, like universities and NGOs and stuff like that. And then we just keep on going through this loop of advancing our technology and making it more reliable and more suitable for applications. So what is the need? Today we have 4 general departments in National Center for Wildlife that are carrying out this mission of the NCW. We have the General Department of Wildlife Reserve Management and Planning, the General Department of Marine Ecosystem and Wildlife, General Department for Terrestrial Ecosystem and Wildlife, and General Department for Research Centers and Breeding. So these are the 4 core businesses that we're serving as a Department of Technology. So they have a lot of operations that are either by emergency, unplanned operations, like some bleaching events and stuff like that, or continuous, like the annually or biannually survey of ungulates and reserves. So we have a lot of, this is just to summarize a few of the ones that we tackled in our first wave of digital transformation. But there's a lot of need in these. We understand the process of what they're doing today. Where can we put technology to make it easier, more efficient, and more reliable? So the current operation challenges, as everybody faces in almost every industry, but specifically in wildlife, is we have vast areas that we need to monitor, limited budgets in some cases. We have insufficient data right now. We have poor accuracy and problems with the data. Some data used to be kept by record of writing in books. Sometimes you can't read the handwriting. Different coordinate systems are used, different units of measurements are used. Some of them are not even accurate or created from nothing. Difficult terrain, variable and severe weather conditions, danger of the subjects that we're studying, like snakes underwater. We have sharks, we have rays, and we have different kinds of dangerous subjects or dangerous environments that we're working at. So we're trying to increase the safety. So the solution, we initiated the first program for technological transformation, not just digital transformation, but technological transformation. We built upon what we already had of technologies, and we started increasing the amount of technologies in some steps that are very sustainable and very measured, to ensure that we're not overkilling the use of technology, and at the same time it gives us valuable information of how best to use this technology. Does it cope with the conditions that we're operating in, like we are using drones in the empty quarter. The mean temperature during the summer is 46 to 47 degrees Celsius. Wind speeds are up way past 10 meters per second, dust, all that kind of harsh environment. So how do these technologies cope with the environments that we're using? These technologies is a very key aspect. So in the first wave, we have adopted a lot of different camera systems, visual observation. This allows us to be there when not being there. So when we don't have to physically be in this location in order to monitor this location. We are, one of the biggest issues in operating in remote areas is always the communication. So teams communicating with each other for collaboration, for security purposes and safety purposes is always a difficult challenge that we always face in most of the wildlife reserves. Now we have a system where I can communicate from the head office in Riyadh to somebody in a boat in Jazan, and another person on a boat in the Gulf of Arabian Gulf, and someone else in the empty quarter, which enables quick information sharing, and it also enables confidence in the people in the field that they're always in safe hands. People know where they are at all times, and the communication is very clear. Also adopting autonomous systems. So we currently own and operate around 8 ROVs, a single AUV. We currently have a fleet of 30 unmanned aerial systems ranging from very small sub-kilogram to 4-meter wingspan systems that can allow us to do some very interesting studies across a very large area of applications. We're using wildlife tracking systems for birds, for terrestrial, for marine. This is not a new technology, but where we're linking all of these technologies into one platform and using artificial intelligence to help us analyze what is going on, analyze the data that's coming in from multiple sources and using it in platforms. So from this came the technology part, and then we had the software and data management and data analysis part, which we started developing applications. One of the most important applications that was easy to develop in-house and was very impactful was having an application for rangers to record a huge number of data, record tracks, images, behavior, etc., that allowed us to gather a lot of data very quickly just using the already existing smartphone. So we don't have to, usually we would have GPS, we would have a logbook, we would put information from the GPS and the logbook and the handheld camera, and we try to get all this information together. Now with one push of a button, you have all this information gathered together, which with the data of the drones, the data of the ROVs, the data of IoT sensors, seismic sensors, data temperature loggers, etc., we can have a 360 holistic understanding of what's happening in that environment to that species at that time. So we have generated about 26 dashboards in-house up to now, which allow us to measure about 200 indices. We're increasing that amount based on the application needs. So we started off with the top 3 of 3. So we went to each of these major departments and we said, what is the top 3 challenges that you have? So we can work on that instead of diluting our efforts and not achieving anything. So from that, we started with one platform, one indice, 2 platforms, 3 platforms, and now we're launching, hopefully soon, the new geospatial information platform that enables us to see almost all the technology, all the data at once. So here's where I use some AI. So there's a challenge. For everything, like technology, some people think that once you get this device and you connect it to the power and you connect it to internet, boom, there's magic that happens. Well, in real life, that doesn't happen. There's a lot of processing, tinkering, experimentation, and everything. And this requires cost and requires time. And these are 2 things that everywhere in the world are in limited resource. Everything is changing too fast right now for a person to cope with in a very traditional method. So we have technological limitations. For us in Saudi Arabia, some of the major technological challenges is the weather. A lot of systems are developed in Europe or in China or anywhere else, so the weather is a very important factor. The other one is high cost. So we're not talking about the cost today, we're talking about the cost 50 years from now. Is this thing going to be sustainable or not? Ethical concerns. Using these systems, you're gathering a lot of data. Sometimes these data are like you flying drones overhead, people and everything. You can gather data that might have ethical limitations to it, so that's one of the challenges. Data security is a huge challenge everywhere in the world. Training and expertise, this is another challenge, making sure that the rangers and the researchers not only have access, but know how to use this technology effectively. And this, by the way, is a very important thing. Like we took the rangers 10 years from now, their level of skill was very low, which meant that their quality of life and the quality of job that they have is going to be low as well. But today we have rangers that are being trained to operate drones, cameras, analyze data, etc. So now they have a higher level of skill, which means they'll have a higher or a better life in the future, and they give more back to the community. And that's a very important thing. And 2 weeks ago we had a celebration of one of the elder rangers who acquired his certificate and he became a licensed commercial drone pilot. he learned the English necessary, he studied the material necessary, and he was able to achieve this. And that's just one of the things that is very, very nice to see and very important. Integration and compatibility, that's where standardization comes in place, API standardization, etc. This is, I think, the main challenge that we face today is standardization of what we have, compatibility between devices, interlinking devices, and making sure that the platforms can incorporate different information from different platforms, especially that some solutions have like a closed system where it's very hard to acquire the data from. And there's, of course, a long list of solutions, and that's why it continues down the slide. That's not a mistake in the design. So we have open source solutions. Like we saw, DeepSeek came out with a new AI model that's being the trend of the world right now. Partnerships, grants, having a lot of collaboration with institutes like KFUPM, like KAUST, King Saud University, even abroad, and this has helped us a lot. So these are a lot of the solutions to the challenges, and I really hope that everybody takes the chance to explore different possibilities. Sometimes we always focus on the traditional method of doing things, and we don't think about alternative solutions. Just look at DeepSeek. So what does the future look like for technology in wildlife? I think in the future, it's going to be a key part of wildlife conservation. Conservation will not happen without technology. It's going to be very effective, but also what's going to be more important is research and development in low-cost solutions for monitoring important indices. So moving forward from now, this is what we're looking at NCW, is reducing the cost and increasing the benefit of the technologies that are used. Thank you, everyone, for your patience and your focus with me today. If you guys have any questions, please feel free to ask.
Thank you very much. That's a wonderful vision that you've created. I'm an architect. I've worked on very large research buildings or large commercial buildings that have building monitoring systems. So there's an enormous amount of data held locally. I've just built a house in the Shetland Islands that built to the Passive House Plus, an energy positive standard. So I have data that's streamed in every 2 minutes to Tel Aviv from the solar panels and batteries. I have data that's going every minute to about the heat pump that's going to a server in Berlin. I have data about the mechanical ventilation heat recovery systems that's going to a data center in Zurich, in Switzerland. I have no way of looking at a lot of that data. There's no there's nothing I can get on the phone that shows me. Some of the things have what's on now. Like, yeah. I think people are used to looking at the weather now on their phones. But you can't find out, you can find out what the weather is going to be in the next week, but you can't look backwards on most of the applications we have from the BBC. So making the user interface more friendly so that everybody can actually access this enormous amounts of data we have, I think is important. So for wildlife, I think it would be wonderful if you have dashboards that are on the phone for normal people. It's wonderful the rangers are able to use their phone and produce the data, but I think it would be wonderful for people to understand like how many birds they've seen this week, the last 10 years. So making that data available to the people of the world would be wonderful.
Actually, thank you for that.
Thank you.
I'm a big fan of smart homes and energy efficiency. I'm doing the same at my house. And yeah, we always look at building user interfaces to be friendly. That's why in the ranges user interface, it's always about pictures. So they don't have to do a lot of reading or steps. They just have to look at the picture of the animal or whatever. And there's background data that gets processed to add all the different attributes to that thing that they've seen. From that, we are planning to launch an application for the general public. We did that for a project for the baboon problem we have in the south, where we had an application for people to record sightings. And we're going to try to expand that for everything else. But right now we focused on what we needed to do internally and to make sure, because the data sets that we have from the rangers are data sets that are following a certain methodology. And that won't be easily to duplicate with the general public. So we do plan on integrating with biotonic and marine and terrestrial, where a person can either identify a species that they're looking at right now, or record a sighting of a species, or even just look up information about these species. And NCW has done a great work in the last 2 years in developing encyclopedias and making them digital for either marine or terrestrial wildlife.
Thank you for your presentation. My name is Khalid Nabout. I asked your colleague in the morning, and he said you will give the presentation in the afternoon. I like your last slide with a nice bird and the drone. So
Yes.
I am coming from the technical perspective. What sensor are you using on your drone? Because she couldn't answer in the morning.
Okay, so basically drones are just a platform that you can connect anything to. And right now we're using multispectral multispectral cameras. We're using RGB cameras. We're using thermal cameras. We're working on air quality sensors also, but that's not of the higher priority. And in the future, we're looking in one of the research projects to use hyperspectral cameras and maybe SAR, synthetic aperture radars, just to name a few.
Did you look to the LiDAR data? Because I think it's quite important if you combine all this data by adding some LiDAR, since you have the platform, and
Yes.
you can easily be flexible to remove and change.
So we have two modes of operation in NCW. If we're going to utilize the technology 70% plus, we adopt it in-house. If we're not going to utilize it 70% of the time, and it's just going to sit there on the shelf gathering dust, then we just hire an external service provider. And that's what our GIS department does, because LiDAR data is not very important for most of it. Bathymetry data is important, and we use multi-beams on our boats, on our catamarans for research. But in terrestrial, we have good digital service models that allow us to have good information. So when we're talking about LiDAR, we usually hire external service providers.
Thank you.
Thank you very much, everyone. Have a good day.
Thank you, Engineer Omar, for this inspiring presentation. We now invite all participants to proceed to their respective rooms for the parallel sessions on technology and environment. These sessions will delve deeper into practical applications and research innovations in environmental technologies. Parallel session 1 will take place in the main hall by Dr. Karim Ad-Dali, and parallel session 2 will be held in room 101. Please refer to the agenda for detailed topics and speaker assignments.
Okay, good afternoon, everyone. Let me ask you a small question. How much did you pay for your electricity bills during last year? And if we stated that the same electricity prices were the same for 30 years ago, do you think you would pay the same amount of... Oh, thank you. Point it up. Again? It's not started. Okay. Let's go back. Let's go back and ask that question. How much did you pay for your electricity bills? And how much would you pay 30 years ago if you are still using your same pattern for today, 30 years ago? Did the electricity bills go higher, or our usage consumption just go higher? Let's take a look for the whole Middle East countries' energy usage. 1990, Saudi Arabia were using around 200 terawatt hours. But for today, for 2020, Saudi Arabia is using now around 700 terawatt hours. That means our usage consumption are just go higher. Why does it go higher? For many reasons, but most probably for our HVAC usage, cooling consumption, which is going from 200, where we are going from 2000, 2050, 2100. Our temperatures are just go higher and higher. We are facing 2 degrees, 3 degrees Celsius are increasing for our temperatures. So we are asking a question. Saudi Arabia have many initiatives to mitigate our buildings to the increasing temperature. For example, Saudi building code are forcing people who are building now to use insulation, to use smaller window-to-wall ratios, smaller windows, to implement double glazed, to use standards that go against the rising temperature. SEEK also, the Saudi Energy Efficiency Center, is promoting some retrofitting initiatives for people who will to retrofit their buildings. Their older buildings who use too much energy should be retrofitted to use less energy for now. Our question was, how about the buildings that are built now? We shed the light on a building that is built for right now, for Talat Mustafa Group in Banan compound. We asked the question whether this building now, how much energy that will be used for this building, how much energy will be used for 250 and in 280, how much energy this building will be using. So we built a model and design builder actually to estimate the current energy consumption for this building. And we used a tool called CC WeatherGen to morph the weather data file we have for now to estimate the energy consumption and the future scenarios for 2050 and 2080 under the 4.0 RCB for future scenario. Okay, so our case study for this study was, as I mentioned, a residential building. It's ground and 6 typical floors, 24 apartments in starting from 60 square meters to 150 square meters, like most of our buildings. The building shell includes polystyrene insulation, and the roofs also include polystyrene insulation. That means this building is compatible with the Saudi building code and also with most of initiatives in Saudi Arabia right now. The glazing is single glazed. Most of the building characteristics were gathered from Talat Mustafa Group, actually, website, and we connected with them. We built a base case scenario for this building in Design Builder. And we started simulation based on each month how much energy we will be using. And in each month, we estimated the total energy consumption and the cooling loads for each month. Then, as I mentioned before, we used CC WeatherGen to morph the current weather data files to estimate to get the weather data files for 2050 and 2080. If we look at this building performance, we can see we are now not using too much cooling energy, which is in orange color. In January, February, December, we are not using cooling temperatures at all. However, in July and August, this building will be using around 54 and 56 kilowatt hours. So how this building will be performing in 30 years? if we go to the simulation data, we will be starting seeing another pattern of cooling. We'll be seeing some usage that is demonstrated here in January and February and December for cooling loads. We will be also seeing that this building will be hitting in January and July and August for 63 and 64,000 of kilowatt hours. Okay, how this building will be performing in 2080? This building will be hitting for 70,000 kilowatt hour in 2080. Let's just remember this building was using, let's go back and go back. This building was using 56,000 kilowatt hour now. In 50 years, the same building will be using 70,000 kilowatt hours for cooling in a single month. Okay, let's put all these data together. We'll be seeing that most of our usage pattern will be going higher and higher, and especially for the cooling loads, which is demonstrated on the right, we can see most of our months are using too much cooling energy and too much increase in cooling energy and cooling loads. Also, this increase in cooling energy can also be seen in the total energy usage. We can see months like January and months like December are facing not as much increase in loads. However, other months like August, July are facing higher increase due to the increase in cooling loads. Okay. Let's put all this together. For a single building, we are facing a building that was using for the whole annual year around 382 kilowatt hours. This building is expected to increase to use in 250. The same building will be using 446,000 kilowatt hours. The same building is expected to use in 280 around 521 kilowatt hours. This building is using more energy for 80% and 38% for the next 30 years and 50 years due to the increase in cooling loads for 27 in 2050 and 49 in 2080. Let's put this small building to be implemented for the whole national border. How much energy the whole energy sector in Saudi Arabia will be facing of the whole energy sector is expected to increase for the same building. If our building is implemented for all the other residential sector, how much energy will be costed? If we can take a look here, residential sector form around 50% of the whole energy consumption for all Saudi Arabia. So if we are facing in 2050 the same increase as this building, we will be using extra 7,000 gigawatt hour energy, which will expose the Saudis for extra 4 million CO2 metric tons. Okay, and for 280, the same building will be the same building increase will be applied for the whole residential sector, which will be require additional demand around 15 gigawatt hours, which will expose the Saudis for extra 9 million CO2 emissions. What to do? Let's go back to the first slide. Sorry, let's go back to the first slide. There were too many initiatives here in Saudi Arabia. What to do? Most of Saudians should start implementing these initiatives in their buildings. The Saudi building code should be applied for all the buildings that were built before or 10 years ago or 20 years ago. Retrofitting initiatives should be applied for the whole Saudians buildings, which was built 20 years or 10 years before. The new buildings should be proving to be energy efficient more than who are built for today. I think I'm now done. And, yeah, I think we are done for now, and thank you. Any questions? Okay. Okay.
Now, you've done something wonderful and something I've been thinking about.
Thank you.
I've just built a house in the Shetland Islands, the north of Scotland, which is wild, wet, windy, cold, with solar panels on the roof. And it's working to the Passive House Plus standard. It's energy positive. It's generating more electricity than it needs at 60 degrees north. Now, Saudi Arabia is blessed by abundant sunshine right at the time when you have peak demand for electricity for the air conditioning.
Yes.
So for me, and the other beauty about Saudi Arabia is you've got flat roofs generally. So it would be very, very easy to put solar panels on the roofs. The other thing I've learned is that Saudi Arabia has already installed electricity meters that are capable of exporting to the local grids.
Yes.
So well done. So the thing that needs to happen next, with the numbers you've got, if you put that into the Passive House planning package, and you look at what you need to do to move it to plus and premium standards, it would be very easy to do that with insulation and triple glazing. Because if my house in the Shetland Islands, which is designed for a 25, 30 degree difference between outside and inside temperature, is working, it's actually the same differences that the building fabric has to do in Saudi Arabia. So if you go to triple glazing, more insulation, solar panels on the roof, the problem will be solved. Now, there's also a standard with Passive House that's for energy refit. Now, energy refit on the building you showed would be really easy because it's a big block, and you can put the insulation on the outside and probably put some shading. So an interesting activity that you might want to consider is working with the Passive House Institute in Germany, and I'm sure they'd be delighted to work with you with the data you've already got, just to see what the numbers might be, how much savings could be created by switching to the energy fit standard that they've well developed. Yeah, so thank you very much. Thank you. I don't know if you've considered the Passive House standard, but please do if you haven't.
Actually, let me share something small with you. There is another research we were working on to estimate is it possible to reach the near zero energy house here in Saudi Arabia or not through only retrofitting. We had a villa. We started retrofitting in this villa to see can we reach the near zero energy or the actual near zero energy for this whole villa or not. We installed PV cells. We changed the glazing to double and treble. We tried that and that. We installed 4 different types of insulation for the whole shell of the building. We were never close to zero energy. We were close to near zero energy for the whole year. However, after using PV cells and after using what we can do, during the summer months, we were using too much power that our systems cannot afford. However, in January, February, and December, the winter months, we were producing energy more than our needs. So we were actually, as you mentioned, we were exporting to the grid. However, in the summer months, we were taking too much from the grid due to HVAC systems. Thank you. Maybe you can go with. Okay, any other questions? Thank you.
Thank you, Dr. Karim, for this insightful session. Now we will proceed with our second speaker in the parallel session, Dr. Dr. Musaad al-Rahman. Please join me in welcoming him to the stage.
Assalamu alaikum. Good afternoon, everyone. Bismillahirrahmanirrahim. Assalatu wassalamu ala Rasulullah wa ala alihi wa sahbihi ajmain. So already we are getting tired. Today I would like to present one of my research is satellite-based analysis of particulate organic matter and its physical and biological drivers in the Arabian Gulf. So the outlines of today's presentation: motivation, objectives, materials and methods, results and discussion, conclusions. Firstly, we would like to focus on the motivation of this study. In the last presentations and keynote speakers delivery, we came to know that Arabian Gulf is a very important ocean waters in this region. And the particulate organic carbon we know is present in the particulate matter, in small organic and other materials in the seawater. And we know the ocean acts as a significant sinks for the carbon dioxide, and it's sequestering as approximately around 25.30% annually. And although the marginal seas are very small, around 7% as compared to the open ocean, but it's contribute around 14 to 30% of the ocean's primary productivity. So if we consider the Arabian Gulf as a marginal sea, it's really works as a hotspot for biological productivity compared to the open ocean. And the reasons to choose the satellite data for this analysis, we know is really large scale and continuous monitoring, high temporal frequency, integration with other variables, cost effectiveness, and accessibility. And the objectives of this study to focus on the spatial and temporal variability of particulate organic carbon across the Arabian Gulf, and it stands on of the particulate organic carbon and the main biological product is chlorophyll, and the physical parameter we know the sea surface temperature. And finally, our target was to check the connectivity between the particulate organic carbon and the physical parameter, that is the sea surface temperature, and the biological parameter, that's chlorophyll. So if we focus on the study area, as Professor Emmanuel already mentioned about the diversity and the importance of this ocean is really very much important due to its unique location in its subtropical high region and the low rainfall, and also due to the high salinity. So it's really, it's very much important sea waters in this region. And the data we used here is the MODIS Aqua, and it was for 20 years, from 2003 to 2023, was monthly data, and it was of 4-kilometer resolution. It's really a high resolution in this type of analysis. So here we used a very simple modeling, you can say, is a geographically weighted regression model. It's really like a multilinear regression, but it's different than multilinear regression in this case, that this the coefficients which we got from this modeling it can vary spatially in terms of pixel. As much as the resolution will be higher, your number of coefficients will be higher. and which will help you to find the specific, the location-based analysis or dependency of the each and every correlations. So firstly, we would like to present the time series of particulate organic carbon, sea surface temperature, and chlorophyll. Here is a very clear indication that particulate organic carbon is in a declining trend from 2003 to 2023. And in case of chlorophyll, it's also declining trend. But for sea surface temperature, there is an increasing trend. And in case of yearly change, we can see at the beginning of the year, the particulate organic carbon and the chlorophyll has a higher in the starting of each year, and it's increasing gradually. And by mid of year, it was in the highest level, and then it's going down again, something like. And so particulate organic carbon and chlorophyll, they are showing the similar trend. But SST, that sea surface temperature, is showing a bit opposite pattern. You can say is the inverse pattern. So at this stage, we look about seasonal variation. Here you can see there's in case of particulate organic carbon and chlorophyll, the high amount was found during the winter, but is lower in summer, and in the spring and autumn there is a intermediate amount we found. And in case of spatial distribution, we also see that in winter the density was higher, but in the winter, in the summer, it was lower. So the connection can be due to the dominance of small phytoplankton and other issues due to the low temperature and limited light availability. And vice versa, in summer, the high amount of light availability, and also can happen due to the the particle mixing probability is related to some geological analysis and microbial analysis. Anyway, so here we wish to check the spatial trends of particulate organic carbon, as here particulate organic carbon is the main parameter of our study. Here we see that there is increasing trend, mostly during it's amount from 5.90 milligram per meter square per year. Actually, here we use it's around 20 years of data, and then we get this analysis. And it's really statistically significant. You can see the p-value for each application is just around 0. But in case of sea surface temperature, you can see there is a increasing trends. It's was around 0.31 per 0.31 degrees centigrade per year. Finally, we would like to check actually the relationships between the particulate organic carbon and the biological, that is the chlorophyll, and the physical parameter, that is sea surface temperature. In this modeling, actually we did in large scale, and also we have lots of layer results and spatial distributions. And due to, as this work is not published, so we did not share lots of results here. There's a final focus. You can see in the for the year 2005, the particulate organic carbon and chlorophyll, it shows a positive coefficient is around 97.03. But for the particulate organic carbon and sea surface temperature, you can see it's a negative of 3.02. So here it means that for each and every change in chlorophyll will make the increase of 97.03 milligram per meter square. It's overall, we can say, in case of all spatial distribution. But can we have it? This was not shown here. And for sea surface temperature, that means with each and every increase in sea surface temperature can decrease the amount of particulate organic carbon by 3.02 milligram per meter square. It's really interesting, and it's an issue of concern that if it is really happening, then what would be the future of the Arabian Gulf waters in terms of biodiversity or something like that. So for 2010, 2015, 2020, and also overall, each and every is showing there's around 100 milligram per meter square is decreasing, increasing in particulate organic carbon for the increase in chlorophyll. But inversely, there is a decreasing in terms of each and every degree of centigrade is around 7.21 milligram per meter cube. It's really interesting, and also is a matter of concern. It's a significant amount. And also, you can see the model feed R square is also around 0.88 to 0.96, and overall is over the 90%. So our model shows that the predicting capability of particulate organic carbon in terms of the physical and biological parameter is really statistically significant. So in this modeling, actually we would like to expose this. We need to make some real time, you can say, measurement from the Arabian Gulf's water to check and so what actually will be happen. And that's why we are working, and in FUSA we have planned to make some in situ analysis to make this modeling in real time. So in concluding remarks, we can say it's really the significant interannual variability in particulate organic carbon, chlorophyll, and sea surface temperature. And in the important sea area, that is the seawater, Arabian Gulf, as I saw from yesterday, up to this, lots of study is happening in Arabian Gulf. So now it's also to indicate the importance of Arabian Gulf. Anyway, the positive correlation between chlorophyll and biological parameters, and there is an inverse correlation is between physical parameters, that is sea surface temperature. So to enhance the reliability of these findings, further research incorporating in situ measurements, extended satellite time series data, and detailed spatial analysis is recommended. And I'm thankful to Dr. Ayman Abdullah, the Director of Interdisciplinary Research Center for Aviation and Space Exploration, and my supervisor, Dr. Roman Schulz, for the sincere suggestions in this work. And it's all. Thank you very much. If I have any questions, please. Thank you very much.
So, due to the awarding ceremony, we request all the remaining presenters to proceed to room 101. As we near the conclusion of GiKS 2025 Day 2, we would like to take a moment to reflect on the incredible knowledge shared today. We will have a conference recap by Dr. Ali Al-Sheikhi, who will summarize the key takeaways from our discussions. Please Join me in welcoming Dr. Ali al-Sheikhi to the stage.
بسم الله الرحمن الرحيم الحمد لله رب العالمين الصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. I was really not expected to say anything in the conclusion. However, and I think the very first thing is the organization of this conference by itself is a goal. Why? Because we really want to share the ideas and the best practices together. We understand the efforts that are put in this important topic of environment and sustainability, because I think our very existence on this planet depends on these actions that we are going to apply and we are going to take. It will affect, I think, the destiny of this planet in general. So I think it was very important to hold this one in its second edition, the second conference and exhibition for green sustainable future in the Kingdom of Saudi Arabia. I was really very much pleased to see that there are really lots of effort is being done, whether in Saudi Arabia or even outside. The National Center for Vegetation Cover, the National Center for Wildlife, the National Center for Environment Compliance, some of the parks and geoparks, and really there are lots of effort that's being done, and maybe we don't know about it. I'd like also to reflect and thank very much the speech and the presentation by His Excellency Mr. Engineer Fahd al-Jubair. It was really fantastic. I didn't know some of the efforts that is being really conducted here in the Eastern Province, where KFUPM is, under the municipality. That is, of course, related to sustainability and weather, and so many really important projects in making the Eastern Province sustainable place, even a hub for sustainability in the kingdom and maybe even in the world. Lots of really important projects. So sharing these ideas and trying to apply some of these successful stories, I think is important. This topic of sustainability, as I can see, it is really a very wide and interdisciplinary in nature. So it is not enough that a certain region or even a certain country just will do a work here or there and you expect things will change. It's the world in totality. We should really work together to achieve all of these goals. That's why United Nations, you know that they have the 17th SDG goals that was, I think, launched or established 10 years ago, and the Kingdom of Saudi Arabia were one of the first countries to sign those. And this is, I think, all of those 17 goals are fantastic in trying to, for example, fight poverty, fight hunger, climate change, the life underwater, the life on land, clean energy, affordable clean energy, all of those. It's a nation wide initiative and importance. That's why it was adopted by even the United Nations. What I like the most about those SDG goals is the last one, goal number 17. Do you know what is it? Come on, we are about here sustainability. Somebody must know something. Huh? Partnerships. And this is why we have this conference. It's about really partnership, collaboration to achieve all of these previous 16 goals. I like really this goal number 17 very much. Also, one nice maybe touch that this conference happens when in this week that started here, at least Sunday, it was 26th of January. What is 26th of January? Anybody knows? It's also something by the United Nations. They declared this day to be the Clean Energy Day. And KFUPM took this whole week and did a number of activities. Maybe you did not participate, but there was the first 3 days, Sunday, Monday, Tuesday, lots of activity about clean energy. And I was really so happy that it was fully organized by the students. And it was not only KFUPM students. There was participation from the universities around us. There was, for example, energy-thon, debates about the energy and the clean energy, poster sessions. It was really amazing 3 days. I attended just few of them. I couldn't attend all of the activity. So this is also part of the importance of this sustainability across the world that, as I mentioned, that sharing these ideas and applying them together, we hope that we can achieve the intention of those goals, inshallah. But I said I didn't prepare anything, and I hope that there's that. At the end, I'd like really to thank all of you for organizing, for coming and organizing this event, this conference. Dr. Luay and his center, they really put a lot of effort. They were fighting, even to the last minute, about the organization here and there. And all, as I mentioned, the technical committees and other committees, the whole university in general, all departments in the university, security, housing, they really put a lot of effort into that. I'd like very much also to thank I know that many already left, but all those who attended those 2 days. Maybe I forgot in the opening, and excuse me for that, to thank the speaker. So thank you really very much for those who came from across the world or even from within the kingdom, and they participated in sharing these ideas with us. We hope that we can avail sometimes in the future to reflect on those ideas, and we do collaboration for the sake of our planet. And then we need really to have this quality life. And I want just to emphasize also one more thing. If the Kingdom of Saudi Arabia, its Vision 2030, by the way, emphasized the importance of creating economy or creating that balance, which is the growth of the economy, but at the same time with the responsibility about the environment. So they put this single statement, but it's very profound statement. And really the investment in the sustainability and the environment, I think it will have tremendous effect, even in the economy itself, by the way. They are even expecting that hundreds of thousands, if not millions, of jobs will be created if we really invested a lot in this sustainability and the environment in general. So the kingdom is put really a lot of effort on that. 2 main goals they put, but summarize even all the 17 goals, which is the first one, protect 30% of its life and and water by the year 2035, and at the same time reduce the carbon emission 30% also by the year 2040. Those 2, although they are only 2, but one way or another, it really cover all the 17 goals somehow. Of course, we put even bigger goals, which is achieving net zero carbon emission by the year 2060. And Aramco, even they put that Aramco company itself, they will reach the net zero by the year 2050. So I think there are lots of effort, and we need really to collaborate and partner together more for the sake of our future here, to have really a greener and brighter future for us and for our kids and for the humanity in general. Assalamu alaikum wa rahmatullahi wa barakatuh.
Please, Dr. Sheikh, remain on the stage. As we near the conclusion of GiKS Day 2, we will now proceed with the awardings. We will be honoring our keynote speakers and invited talks in appreciation of their valuable contributions. Now I will call the names. Excellency Fahd al-Jubair. دكتور طلال الحريجي. دكتور أحمد الغامدي. بروفيسور عبد الرحمن الليلي. مسز دنيا عبد الواحد. انجينير حسام تركي. دكتور سراب باندي. دكتور ماريسكا ويدرمان. مستر بارت روبينيك. مستر عماد أنصاري. دكتور هاريس أحمد خان. مستر محمد جاها. مستر جان فريدمان. انجينير إبراهيم صالح الزهراني. دكتور إيمان صباغ. دكتور تامن ميلوت. دكتور سوزانا كارفالو. دكتور مارك دايميك. دكتور ويل كوزين. Dr. Chico Perel. Professor Emmanuel Anner. Dr. Aman Singh. Dr. Abu Bakr. Engineer Omar Binayan. We will commence the much anticipated Posters Award distribution, recognizing the outstanding research presented during the conference. The best Posters Awards go to ريناد اليامي, محمد العطية, أرياف البقمي. Let's give a round of applause as we celebrate all our incredible speakers, participants, and organizers for making this conference a huge success. This concludes the Day 2 closing ceremony of GiKS 2025. Thank you all for your active participation and engagement throughout the sessions.